Welcome to this course on CompTIA's Tech Plus. I'm Andrew Ramdial, and I'm going to be covering every single one of the exam objectives in this course. This is the full course for the certification. Now, in this course, we're going to be learning a lot of things. We're going to be learning basic computing, things such as numbering systems. We're going to take a look at hardware, networking, software, and of course, IT security, which is actually the biggest section in the course. So with that in mind, let's go ahead and get started. But you know what, before that, quick introduction to me. I'm Andrew Ramdial, and I hold over 70 different IT certifications. I've been teaching IT programs for over 25 years to hundreds of thousands of students. And that's all you need to know about me. Let's get started. The first thing we want to talk about is going to be the actual Tech Plus exam objectives and what exactly is on this test and what can you expect. Well, first off, I want to mention the exam number. So CompTIA has the exam number as FC0-U71. That's important because when you're registering for the exam, you're going to need to know this number to ensure you're registering for the right exam. Now, where do you register for the exam? Pearson VUE. Go to VUE, that's Virtual University Enterprise.com. Type in the word CompTIA and you'll be able to register and take your exam. You can even take it right online. The Tech Plus exam is a 60-minute certification exam where you're going to have a maximum of 70 questions. So a little less than a minute per question. I've never really had any students complain that it's not enough time. Actually, it's more than enough time because the questions are relatively short and it's more of a knowledge-based exam. In other words, basically if you memorize all the different definitions, you're going to be able to pass. So it's 70 questions and it's a multiple choice. Now, you have to get 650 out of 900, which is about a 72% in order to pass. That's not a very high score, but it's not a very low score. I've seen certification exams where the scores were like 60%, but I've seen Cisco exams where you needed to score 80% to pass. This one, 72, seemed to be right there in the middle. So not too much of a high score. The exam is broken into 6 domains, and we're going to be covering every single one of these domains in this particular class. The first one, IT concepts and terminology. You just need to know basic things, like, for example, what is gigahertz versus megahertz and how do you measure things like that. IT infrastructure, this is going to be things like different kinds of hardware. We're going to take a look at different types of software development concept, like how software is programmed. We're going to take a look at what exactly is a database, for example. IT security is actually 19% of this test, making it one of the biggest domains here, next to infrastructure. So in order to pass, you're going to get these questions. You're going to get questions within these domains, and in order to pass, you're going to have to get about a 72% in order to pass your exam. Okay, so that is all you need to know about the actual exam itself. Let's get into the actual exam objectives now. Let's get started in section 1.1 of the course. This is called the basis of computing. In this section, we're going to learn about input, processing, output, and storage. Now, before I get in and cover all of those things, I want to just talk a little bit about this. This is a desktop, and throughout this course, a big portion of it anyhow, we're going to have to learn about different kinds of hardware, all the different things inside of here, the hard drive, the processor, the motherboard, the power supply, and so on. Throughout this course, I'm going to be explaining a lot of the different things that's in here. In fact, I might take it apart a little bit later in the course. So keep in mind, I'm going to be coming back to this. Now, what I did was to the side of this, I had a desktop like this before that I have taken apart. And here I have some of the main components that I'm going to have to be showing you guys as we go through this course. I'm going to try to keep this as visually appealing as possible. I'm going to show you guys anytime I could. I'm going to show you guys the physical aspect of things just to make it easier to understand. I think we all learn better by visually seeing things than just me having to explain it. Plus, when you see it, it just makes it a whole lot easier to explain it anyhow. All right, let's put this back over here. We'll come back to those things a little bit later, and we'll be taking this apart a little bit later. So let's get rid of this. Okay. Let's talk about these things here: input, processing, output, and storage. Now, realistically, it's an easy concept to understand because when you're utilizing a computer like I have here, here's my personal laptop, a MacBook. When you're utilizing a computer in particular, you have to input data into it. You have to tell it what is it you want it to do. Well, how do you do that? You can do that with a mouse. You can do that with a keyboard. Or as you can find on my laptop, you can do it with a touchpad, or you could do it with the keyboard that's on it. You also have processing. So when you input data into a computer, the computer has to process this data in order to produce some kind of an output. Why do we input data? Because we want a particular output. For example, you went online this morning or this afternoon, whenever you're watching this, and you inputted something, right? You search for something to find this course. Maybe you were searching for Tech Plus. Maybe you were searching for CompTIA. Maybe you were searching for things like a basic IT classes. So by you searching for things, you're inputting data. You went to YouTube, or you went to Udemy, or you went to my website, and you search, hey, Tech Plus, CompTIA Classes. You're inputting data from the keyboard itself. The computer then processes your request, and it outputs a screen that we get on here. It outputs this course that you want, the information that you're looking for. Now, the computer must have some kind of storage within it in order to process and then produce that data for you. So with that in mind, let's go in more depth into these particular terms here. So the first thing up I have is input. What exactly is input? Well, input is the data and the instructions that we enter into the computer. Basically, we're converting our physical human actions into digital signals that a computer can understand. The devices that does this is going to be, well, your keyboard, like I have here, right here, hard to see that. The keyboard, the mouse, you also have some devices like my tablet. There's also my tablet. Some devices works with touchscreens, right? Where's my YouTube? There you go. So some devices works with touchscreens, while other devices will utilize a mouse and a trackpad in order for it to work. You can also nowadays input information into a computer with a microphone. What do we mean by that? Well, nowadays you can actually talk to a computer and it can do things for you. And there's a lot of different software that does that, which we'll cover later on in the course. So we input information utilizing these devices, and then a computer has to process that information. Now, how does a computer process data? Well, it processes data utilizing a CPU, or Central Processing Unit. This is what performs the calculations and the instructions that you gave it. Now, where is it getting the instructions from? Well, it's getting it from the programs, the applications that we utilize. You see, when you go to something like a web browser, like maybe you're using a Chrome browser, you open up your Chrome browser, that has a specific set of instructions that has to be executed. It tells it to the processor then executes that instructions and displays it on your screen. I want to point out something to you guys, that processors are also known as the brain of a computer. And they're measured in what's called gigahertz, which we'll cover later in the course. If you're wondering, hey Andrew, what does a processor look like? Well, here's a computer motherboard. This is the main underlying component. In fact, if I take apart this laptop, you're going to find something similar to this, just a whole lot smaller. This is a motherboard from a desktop computer. And I want to show you guys what that processor looks like. The thing that's processing all of the information that's on there. So let's take a look at here. So you can see the processor is actually installed on the motherboard right there. I'm going to remove it so we can have a good view of it. All right, so this is the actual processor itself that processes all the information that we need out of our computer. Now, I'm not going to go into the specifics on this, as we have different videos coming up for that later on in the course. Now, they are measured in gigahertz. This is something that you're going to want to remember for your exam, but we'll cover more of this a little bit later. So the computer inputs data. We give it input. Utilizing a keyboard, for example, it processes the data in a CPU, and then it outputs the information on a screen. The results are displayed generally on a screen. It basically converts digital signals to human readable form. Humans can't really read digital signals, but we read what's on a screen itself. So the output converts that digital signal into things that we see, generally through a monitor. We can also hear it with speakers. And sometimes we may need to print something out, physically print it out, like a piece of paper, utilizing a printer. Now, I want to talk about, before we end this video, I want to talk about storage. When we're storing information, how does a computer store data? You have a computer, you have a laptop, you have a desktop. When you store information, it's basically stored permanently in your computer, right? Until you delete it. But where does it do that? Well, in order for a computer to store information, it's going to have to store it in what's called primary or secondary storage. So we want to understand the difference, primary storage versus secondary storage. Primary storage for a computer is the RAM. It's temporary storage. The secondary storage are hard drives or solid-state hard drives. These are generally measured in gigabytes or terabytes. We'll talk more about measurements though in another video. I want to show you guys what I'm talking about here. So let's take a look at this. Here I have a motherboard, but this motherboard has storage on it. Let's take a look at the overhead cam. Let's get rid of this. We don't need this keyboard. So look at what I have here. On this overhead cam, you notice that this is a motherboard and it has storage. Here I have a hard drive. This is a hard drive. This is known as permanent storage on your computer. It's called secondary storage and it's permanent, which means when you save data on your hard drive, this will be permanently stored on your computer. For example, maybe you download a song and you saved it on your desktop somewhere. Well, basically you're saving it here. The primary storage of a computer is this thing right here. This is the actual RAM chip on a computer. This is called primary storage. This is temporary storage. This is also known as volatile memory. Let me explain the difference here between the two. So primary storage, it's called primary because it's what the processor actually accesses. You see, a processor doesn't actually read from this hard drive. When you open up a document, when you go to a computer and maybe you had a document on your desktop, you downloaded something, when you open it up, yes, it's stored here. It actually leaves the hard drive through that cable, say the cable I have there, into this chip, the actual RAM, and this processor, which sits underneath this giant fan that I have here. This processor reads from the RAM. So the processor primarily reads from the RAM chip. This is why it's called primary storage. What the computer stores permanently is called secondary storage. That's going to be your hard drive. For your exam, make sure you understand the difference. Primary storage is your RAM chip. Secondary storage is going to be your hard drive. Another term I want to mention is something called volatile memory. The RAM is known as volatile memory. When you turn your computer off, you lose everything in RAM. This is non-volatile. You turn your computer off, it still stays here. So keep that in mind. Volatile storage means when you turn it off, you lose it. Non-volatile, you turn it off, you don't lose it, like your hard drive. So keep that in mind for your exam. All right, that was section 1.1. Let's take a look at this section now, 1.2, Notational Systems. Now, we're going to have to talk about numbering systems, of how a computer basically reads numbers. Or what exactly does a computer read? First of all, a computer doesn't read English like we do. A computer will read numbers. A computer is all about reading numbers, and it has a different set of notational systems that we want to talk about. Predominantly, a computer will read binary. You see, a computer basically can only read binary digits, and binary is a numbering system of ones and zeros. You're familiar with another numbering system we call decimal. This is the normal numbering system that me and you, we're going to be using to communicate. The decimal numbering system basically is what's called a base 10. It has 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 10 digits. So it's called a base 10. Anytime we say a base, it basically means how many digits this thing basically supports. So like a decimal is called a base 10 because it supports 10 digits. A binary is called a base 2 because it only supports 2 digits, 0 or 1. But the question is why? Why does a computer only reads binary? Well, the answer is because of this device, right? This little chip that I have in my hand here, right? So this is the processor of a computer. And this processor is made up of something called a transistor. Now, a transistor is basically, you can consider it basically like a light bulb. A transistor is either on or off, or it's either 1 or 0. And anytime you send data to a computer, the transistors on this processor is basically what's processing your information. How many transistors is on a chip like this? Well, believe it or not, it's in the billions. And the more transistors you have, the more billions of transistors that we have on a processor like this, the faster our processors will be and the more stuff you can get done on your computer. But for now, I want you guys to remember that binary is the language of computers. Computers only read binary because of that processor can only read 1s or 0s. Now, there are ways, and I'm not going to go into this, I actually covered this in A+, of how we can convert binary to decimal. There are ways of converting them. It's actually pretty easy to do it. Take my A+ class, I'll show you how to do that. You don't necessarily need to know how to do that for your exam, but each position represents a power of 2 is a little tip there. You don't need to know to do that for your exam. Just for your exam, just know what binary is. The next thing I have is another famous numbering system in computers, and that's going to be a hexadecimal. Hexadecimal is basically a base 16 numbering system. And you're like, how does it have 16 numbers? Isn't numbers 0 to 9? Isn't that what we have? Yes. But what hexadecimal does is that it adds in the alphabet of A to F. So you can see in this diagram here, on the left side of the picture, you see something like 6A, 2D, 3.5, 3.6, 6D. Those would be a type of a hexadecimal. So a hexadecimal could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Any of those digits would be considered a hexadecimal when it's noted as a hexadecimal. In other words, the system have to tell you that's a hexadecimal. Because if you say the number 1, the number 1 could be binary, it could be decimal, it could be hexadecimal. So you'd have to know that, hey, that's a hexadecimal of 1. The system would have to tell you, the software, the memory management software would have to tell you that. Now, a lot of times hexadecimals is going to be written like 0, A, 1, F. Something like that is how you're going to see hexadecimal. You can see it in that little diagram that I have there. So like the number A, there are ways of converting all these things back to decimal. So like a hexadecimal, A is basically a 10. FF would be 255 in hexadecimal. Hexadecimal is very common in programming and memory addressing. So if you do a lot of programming, this is something you're going to want to know of. The next one we have is, of course, the numbering system that we utilize in our day-to-day life, which is just decimal. A decimal numbering system basically uses the digits of 0 to 9. It's how we, as humans, will count. Now, the last one I want to mention is going to be an octal. This is what's known as a base 8. It basically reduces our numbering system, our normal decimal, from being a 10 to an 8. It uses 0 to 7. This is not very common in modern computers. It was mostly used back in the days, but not very common in today's world. But here's just a quick notation. 10 in octal would be 8 in decimal, 77. It's mostly sometimes used in file permission. I see that in Linux. So here's a little chart that I have here. And here's a cool thing. You don't need to memorize that. I'm just showing you guys in a decimal, like number 1, what it looks like in binary, what it looks like in octal, and so on and so on. You do not need to know how to convert decimal to binary, binary to hex, and all that. For your exam, all I need you guys to know is basically how those numbering systems are, or like what exactly are they. So if they give you 0A or AF, what type of numbering system is that? Well, that's going to be hexadecimal. If they say, well, what is octal? You're going to know, oh, that's a base 8. If they say decimal, you know that's a base 10. If they say, Well, binary, well, that's a base too. Things like that you need to know. Your exam is very simple, so knowing these things should make it pretty easy. Hold up. Did you guys click on that like button? And did you subscribe to the channel yet? Guys, it took an enormous amount of time and effort to put this together. I really hope you're enjoying it. It would help us. It would mean a lot to me if you can click on that like and subscribe. It would be amazing. Let's continue the course. When you work in IT, one of the most basic things to know is just how to understand data measurements and speed measurements. And in this video, I'm going to explain all of that to you. But let's start out with a problem. Let's say you go to fix somebody's computer and they tell you, I have a 250 gig hard drive. And somebody else tells you, hey, you know, I have a 1 terabyte hard drive. Well, the question is, which one is bigger? Is this one 250 times bigger than this? Or is this one actually bigger? Well, this one it says TB and this one says GB. So in this video, we're going to decode that. Now, before I get into this, I want to talk to you guys about, before we actually understand this, how a computer actually works. And that's going to bring me to a term I want to explain to you guys called bits. Bits and bytes. 8 bits is in 1 byte, all right? 8 bits in 1 byte. I want to explain that term to you. So, computer reads data in ones and zeros. Computer reads binary, only binary. But why? You see, the binary numbering system, you're accustomed, I'm accustomed, we're humans, we do the decimal numbering system, which is 0 to 9. There's another numbering system called a binary system, which is just ones and zeros. The reason why computers only read ones and zeros is because of this guy right here. See this? This is the CPU, or the central processing unit, basically the brain of the machine. This will process all of your information. Now, if I remove it, so we can, we'll talk more about this and how to install them and removing them in another video coming up later. So here is the CPU of the computer. Now, this CPU is made up of a component called transistors. In fact, transistors, the CPU is made up of billions, not like hundreds or 10 or 5, billions of transistors on this CPU. Now, when you think of transistors, think of a light bulb. Think of 1 and 0. All right, that's really what they are. And the reason why a computer only reads binary is because transistors are either on or off. They're either 1 or a 0. That's why computers can only read bits. Now, we don't actually store data in bits though. We store data in bytes. Let me show you exactly what a bit looks like and what a byte looks like. So here I open up Notepad. All right. You see this 1? That's a bit. You see the 0? That's a bit. A single individual character of 1 or 0 is considered a bit. But look what I did here. I put it 4 ones and I put 4 zeros. This is a single byte of data. All right, so keep that in mind. So 8 of these bits forms 1 byte. Now, that is generally the smallest unit of measurement. When we store data on devices like this hard drive is where you do your long-term storage on. All those pictures, those movie files that you download, your music files and whatever, all of that you're going to store on your hard drive. These devices store data in bytes. We generally don't store data in bits. We move data across the network. We move data across the different channels of the motherboard in bits. But we store data in bytes. So remember that. We store data in bytes and we move data. How fast we're moving data? In bits. You'll see that in the next slide. Let's just concentrate on bytes here. So let's go through this. So 1 byte is 8 bits, just 1 byte. A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. A giga is 1,000,000,000 bytes. And tera is 1 trillion bytes. Yeah, that's big. Now, so TB, GB, MB, KB. So in other words, 1,000 kilobytes is 1 megabyte. 1,000 megabytes is 1 gigabyte, and 1,000 gigabyte is 1 terabyte. That's another way of saying it. So watch this. Look at this hard drive. This hard drive is 250 gigabytes, right? So that's here. This is 1 terabyte. All right, so if you look at it this way, this hard drive is 1 trillion bytes, and this one here is 250 billion. So in other words, it takes 1,000 gigs to equal 1 terabyte. In other words, because this is 1 tera, this is 1,000 of giga, so this is 4 times the size as this. You got it? Let me give you an example. You see, let's say you download Blu-ray movies. A Blu-ray movie is 50 gigs in size. Big movie, right? 50 gigs. You can store 5 of that here. You just store 5 Blu-ray, this would eat up this whole hard drive. But this one here can store a lot more. In fact, it can store 4 times more. It can store 20 of those Blu-ray movies can fit on this 1 terabyte drive. Get the point? So terabyte is 1,000 gigs, right? And 1 gigabyte is 1,000 megs, and so on and so on. So make sure you understand this measurement on here. Now, I want to point out a couple quick things. Number one, file size, storage capacities, generally we're going to utilize them in bits. Now, the other thing I want to point out here to you guys is going to be, I got some quick examples of things if you're wondering how files are stored. For example, like a little text document like I had here would probably be 10 to 100 kbs or kilobytes. A photo, 1 to 5 megs, like especially if you take something with your phone. My phone does about 4 megs. A song, like an MP3 song, could be 4 megs, 5 megs, 6 megs. A movie, 1 to 5 gigabytes, like a Blu-ray, though, super high definition, though, would be, I told you about 50. The Windows operating system that we're going to be installing later on in this course is going to be about 30 gigs. Now, the hard drives themselves comes realistically nowadays, in modern times, they come in rated in terabytes. So you can buy, this is a hard drive, not a solid state drive, a hard drive. 1 terabyte, 2 terabytes, 4 terabytes, 10 terabytes. I just bought hard drives that were like 20 terabytes or something. So they come really big nowadays. We do have another brand of these things, another form factor, I should say, called solid state drives. This one here is 1 terabyte also. This is a solid state drive. So that's how it comes. This is a solid SSD solid state drive. This is referring to this. This is a 1 terabyte solid state drive. Now, the other thing I have here that I want to mention to you guys is how fast data moves across the network. And that we're going to use something we call BPS, or bits per second. So we store data in bytes, but we transfer data in bits. Now, I want to point out something. I want to mention something before I go into that. The unspoken rule. It's not a rule that everybody follows, and technically you don't have to follow it, but what almost all IT does is big B and little b. Okay, so let me show you guys something. A lot of times when you see data, you might see something that looks like this, and then you might see something that looks like this. You see this big B, it generally refers to bytes. And when you see a little b, it generally refers to bits. All right, if you look at this hard drive, you'll notice it's not a small b, it's a big B. This tells me that this is bytes. All right, so this is 99% of the time. When you see little b, think bits. When you see big B, think bytes. Remember that. Now, how do we measure speed? Well, speed is measured in bits per second. So it's transferring one of those ones and zeros. It's transferring one of those ones and zeros, just this zero here, per second. So if you had 1 bit per second, it would be that one single zero going across the network in 1 second. That's really slow, actually, because in reality, we measure them nowadays in kilobits per second, megabits per second, gigabits per second. So for example, if your network at home, maybe you have an internet connection at home that is measured at, let's say, 500 megs per second. All right. 500 megabits per second. All right. Megabits per second. So what that means is you're moving 500 million ones and zeros every second across that line. Is that fast? Yeah, it sounds fast now, right? That is pretty fast, actually. My house, I have an internet line from the Verizon Fios that is 1 gigabit line. This allows me to move 1 trillion ones and zeros across the line every single second. So every second that goes by, I just moved 1 trillion of those ones and zeros. Isn't that crazy? You guys ever thought about that, right? That's crazy, right? If you think about how fast that is. Technology is amazing. Now, I want to point out, you notice these are all small bits. Bits, they're not bytes, they're bits. I'm going to give you guys an interesting thing here in a second. Stay with me, this gets more interesting. Now, the processor. Processors are measured in what's called hertz. All right, so by the way, when you see Mbps, kbps, gps, that's generally referring to things like USB speeds, Wi-Fi speeds, sometimes even your RAM speed, your internet speed is what you're going to see utilizing these kinds of measurement. Your processor is going to be measured generally in what's called a hertz. Hertz means cycle per second. The more hertz you have, the faster your processor. Nowadays, processors are measured in gigs. So you're going to have a processor that's 1 gig, 2 gig, 3 gig, 1.2 gig, 2.5 gig, 2.6 gigs. The higher the hertz, the higher the more hertz you have, the more cycle per second you do, the more transistors are here, the faster your processor. So this means cycle per second. All right. There's a couple of quick things here. For example, USB speeds, like if you do USB 3.0, they may say you're moving 6 gigabits of data. So that would be this one here, 6 gigabits per second. Wi-Fi, I connected this morning to my Wi-Fi. I had 300 megabits per second connection. RAM speeds, you can see like this here on this RAM stick. They're going to tell you how fast these sticks are. We'll get more into this, depending on how fast they are on this, like 5400 hertz on that. You have internet speeds, I mentioned, at a 1 gigabit BIOS line. Now, I want to mention something here, something that you guys should understand. So, really quick review here. Number one, bits is generally what we're going to measure with speed. Bytes is how we store data. 8 bits in a byte. All right, now, here's something interesting. Let's say you have an internet provider line with 300 megs, right? Your Verizon, your AT&T is giving you 300 megabits per second. And you want to download something. Let's say you want to download a 300 meg file. You want to download a 300 megabyte file. Okay, keep that in mind. 300 megabyte file. So that is megabyte, but the line is rated in megabits. 8 bits in a byte. Remember that part? So that's megabits per second, not megabytes, right? You notice the tiny b. So your actual download speed is, you're going to download, take your megabits and divide it by 8. You're downloading 37 megabytes per second. You guys understand that? So here's why that's important. So let's say 300 megabytes, and you want to download a file, all right? You want to download a 100 meg file. And you're thinking, well, I do 300 of this, I should do that in a third of a second. Actually, no. You're actually going to be downloading at 37 megabytes per second. So it might take you 2 to 3 seconds to download. So that's something you got to understand, that because when you go to download a file, the file is rated in bytes, but you download in bits. If you ever want to get your true, how much megabytes can I download for real? Just take the megabits and divide it by 8 to get the megabytes that you can actually download. Hopefully that's not too confusing. That's just the way IT works. It's the way we do things. A couple of quick things here on speeds. Remember, your CPU is measured in gigahertz, generally speaking. That means, remember, a giga is a billion. So this CPU will do, I think this is a 2 gigahertz. This will do 2 billion cycles per second. Your RAM, you do have RAM speeds. We'll talk more about this, but they're measured in hertz also. Storage speeds. Lots of different storage speeds out there. We're going to go through a lot of these coming up later, how fast they are, how much they can store, and how fast they can read, write too. All right. That is the lesson on this. This is really important you guys understand how we measure things, because how we measure things is how we can determine their performance. One of the things that you're going to be tested on is known as the CompTIA Troubleshooting Steps. This is something that I want you guys to remember. Memorize these steps the way you see them in the order that they're in. They're probably going to ask you a question that they're going to tell you, like, this happened, and then you're going to have to say, well, this is what I should do next. They may say, well, you have tested the theory what should you do next? And then you should establish a plan of action. Or they may say, well, you've already identified the problem. What should you do next? Then it's establish a theory of probable cause. That's how you're going to be tested. You're going to have to memorize these steps in order before attempting your exam. Let's get started. So the first thing up is I want to mention to you guys is let's go through the steps. There are 6 steps in particular that we want to go through. Number 1, identify the problem. So let's start out with this. You're a technician. You're working at a help desk and a user calls you up and says, well, I can't access this file on a file server. That's a problem. These steps are there to tell you how to solve IT problems, whether it's a person can't access a file, they can't access the internet, their computer doesn't turn on, it doesn't matter. Let's just say a user calls up the help desk and says, hey Bob, I cannot access this file. Okay, what's the first thing you're going to do? Well, the first thing you guys have to do is to identify the problem. You got to ask a bunch of questions. You got to gather this information from the user by asking specific questions. Things you're going to ask for is, okay, can you access the internet? And that's an important question, because if they could access the internet, it means that their network connection works. If the network connection wasn't working, they couldn't access the internet. If they said no, they couldn't access the internet, then you say, can you access any other file server? Can you print to the print server? You try to gather as much information because you want to determine the scope of the problem. Is it just the file server, or is it the entire internet connection, network connection is down on this particular user's computer? So that's what you're going to do. You're going to ask a very specific question. You're going to ask about the symptoms, things like when did this start happening? Were you able to access the file server yesterday? That way, maybe something happened overnight. Could you have accessed it 2 weeks ago? When was the last time you accessed it? What did you do the last time you accessed it? Has anything changed on your computer? Did you install any kind of software? Did you change a setting, for example? These are questions you're going to want to probe the user in order to understand what happened to this machine all of a sudden. Next thing here we have is going to be establish a question, a theory of probable cause. Question the obvious first. For example, do you have permission to this? Did you access this before? Did you request permission to this? Things like that. Consider the most likely explanation and don't overlook this simple stuff. There's something in IT we call the super simple stuff. You know how many users overlook that? So consider the most likely explanations and don't overlook simple solutions, because let me tell you guys something. Sometimes it's the most simple things that solves problems. You'll be surprised to know how many times rebooting a machine or just logging the user off and logging them back in solves most of the problem. So what we're going to do is we're going to question the obvious first. We're going to say things like, hey, did you try rebooting this machine? Did you ask other users if they can access the file server? Did you access the file server yesterday? Keep asking users, but what you're trying to do is you're trying to come up with a theory of probable cause why they don't have access to the file server. Consider the most likely. It could be that the user just never had permission. So let's say the user comes back and says, well, I never accessed the file server before, and my boss said I was supposed to have access to it, so that's why I'm trying to access it. So the most likely explanation here is that the information security didn't give this user the rights that they're trying to access. That's why they couldn't get it. How can you verify this? Maybe you should ask the user if anybody else can access it, because if anybody else can access the file server, we know that the server actually works and it's just for them that's having a problem. So don't overlook simple things like asking the user if anybody else can access this particular server. Now, with number 2, just a little sub-bullet point to number 2, 2.1, is when you have problems that you can't solve. Maybe you may have a computer that's slow. Maybe you have a specific error that the computer is showing. You may want to check the internet. Search the internet. Google the error code is one of the most famous things I would do. Sometimes you have internal documentation. If it's an internal piece of software or proprietary piece of hardware you're working on, you're probably going to have to Google it or check their internal knowledge base for it. And one of the best places, so like if you have a problem with like a motherboard like this, sometimes the best way to solve problems with specific equipment like this is by checking the vendor website. So I can look at this motherboard and I can see that this motherboard take this wire, take the SATA cable out. I can see that this motherboard is a ASUS motherboard. And because I can see that, I can just go to the vendor website and try to get information from it. Generally, most common problems is going to be on that particular website. The other thing here we have, number 3 now, step 3, the other thing we're going to do is test the theory. So let's go back to this user that can't access this file server. What we want to do is we want to test the theory. We want to verify that you suspect this is causing it. You want to do as much testing as possible and eliminate variables one at a time. So for example, you want to test that your theory is this user doesn't have access. He doesn't have the right permission to access the files. So what you should do is you should maybe log in and try to access it and read the error message. Generally, when you don't have the right permission, it's going to tell you access denied. So you should see if that's true. You want to eliminate one variable at a time. Maybe you want to access the internet to see if you could access the internet. Maybe you want to ask users if they can access it also. Try to eliminate. Is it the network? Is it the file server? Is it the user permission? Is it the switch? Is it the router? Things like that. You want to eliminate one thing at a time. The next thing here you're going to do is establish a plan of action. Create a step-by-step solution plan. Maybe a step-by-step plan for you now is to contact information security, verify the user should have access, and have them provide the access. Consider the potential risks. If you contact information security and maybe you're the one that's going to help them get access, you might be giving access to somebody that shouldn't get it. Implement your solution carefully. So what you want to do is create this step-by-step plan. You want to make sure that, you know what, let's get this solution implemented and verify that the system is fully functional. So now that you implemented your solution, maybe you called information security, and security is like, okay, we gave the user access. Now what you want to do is you want to log back in to that user station and verify that they could access the file on the file server. You want to ensure there's no other new problems and check anything related to the file server. Maybe they're required to print. Check that they can print. Maybe they're required to edit the files. Check that they can edit the files, for example. The other one here you're going to have is, let's call this 5.1. Implement preventive measures. So what you're going to want to do, this is part of step 5, what you're going to want to do is set up a monitoring. Create a procedure to prevent this from happening again. What you want to do is you want to inform the user that, hey, anytime this happens again, before calling the help desk, maybe you want to verify with information security that your permissions was applied. Maybe if you're fixing a computer that's really slow, maybe you want to tell the user to try rebooting it. Maybe you want to tell the users, hey, don't install software that you're not familiar with if there was a machine with a virus. If somebody calls and said that their machine doesn't function and you came to realize it was a virus, maybe to prevent it from happening again, you may want to train the users not to click on random links. Now, finally, the last thing here, guys, is going to be to document your finding. Document this. Generally, most help desks will have some kind of knowledge-based system or ticketing system that they store these tickets in. That way, they can track how many problems they had and how many problems they're actually solving throughout the day. So we're going to record our lessons. We're going to document our actions. We're going to note those final outcomes. So this is important. Most companies will make it mandatory that you document your finding. Now, I want to go back to this here before we end this video. And I want to make sure that you guys understand it. Let's go through another problem. I went through the one about the file server. Let's just do a simple one. Let's say a user calls up. I'm going to tell you, we know the problem already. Let's say a user has a virus and the computer is very slow. It's acting all weird. So the user calls up and says, oh, my computer is very slow. What should I do? Well, the first thing we want to do is we want to identify that problem. We want to verify if it's actually slower. That's just how it works. Ask the user all types of questions. When did this start happening? How do you notice it's slow? They may say, oh, well, when I open Word, it takes long, or every website is slow. Ask them, is it just one application that's slow, or it's every application that's slow? That way you'll know, you can isolate it. Is it just that app is not functioning, or the whole machine? Let's say the whole machine is not slow. Establish a theory of probable cause. Now you're probably thinking, well, maybe this person has a malware on the machine. So you log into the machine and you start testing things, right? You come up with a thing, you say, okay, well, maybe they have a virus. Test the theory that maybe they have a virus. Maybe you check the malware and you realize the anti-malware isn't updated. Well, that's not good. So let's put a plan of action. Let's get the anti-malware software updated and clean the machine of a virus. Let's verify the machine fully functions, it's back and it's fully functional and it's fast. And then we want to document that Bob machine has gotten a virus. That would be step number 6. This is a guaranteed question on your exam. It's guaranteed that you guys have a question like this. So what you guys want to do is you guys want to make sure you know these steps really well for your exam. On this desk, I have the 3 most common computing devices. And that brings me to section 2.1, common computing devices. And on this desk, I have the 3 most common ones. I have the thing that people spend probably way too much time on, their phones. The thing that I probably spend too much time on, my laptop. And the thing that some of us probably spend too much time on, our bigger phones, our tablets. Let's get started in this section as we're going to go through some of the most common computing devices that are out there. Now for your exam, you just want to be able to explain these devices. You don't have to go in and know how to configure them or set them up or anything like that. Let's go ahead and get started. So the first thing up I want to mention is going to be the thing that most of you guys probably spend too much time on, is going to be a smartphone. Now, smartphones, whether you're an Android user or you're an iOS Apple user, these kinds of devices are basically mobile communication devices. There are tons of central processing being done into these phones, so they're incredibly capable in a pocket-sized device. They have lots of functionality, and they're basically full-fledged, basically what we used to have in desktops nowadays, as basically almost everything I can do in a laptop or my desktop, I can basically do in a smartphone nowadays. Another thing you have is basically a tablet. Now, a tablet basically mirrors the functionality of a smartphone, but it's something that is just bigger. It's basically, this is a Samsung phone and a Samsung tablet. And trust me when I say, this is really just a bigger version of this. Like, everything I can do here, I can do here, and everything I can do here, I could do here. This is just a 10-inch display versus this 7-inch, 6 or 7-inch display that I have here. They're really lightweight, they're portable, and one of the best reasons why I use my tablet is for media consumption. In other words, I'm going to use this tablet in particular for more like watching YouTube videos on it. Now, the other one I have, and I have one of these things here, is an e-reader. E-readers, like the Amazon Kindle devices, are done with what's called e-ink. In other words, they're basically a little bit bigger than my phone here, and basically they're meant for reading text on. When you read text on a screen like this, technically the light can hurt your eyes, but when you read on a e-reader that's utilizing what's called e-ink, basically it looks exactly like paper. Now, these things have incredibly battery life. The battery life goes into the weeks, not the days like this or one day. And they're basically easier to read on than these kinds of devices. A lot of these e-readers will also come with a backlight, so you can actually read them in the dark. One of the most famous computing devices out there is, of course, going to be a laptop. This is going to be your personal computer. Your laptop is going to mimic everything you're going to do on a desktop, except that it's more portable and you can take it with you. Almost all laptops, including mine, will come with a built-in screen, keyboard, battery, mouse, and so on. They're a good balance of performance and mobility. Keep in mind, laptops will generally never be as powerful as the equivalent desktop for the price. For example, if you go out and you purchase, like I have on the floor here, this desktop, and you spend $1,000 on it, you will get a lot more performance than if you was to buy a $1,000 laptop, because the desktop can hold more components. It can cool the components better. Cooling becomes a problem for laptops as computer components does get hot. And for it to cool it, they may have to install fans, and them trying to keep it small generally reduces the processing capabilities of it. Workstation PCs, like I showed you guys here on my desktop. Now, a workstation is a very particular term in the business world. In the business world, we use workstations to get tasks done. But a lot of times when they say the word workstation, they're referring to a very specialized business computer that's going to be used in order to do specialized tasks like graphics design, making movies, drawing architectural plan. Workstations are generally really powerful desktops that they use to do things like create video games or make a giant plan to build a giant building. They're high performance, specialized computer. They're going to be doing really demanding tasks like making a video game, not playing video game. They're beyond that. They're much more powerful than that. A high-end workstation in a business can cost thousands and thousands of dollars. Like, it's not uncommon for a high-end workstation to cost $5,000 and utilizes very specialized graphics processing units in order to produce the task or do the task that is needed. In a business, you're going to have servers. You see, in a business, they need to share data amongst all the computers in that network. And the computer that's going to be sharing the data and processing the data for all the computers in the network is going to be a server. Servers comes in all kinds of configurations. Some of them looks like desktops, like I showed you guys, and some of them are rack mount machines, like I have in this picture here. Rack mount machines goes into racks so they can stack servers on top of servers. Now, the entire world runs on servers. If you're utilizing something in cloud computing, which we'll talk about later, that all runs on a server. You go get a web page, it's coming from a server. So businesses have servers to serve up information on that network. It provides services to other computers. They're generally highly reliable and they're made for performance and they're not cheap. They run services and applications for a network. Now, I'm a gamer. I don't know about you, but gaming consoles are very specialized, basically computers nowadays that basically are designed to run video games. They're optimized for video games. They come with very specialized cards, motherboards, and processors. They're connected to a TV or monitor in order to play video games. Think like your PS5 or your Xboxes would fall into this category. Virtual reality systems. So things like Facebook or Meta headsets, these kinds of devices gives you a 3D experience. It's something that you put on. They have controls that you can see there. You mount the displays on top of your head, basically, and you look through lens and you can go into a 3D world. This is mostly done for gaming. I know my son has one for gaming. It's also going to be used for training and simulation. People utilize this to train people, like flight simulations, driving simulations can be done with these virtual reality systems. The other one they have is what's called augmented reality. Now, this is a little different. So in a virtual reality system, when you put it on, it immerses you completely with this cartoonish looking virtual world. But when you're looking at augmented reality, basically you can see the actual surrounding and then it just places different kind of objects in front of you. It overlays digital information on the real world. So you would put on an augmented reality or AR glasses and you can then see different characters or objects in the surrounding environment with you. Smartphone apps or specialized glasses does this. This is basically it's an enhanced virtual reality, like it brings a gaming aspect to the real world. Now, let's go into something we call IoT. The next set of things that I'm about to mention, and I'm talking almost all of these things here that I'm about to mention, is going to be IoT devices. So let's go into that. IoT means Internet of Things. And if you think about this, right? Tell me what doesn't connect to the internet nowadays. Think about that. What doesn't connect to the internet? Almost every single thing connects to the internet, right? Your game system, your TV, your car, your thermostat, your bed, your watch. Does your shoe connect to the internet? Maybe there's a shoe, I'm not sure. Everyday objects. So the word IoT means Internet of Things. It basically means all devices and many different types of devices and things are connected to the internet nowadays, allowing them to send and receive data, and you can also control them also. So one of the most common ones is going to be a home appliance. This is something that I've seen more and more common. People are connecting their refrigerators. There's a Samsung refrigerator I saw with a with a big tablet inside of it, washers and ovens. They connect to your home network, and you can connect them to apps so you can check if your fridge is at a certain temperature. You can also monitor and control these particular devices that are there. Another one is going to be this category of home automation. All right, these are devices that help automate your home, things that make your house more computerized, more automated, more functional, I should say. What are some examples of home automation devices? Well, let's go into it. One home automation device is like a thermostat. I have one of these. I have the Nest, that exact thing, the Nest thermostat. This allows me to, this is installed at my house, so I can open up my phone and I can go to my Nest thermostat, and you guys can see that my house right now in the living room is at a cozy, is it going to show you? Yeah, it's at 68 degrees. I can then go in here. Oops, I turned it off. I can then go in here and I can change the actual temperature in my house. My wife is home. I don't want to make her too cold or too hot. This can automatically control home temperatures. It learns your preferences. It does. It learns your preferences and ups it as needed. And of course, I can remotely access it. Another one is going to be in the home automation category is going to be the security systems. A lot of times you may have a security system such as ADT and all these other vendors that produces alarms and camera systems to keep an eye on your house when you're not there. They're used to detect home intrusions or burglars coming into your home, and can send alert to your phone and even put on different alarms. Home assistants, maybe a lot of you guys have this, and I have one of these in my bedroom. I have one of these Google Home devices in my bedroom. And these home assistants are voice control. So when I wake up in the morning, I'll say something like, "Hey Google, what's the weather today? Hey Google, what's on my calendar?" It actually connects to the thermostat. I'm like, "Hey Google, turn the temperature to 70. So now you can start talking to these devices in order to get things done. Another one, you have a smart door lock, and I also have one of these. A smart door lock allows me to lock my door, open my door with an app on my phone. This is an electronic device, an electronic lock that you put on your door. It connects to the internet, and then I'm able to connect and control that lock from my phone. So it basically is an electronic lock with a remote access. I can tell you when my door was open, when my door closed. And let's say I have a visitor at home, but I'm not home. I can just open the lock for them. I can even give them, it does have a keypad on it. So what happens is I can then send them a code, a temporary code, and they can open the lock with it. Highly functional. Wasn't that expensive, about $150. Video doorbell. One of the most famous one of this is what's called a Ring doorbell. That's what you see there. The Ring doorbell, I don't have this one actually. The Ring doorbell is a camera doorbell. Basically, you walk up to it and it takes videos of people coming up to your door as a built-in camera. You can see and speak to visitors. So for example, somebody can ring the doorbell at your house. You can get it on your phone. You can see them and you can talk to them through your phone, and it's good for security purposes. Now, the next thing I want to talk about are other connected devices that are out there. Those are all the home automation. What are some other IoT devices? Well, one of the most common IoT devices that we have now in particular is going to be all your connected cars. It's cars connected with internet connectivity. You can do things like remotely start them, diagnose them, and even do over-the-air updates. And one of the most popular for this is going to be like the Tesla electric cars. But I bought a Toyota SUV for my son, and his car comes with an app, the Toyota app, and he's able to remotely start his car, check the diagnosis. I have the app on my phone. I can tell you where he is right now, where that car is at all points, and even how fast he was driving. So even our cars are connected to the internet nowadays. IP and security cameras is of course going to be important. I have a home, a network connected, what's called a network connected camera system. And what this does is this allows me to log into a camera system at my house and see all the cameras that are surrounding my house. This is good for remote surveillance. I can see it over the internet. It does detect motion and it records throughout the day. So it's basically a network connected surveillance system. This is Different than back in the days when there was no network connected surveillance system. You had to be in front of the camera to watch it. The other one you have is a streaming media device. Now, this is, of course, really famous. A lot of us have the Roku, Apple TV, Chromecast. I have the Amazon Fire Stick. I use that a lot. This allows me as a streaming media device. This allows me basically to connect it to my computer so I can stream YouTube or Netflix directly to my TV. A lot of TVs actually has this built in nowadays, but you can also buy a particular, like a Fire Stick, Amazon Fire Stick, or a Roku or Apple TV for this. What's new and coming into the market a lot more is going to be medical devices. Devices that you can track with an app. I see this with people putting glucose monitors on their arm to track their blood sugar levels utilizing an app. It also allows doctors to check how a patient is doing, especially if you have heart issues. They can install a pacemaker, and this here can help track the electrical activity in the heart, and your doctor can monitor your heart from far away. So really interesting thing. This is becoming more and more popular. The other one here is going to be exercise equipment. Treadmills, bikes, weights. I once bought a treadmill a while back. As you can see, I'm not using it much. I should use it more. Treadmills now connects to the internet. I have an app on my treadmill that I connect to. It tells me how fast I was going, how much I did this week, and so on. This, of course, is getting more and more popular. Treadmill, bikes. I'm not sure about weights, but there are different versions of that does do connections. The other one I have here is going to be a wearable device, and you can see I have one on. This is the Samsung smartwatch. So smartwatches, fitness bands, and smart clothing. This is what you wear on your body to do different types of health and fitness tracking. Like this tracks my step, it tracks my heart rate, it tracks my sleep, all in this device here. Okay. Quite a lot of things here in 2.1, all of these different devices. For your exam, you do not need to be able to configure those things, change them, manipulate them. All you have to know is know what they do. They're pretty simple to understand, as most of us have probably interacted with most of these devices. So this section, not that complicated, just know what these computing devices does. In this video, we're going to be taking a look at sections 2.2 and 2.3. I'm going to cover this in two different videos. The first one I'm going to do is I'm just going to explain the exam objectives to you while giving you guys just a brief hardware overview. The next one I'm going to do, I'm going to combine these two sections because technically they should belong together. And then I'll do a nice overview and really go more in depth into the hardware that you should know as a technician. So it's going to basically be two videos that's going to really explain 2.2 and 2.3 because it's in these two sections that you're going to learn a lot about hardware. Let's get started. So in this section here, starting out, I'm looking at the first thing up we're going to learn is a motherboard. We're going to talk a little bit about the BIOS, the RAM, CPU, GPU, storage, hard drives, and NIC cards in there. So let's go ahead and get started on this. The first thing I want to mention is going to be your motherboard. So your motherboard is, of course, the device where everything is plugged into. It's in this device here that we're going to put our processors in, our RAM, our expansion cards, our hard drives are also going to connect onto these motherboards and so on. So everything plugs into it. It's the main board of the computer itself. Connects all components, ports, slots, and connectors. The overhead cam here is a motherboard that is fully connected. It has its CPU inside. It has its RAM. It has a hard drive connected to it. Right here, we do have a graphics card that I can install right now on it. It also has a wireless NIC card. Here's a wireless NIC card that I have. We're going to mention that in the exam objectives in a minute. That I can also install. So this one here is a complete motherboard. So what is the motherboard? It's where everything is going to connect to. The next thing is we want to mention is our firmware. So the word BIOS, it stands for Basic Input-Output System. The BIOS is a piece of software that lives on a chip, a particular chip. This chip right here. This chip right here. You see this chip right here? This little chip? This is called your ROM chip. And on the ROM, you have your BIOS. This basic input-output system. It's basically the firmware of the device. Now, what exactly is this software? This is a piece of software that controls the hardware. It's the layer between the operating system Windows and the hardware itself. So imagine your hardware, all your hardware. The BIOS, this software, is what's actually connected to this hardware, and then Windows connects to this BIOS. So Windows is basically going to come to the BIOS, that low-level software that's stored on that ROM chip to talk to hardware. You can see your BIOS. You can actually put on your computer, and if you put on, like if you have a desktop, it may say something like press F1 to enter setup, or press delete to enter setup, and then you get this program. Sometimes it looks like this. This is an older one. Sometimes it may look, you have a mouse, you can move around things. In the BIOS, you'll be able to enable and disable hardware. Like you can enable and disable ports on a motherboard. You can up your CPU, you can change your CPU setting, change your RAM setting. So a lot of hardware configuration is done there. It also does things like load your operating system, provides hardware configuration, and it even can test components. Generally, when we install new components, like you put a brand new hard drive in, you put more RAM in your computer, you go into your BIOS to see if those components are working. RAM, random access memory. Where is my RAM chip? Right here. Random access memory. This is temporary storage. The random access memory is for all your active programs. All active programs is stored here. This is faster than a hard drive. Now remember, I think I mentioned earlier already, your CPU does not read directly from your hard drive, right? That cable is plugged into that hard drive on the desk. It reads from the RAM. So why? Because the hard drive is very slow, while the RAM chips are very fast. So the more RAM you have, the more programs you can have open. It is considered volatile. We'll talk more about that coming up a little bit later. Now, your CPU. Where's my CPU on my desk here? I have a CPU somewhere that we have probably lost. Where the hell did I put my CPU? You see what happens when you film videos, guys? You have everything when you need them, and then you start the video, it's hiding under the heatsink. This is the CPU, the brain of the computer. It executes program and instructions, performs all the calculations on the machine. This is what we would consider the brain of the actual computer. Every single computer has some kind of a CPU or not. This here is going to be your CPU socket that we're going to be using to store the CPU. Now, the CPU is protected by something we call a heatsink, and I'll talk more about this when I do the other video where we talk about how to cool our computers. The GPU. So I have a smaller GPU here. I will be building a gaming machine. I'm going to show you guys that video. That's going to be the next video I'm going to be doing. I'm going to show you guys the actual gaming component. But here is a smaller GPU. So this has got dedicated graphics card. So GPU stands for Graphics Processing Unit. Generally speaking, if you play video games or you're into design and you do like architectural design or like you build video games, you need to have a dedicated graphics processing unit. And that's what this is, a dedicated graphics processing unit. This here is an expansion card that fits onto your motherboard. Now, these types of GPUs in particular are, sometimes they're cheap, a couple $100, to very, very expensive, to thousands and thousands of dollars. In fact, some of these GPU like this one here, like a 5060, this probably is about $300 to $400. You have other cards that's going to go up $50,000, $90,000 to $3,000 cards. Generally, this is going to be used for when you're playing video games. Now, the separated cards, like this is a separate GPU card. These are going to give you high-end performance games, think video games, graphics design. But a lot of motherboard comes built in with a graphics. You see how this motherboard has a port for a VGA, a DVI, and a HDMI port? You guys see that? So this one has a built-in GPU. Not every motherboard has built-in GPU. In fact, some motherboards, you will need to purchase a dedicated GPU. Now, where do we store data? our storage on our computer. We're generally going to store data either on a hard drive, like I have here. You can store data on a hard drive. You can store data on DVDs or CDs. This is going to retain information, permanent storage. A NIC card. When you build computers, when you're utilizing a machine, you're going to have to connect to the internet at some point. How are you going to get internet access? Well, for that, you're going to have a network interface card. This is the card where you're going to plug in the network cable into it. Most of these motherboards will have an integrated NIC card. You see how this port here, this thing that looks like a telephone port, that's where you would plug in your network cable so you can have internet. This here is an integrated card. This allows you to connect to your network, handles all your data transmission. Now, these cards, when you're looking at a network interface card, there's wired and wireless. The one I showed you on the motherboard is a wired card. This one here is an add-on that I can add on to a motherboard that gives me wireless access. So you have wired connection, wireless access connection. Most desktops nowadays comes built in with both wireless and wired. Older desktops, like this one is an older desktop motherboard, you had to buy an expansion card. And that's what I wanted to tell you guys about these onboard versus expansion. So like this one has an onboard NIC card, and then you have an expansion wireless NIC card. Nowadays though, once again, most modern motherboards, like I have this motherboard that I'm going to be using in my A+ class. This is a motherboard that I'm building a gaming PC for. You'll see me build parts of it, and I'll show you guys the parts in the next video. But this one here comes with a Wi-Fi integrated card. All right, so this one comes with that box. We're going to set that up in A+, but I'll show you guys parts of it in this course. So remember, onboard means it's built into the motherboard. Expansion means separated. You can have onboard GPU, you can have separated GPU. So this motherboard has onboard GPU, here's a separate GPU. You have onboard NIC card, you have separate Wi-Fi card. Keep in mind, some motherboards will have more than others. Generally, the more money you spend, you probably get sometimes less on the motherboard. Let's take a look at sections 2.3, because we're combining them two here because they're really all about hardware per se. Now, I want to start out by talking about volatile versus non-volatile, different types of storages that we have. And remember, we're going to do a dedicated video that I really want to explain all these components to you. So we're just going to briefly mention them, and then I'll show you guys the actual components later on. And then we'll finish it off by talking about storage. Let's get started. So something that's really important for your exam in particular is volatile versus non-volatile storage. All you have to know for your exam, guys, is volatile storage needs power, persistent power to hold that memory. Non-volatile doesn't need any power to hold its memory. A good example of this is your RAM chip. Your RAM chip on your motherboard, like I have here. Your RAM chip on your motherboard needs power. I'm talking power from the wall, by the way. If you shut off the power, everything is lost in the RAM chip. Versus your hard drive, this doesn't need power, guys. This doesn't have power. This is just a data cable. There's a power cable right here, but you can unplug it. You can turn your computer off, and you're going to still have data. Keep in mind that things like your ROM chip is non-volatile. Your storage, your disk drives, your solid-state drives are non-volatile. Volatile memory is basically your RAM chips, all right? Let's talk about local storage. How are we going to store data locally on our computers? This is going to be because you could store data across the network. You could store data in the cloud, but we also store a lot of data on our normal computers. And there's a few different components in this on a computer where we store data. Let's get into it. The first one up is going to be your RAM. So I mentioned earlier, your RAM chip will store the data that you currently opened up. All open programs, that includes your operating system. Maybe you're browsing the internet. Maybe you're opening a document. or an Excel sheet. All of that is going to be stored in your RAM chip. It's considered volatile. Remember, the more RAM you have, the more generally programs you open up. So if you have a computer right now, you can open up 1 or 2 programs and you've noticed, hey, this all looks good to me. Everything is nice and speedy. And then you open up a few more and it gets really slow, maybe because you're running out of RAM. So you don't want that. You want to make sure you have a good set of RAM. I recommend to have, in today's world, 16 gigs of RAM. All right, I recommend 16 gigs at a minimum to operate in today's world. Windows 11, maybe even older Windows 10, get most of your work done. 16 gigs. Ideally, I have 24 gigs of RAM here. That's all this MacBook here could have supported. Ideally, 32 gigs for us gamers. 32 to 64 gigs of RAM would be good. Your ROM. So your ROM chip is this chip on the motherboard. I showed you guys this earlier. This ROM chip, this little chip right here, this chip right here, this chip stores your BIOS. Okay? It's a non-volatile thing. It stores the BIOS. It contains the firmware of the actual machine. Now I want to point out something. All right? I don't have the battery on it, but you see there's a battery. There's a port for a battery. You see this motherboard has it. See this battery right here? I want to talk about this here for a second. So, when you turn on your computer, know this for your example. When you turn on your computer and you go into your BIOS, the data, the software in this chip, the BIOS, the firmware, okay, is non-volatile. In other words, it doesn't need power to hold that software. The software is encoded into the chip. But if you change any settings in the BIOS, and there is something that's always changing in the BIOS, the clock, the system date and time. Whatever changes you make to this chip, it needs power to hold the settings. All right? So if you go in there and you modify the BIOS, and don't forget the date and time. The computer has to find a way to hold the date and time even when the computer is off, right? Do you ever notice you turn your computer off, put it back on, the date and time is still correct? But where is it storing the date if it had no power, right? Something had to remember what today's date is. But how is it storing that data? It has to have some kind of way to remember the seconds, 1, 2, 3, 4, 5. It's remembering days. And you turn your computer off for 5 days and you put it back on, it should still know that, you know what, 5 days has passed. The settings, when you change a setting in here on this ROM chip, okay, the power that's holding the settings for the BIOS is this little battery. This little battery. This is called the CMOS battery. This battery holds the settings for your BIOS, for your firmware. So if you ever make a change to your BIOS, you modify it somehow, you change something, and your computer wouldn't boot or you can't get it up because you did something you shouldn't have done, you can just remove this battery, put it back in, it'll reset the entire BIOS. There might be a question on the exam and I'm going to be honest with you guys, these batteries, they basically last more than the life of the machine. You never need to change. I've never changed that battery in my life. And I've had machines for 6, 7, 8 years. But you're taking a test. Keep in mind, you might get a question where they were like, oh, the system timer kept going back to 1900 or whatever it is. And the answer is change the battery on the BIOS because the battery drained out. I've never seen that thing drain out, but it's an exam question that I've seen quite a lot. In fact, too many times to count, depending on the exam, I've seen that. So keep that in mind. Let's talk about storage devices. These are going to be non-volatile storage. You're going to store your operating system file. There's several different technology. I'm going to go more into the technology in the next video, where I really want to show you how everything works, because I want to bring my desktop up. I just want to get through these exam objectives. The first thing up is going to be your mechanical, your hard disk drive. This is the one like I have. If I open this drive, it looks exactly like this. It's a mechanical magnetic disk that spins with an arm that reads the data. So it's a spinning magnetic drive. Those spinning things, those disks are called platters. It is mechanical. These drives, they last Not very, very long, couple of years. They'll probably go for with continuous usage. Some of them can go 4, 5, 6 years. Some of them, if they're a Seagate, they'll probably die in a week because Seagate really sucks. I'm a Western Digital person. I hate Seagate. I've never had a Seagate. The brand I'm talking about lasts very long. So mechanical read-write heads, they're generally very cheap. You can get a hard disk drive. I bought 22 terabytes, which is an enormous amount of memory, for about 200 or 250 or 300 bucks. These drives are very, very slow in today's world. These drives are replaced with what's called solid-state drives. These types of drives, they don't hold a lot. For example, a hard disk drive will probably hold up to 20 terabytes versus a solid-state drive, 1 terabyte, 2 terabyte drives, is going to be very expensive. So these don't hold as much data as these, but they're generally very, very fast because they use memory chips on them. And I have one. I'll show you guys that in the next video. Now, these types of solid-state drive, one of the most famous form factor for solid-state drives in today's world, when you're buying a solid-state drive, basically all of them are going to come as what's called an NVMe, solid-state interface. This is the interface. This is basically a chip that you would install on your motherboard to hold your NVMe drives. They're very, very fast. They're very fast. They connect directly to the motherboard, and they generally, these things, 1 terabyte, 2 terabytes, 4, up to 8 terabytes, I believe, is the highest we can get in these so far. There might be more. When it comes to other storages, not very popular in today's world, but popular back many years ago. We used to store a lot of data on CDs. This would replace floppy drives, if you're old enough to know what those are. CDs used to hold up to about 650 megabytes. Not a lot, not in today's world. DVDs used to hold about up to 4.7 gigabytes. And Blu-rays used to hold about 50 gigabytes. So this type of technology really doesn't exist anymore. Not many computers don't come with optical storage, so we don't store data on DVDs or Blu-rays or anything like that. They're generally very slow to access, and they do utilize a laser to read them. A lot of that has been replaced with what is called USB flash drives. You guys should be familiar with these things, as I've bought way too many of them. This is portable USB storages, just little drives. You plug them into a USB port. They're flash memory in a small form factor, convenient for data transfer. These things here, from a few gigabytes, 8 gigabytes, 16, 32, 64, 128, 256, 512, even 1 terabyte now, I see them coming in. They range in prices from a few bucks, 10 bucks, to hundreds of dollars, depending on their size and speed. Now, that was what we're talking about in local storage, but you also can store data on a network. When you're working in a business, you store data on file servers, for example. So you store data across the network. Storage across over local area networks or small networks. This is going to be shared by multiple users. This is going to be done for businesses, not necessarily for you at home. One of the most common devices that businesses can install, and you can have one. I have one of these at home. This is actually my device. I have this exact device at home. You can have this at home. A lot of businesses uses this, especially if they need to share data. Maybe you have a household with 4 or 5 folks in your house and you want to share data amongst them. You would purchase one of these devices. Businesses will use this because a business always has multiple people needing to share data. Hey, Mary wants to share some documents with Bob. So you have a network attached storage. This is a dedicated storage device on a network. Multiple hard drives is in here for redundancy. It uses what's called a RAID system. We'll talk about that in the A+. And it's accessible to all network users. So remember, this is a device that connects directly to your network, and it allows you basically to have a hard drive in your network where everybody can access. On a business, they're going to take this. All right, this is going to be a smaller business. In a bigger business, they're going to take what you saw there and give it more power, give it a whole lot of RAM, give it more hard drive, and call it a file server. Technically speaking, a NAS, a network attached storage, is a file server, But this file server we're talking about is something that's more robust. It runs a dedicated operating system. It's dedicated for file storage, and it does manage user access and permission. This is going to be what we would have in businesses. This is a desktop file server. Also popular in today's world, if you want to just share data with folks on your network and you don't mind storing it on the internet, that's cloud storage. If you store data in things like Google Drive, Dropbox, or OneDrive, in which case you can share that data with anybody else, that's called cloud storage. Okay, quite a lot in these two sections. Now, let's go have another video where we're going to have some fun. I want to put it all together. I want to explain more than just what this exam objective is. Let's talk about power supply and coolant, and let me show you guys what the inside of that desktop looks like. Now that we have covered the exam objectives, let's have some fun putting it all together. When it comes to understanding how a computer works, there's three main components that puts it all together. Number one is going to be your CPU. Number two is going to be your RAM. And number three is going to be your hard drive. So in this video, I'll show you guys exactly using real components how all of that works. And I'm also going to explain some other components. Let's get started on this. So exactly how does your hard drive work versus your RAM versus your CPU, and how does that all interlinks together? Let's take a look at the overhead cam. Now the overhead cam here, I have a motherboard, and this is a little bit of an older motherboard, but all motherboards basically follow the same layout, and the theory of the components doesn't change. So look what I have here. I have a hard drive right here. Okay, this is a 1 terabyte hard drive that is connected to the motherboard using a SATA cable. SATA hard drive. Don't worry about the specifics. We'll cover those coming up later in the course. We have a hard drive that is connected to the motherboard, and the motherboard is the underlying board here. And here you have your RAM chip. Now I didn't connect anything. You can see it's just sitting there, so I could take them in and out as needed. So here I have a RAM chip, and I also have my CPU under this giant piece of metal. Let's talk about how this works. So let's get started. Number one, let's say you want to open up a picture, but the picture is stored where, right? Let's say you've saved a picture on your desktop and you're trying to open that picture. Well, where is the data stored? Your computer stores data here on this hard drive. Your hard drive stores all of the information on your computer. This is called non-volatile storage. Now, I want to point that out to you. You got to understand the term between volatile versus non-volatile. So, volatile memory is when the computer loses power, such as if it's shut down or you take the power cable out. Volatile memory, it would be completely erased. Your RAM chip is considered volatile memory. In other words, when you turn your computer off, all data from here is wiped out. Versus a hard drive. Now a hard drive, I want to pick that one up. A hard drive like this one is considered non-volatile. When you shut the computer off, it still maintains the memory. In fact, you can disconnect it from the computer and plug it into another machine and still have the data. Hard drives are generally considered non-volatile. So are other types of hard drive, like a solid-state drive. These are also considered non-volatile. So remember, volatile memory, you shut the computer off, you lose it. Non-volatile, you keep it. Does it need power to hold the memory, is the real definition of that. Okay, so coming back here to the overhead cam. So you want to open a picture on your desktop, right? So you double click on the picture. Where is the picture stored? The picture is stored here on the hard drive. Now, I want to point out something to you guys. Your CPU, which is here, does not read from the hard drive. In fact, there are times when it does. It's called virtual memory. Basically, your CPU is not really meant to read from here, and if you start using this as full-blown RAM, your computer runs really slow. It's called virtual memory on swap files. We'll come to that later in the course, but remember, technically, your CPU is not going to read from the hard drive. When you open a picture, the data comes through this cable into the motherboard and into the RAM chip. Your CPU will read data from your RAM chip. This RAM chip is very fast, and it can feed the data to the CPU very, very quickly versus this hard drive that is spinning here. Now, if you're looking at this, you're saying, hey, Andrew, that doesn't look like a CPU, and you're correct. This is not a CPU. What I have on top of the CPU is something we call a heatsink. Now, this here, I didn't connect it because I wanted to show you guys. The CPU is underneath it. This heatsink is a big piece of metal with a fan at the top. And these fans is used to cool down this metal, which then transfers this coolant to the CPU to keep it cool. Because CPUs are made up of billions of transistors, they get very hot. And they need specialized cooling devices in order to keep them cool. So, let me show you guys once again how this works. You open up a picture on your desktop, comes out of your hard drive because all data that you store on your computer is here. When you open it up, it pulls it from the hard drive into your RAM. Your computer, your CPU then reads it and processes it from the RAM chips. Then what the computer now does, once it's processing it, it pushes it straight out through the video port. Now, some of you guys may have dedicated graphics card. Here's a very small one that is connected to the motherboard. These are called expansion cards that you connect your monitor to so you can see your picture. This particular motherboard has an onboard video card. See the video ports right here? So if I had a monitor connected to this, a VGA port, if I had a monitor connected, then I would see the picture on the screen. That, in essence, is basically how a computer works. Now, I want to point out something here about all the things I'm showing you. Speed and bottlenecks, okay? When you're building a computer, when you're building a nice fast machine, for example, like a gaming machine, this is a question on your exam. Pay careful attention. When you're building a really powerful machine, these three components matters. Your CPU, your RAM, and your hard drive speed. You go cheap or slow on one, you're as fast as your slowest component. So you could buy a really fast processor and a really fast RAM, but if your hard drive really slow and it kind of sucks, your whole computer is slow because you're as fast as this. You could buy the fastest hard drive, amazing RAM, but buy the slowest processor in the store, same problem. You need all three to be decently fast in order to have a decently fast machine. And I'll give you guys some tips on that right now. So let's go into some slides here. I just want to cover some things here. Number one, hold on. We forgot to turn on the presentation. So number one, the CPU. We just mentioned, hey, the CPU is going to be the brains of the actual machine. It executes all the instructions and is generally measured in gigahertz. Now, I mentioned this earlier in a previous video that the CPU itself, remember, this is measured in hertz. So 1 gigahertz, 2 gigahertz, 3 gigahertz, 4 gigahertz is how we measure this. Remember, hertz is cycle per second. The more gigahertz, the better. And these CPUs do get pretty hot. So we're going to utilize things like this, like a heat sink, in order to keep it nice and cool. The heatsink has a fan that keeps the heatsink cool in order to keep our systems cool. If this overheats and dies and blows up, your machine is basically dead. Next thing up we have here, guys, is going to be RAM. Now, I want to mention that RAM holds all the programs. All the current programs that you have open is stored in RAM. Remember, the moment you open something, it feeds it into the RAM chip, right? It comes out of the hard drive and into this RAM chip, and all the data is stored here, and the CPU is pulling it from here. So the more RAM you have, the more stuff you can keep open. This is 4 gigabytes of RAM. Can you guys see that? Hide my face. Yes, there. So this is 4 gigabytes of RAM. I know it's a little hard to see there. Yep, it says it right there on the top. 4 there you go. 4 gigabytes of RAM, and that's not a lot. Okay. Don't forget, the more RAM you have, the more things you can open, the more documents, the more games, the more tabs in that browser you're utilizing. It is volatile, which means if you turn off your computer, you lose all the memory inside of it. It is much faster than normal storages like this. Now, I want to tell you guys, when you're building a computer in modern day times, and the year is 2025, 26, 27, you got to have, in my recommendation, at least 16 gigs of RAM. At least, minimum. 16, I didn't say 16 plus. To run modern systems nowadays, you need about 8 gigs of RAM to run your basic Windows and stuff. But this one that I bought here is 32 gigs of RAM that we're going to be installing on our gaming PC. 32 gigs I think is decent amount. I like to have 64 gigs. But that runs a little expensive, and for what I'm doing, 32 gigs is enough. Now, let's talk about storage technology. Actual storage on a computer. Now, there's really 2 kinds of these drives. This is a HDD, or hard disk drive, and this one here, that is now loose in the pack. Yes, I'm actually going to still use this one. That's why I'm trying to keep it safe. This one here is a solid state drive, right? It's NVMe drive. Now I want to point out the difference between these. So this type of drive is older technology. I remember when I bought my first desktop, when I got my first desktop that my mom got me, 1996, 1997, something like that, an old IBM machine. It came with 8 gigabytes of storage, which was huge in those days, as a lot of machines only came with 4 gigabytes of storage. Nowadays, you can see this one is 1 terabyte of data, which is 1,000 gigs, right? You guys remember the conversion. This is old technology. This technology has been around for a very long time. It is mechanical. There is a disk in there that's spinning. And if you ever hear a clicking noise, the drive is basically dead. Later on in the course, I'll explain to you guys the internal working. Now, I want to point out that this technology, even though it's slow and old, and it dies pretty often, I've gone through many of these things, they get damaged pretty easily, we still use them, and we use them a lot. A lot of companies are still storing data on these things. Why? Because they're cheap and they hold a lot of information. For example, this 1 terabyte, this is probably $20 or $30 in today's money. I built a network attached storage for my house, and I bought 3 22 terabyte drives. That's a lot of storage. 3 of them, huge drives that I bought. And you cannot get solid state storage that big. In fact, I think the biggest one I've seen of an NVMe drive. And don't worry about the terms. We'll cover them later in the course. But the other more newer technology that has no moving parts, very fast, it uses a type of flash storage, and it's going to make an old computer feel new. I'll cover this in a second. It's expensive. These newer memory, they don't come big. They come 1 terabyte, 2 terabytes, 4 terabytes is some of the bigger, and they're really expensive. 4 terabytes is nearly $400, I believe. So it gets really expensive to have this, but it's very, very fast. Versus this is much slower, but it's a whole lot cheaper. This generally lasts longer. This not so much. All right, the more you use it, the faster it dies. Now, I want to point out something to you guys. I have a term here. I have this thing. Makes old computers feel new. Now, there's going to probably be a question, because I had a question similar to this on your exam when I took it. And remember, I took the same exam you're taking. There was a question where they gave you the specifications of a computer. And they showed you a processor. They told you how fast the processor was. They showed you how much RAMs the machine had. And they told you the hard drive. And it was like HDD was like 600 gigs. And it's like, the machine is slow. What should you upgrade? And the answer is to upgrade the hard drive. Don't use HDDs. Use SSDs, solid state drives. If your machine runs on one of these old spinner machines, spinner drives, and you update it to a solid state drive, you will notice a drastic increase in speed on a computer. So remember that. That is a real tip for a real exam question. Now, moving on here, I want to talk about the motherboard. All right, let's go back to the overhead cam. Here is a motherboard. All right, put my processor back in. So the motherboard, let's take this cable out. Now, this is an older motherboard. We'll take a look at the brand new motherboard that's in the box for a gaming PC later. So here we have a motherboard. Now, what exactly is the motherboard? Well, the motherboard is where everything is going to connect to. Your processor connects to, you put your RAM in here. You have your different expansion cards for all your graphics devices. You have your hard drive connectors all listed here. You have a variety of different ports, whether they're USB ports, monitor ports, printer ports, Ethernet ports, more USBs, audio ports, and so on. Again, this is an older motherboard. Your motherboard is going to be that central, everything connects to the body like of the machine. So, oops, here we go. So, all components connect here. CPU sockets, which is going to be this thing here. You have your RAM slots. You have your storage connectors. You have expansion cards. You have the USB ports that we talked about right here. And, of course, power connector. Now, I want to talk about that because if you're asking me, by the way, if the CPU is the brain, which it is, the motherboard is basically the body, is where everything is. Now, I want to talk to you guys about powering up this, right? Because you connect everything. You connect to your motherboard. You're going to connect your expansion cards, your video cards, right? You have a really high-end video card, you got a fast processor, you got RAM. How is all this getting power? There is a dedicated device for that called a power supply. Now this is a brand new power supply we're going to be putting in our gaming desktop later. Here is a power supply, 650 watt power supply. And this is a modular power supply, all right? This power supply will give power to things like your hard drive. There's a cable that comes out of here and plugs into your hard drive, SATA power connectors. You can see it has a very large connector right here. We'll go over the names of all these connectors later on in the class. I got you, don't worry. Basically, this giant cable will plug directly in to this motherboard. Let's move this motherboard up. You see right here is a power connector, and the power cable basically goes in there and connects there. Now, this power supply, all right, the heart of the machine, the power supply is feeding all of the power to the device itself. Basically, it's going to take in AC and it converts it into DC power, pushes it across the motherboard. It's rated in watts. Got to understand that. Different machines need different wattage. So if you have a very simple motherboard like I have here, and you have a very small or onboard video card, and you just connect in one hard drive and this slower processor, you can get away with 250, 300 watts worth of power. But the moment you start going in, and you're going to put in, and this is not a really powerful video card. You start putting in higher end video cards, bigger video cards. You can see some of the big ones with them. They're very long and have a lot of fans on them. And you start putting in different cooling systems into the case to keep the systems cool. Now you need more wattage. Now you need 400, 500, 600, 700, 1,000 watt power supply. So the more components you're going to be adding in, the more power you're going to need. And these devices is going to give you that. As it supplies power to your motherboard, your CPU, we just mentioned, your GPU or your graphics cards, your drives, your fans. Now, if you start having power supply problems, just a quick thing. Bad power supply. I've got to explain this. Bad power supply symptoms. Random shuts down, no boot, burning smell. If you ever see smoke coming out of your machine, it probably is coming from here. Power supply is dead. Change the power supply. Your machine, keep pushing your power switch, nothing happens. It's probably a dead power supply. It's not unheard of that the machines, they died. Cooling systems. So how do you keep a computer cool? So when you're looking, let me bring up my desktop that I have here. When you're looking at a desktop. Okay, when you're looking at a desktop. So this is it all put together, right? When you're looking at a desktop, there's a couple of things here I want to point out to you guys. So when you're looking at a desktop, all right, one of the main things is, here's the power supply. This power supply is fully connected into this motherboard right here. You know, let's take a look. Let's go into the overhead cam here to help us out. Let's go into the overhead cam. Hopefully we didn't break anything and I don't have to refilm this video, because this is the third time filming this video because I broke something once on it. Let's take a look at this inside of this case. So in this case, we got to keep components cool. One of the first things you want to keep cool is your processor. You notice here I have the CPU fan. This is on top of the heatsink that's keeping that machine cool. But you notice there's a fan right here. See, that's a fan right there. This fan is pushing air out. You also have this part here. We don't have it on, but you can also install fans in the front to pull in cool air from the front. So you have an intake fan pulling cool air in, pulls that cool air in, circulates it, keeps it nice and cool, and then you exhaust this hot air out of the system. This power supply also have fans in them that you don't replace. If one of them die, you just replace it. So we do have a lot of things that we are going to use in order to keep our systems cool. Let's put this back over here. All right. Yes, guys, I am old and fat. I am too young to be moving around. I'm too old to be moving around components nowadays. Okay, so going back here. So how do we keep our stuff cool? We use fans. I showed you on the case. Heat sinks for your power supply. We'll talk later on about liquid cooling. What liquid cooling does is that it basically uses different pipes and water running through those pipes to keep the system cool. It's a better, more quieter form of cooling than just fans. Another thing I want to point out is something called, you'll hear me talk about, is thermal paste. If you look at the bottom of this, heatsink, there is this paste. You can't really see it because it's all dried up. This is an older one. This is called thermal paste. What this does is that it's able, when you put this processor on this particular, when you put this heatsink, I should say, on top of this processor, okay, you don't want the processor die to just hit the metal. You want metal on metal. So you put what's called thermal paste in between the processor die and the heatsink metals itself to help extract and keep everything cool. So that's called thermal paste. All right, I think we learned a lot of stuff in this video. Hopefully you guys understand how all these components are starting to work and come together in order to make your computer functional. I hate to be a pain, but can you please click on the like and subscribe? I'm pretty pleased. I'm really begging you. It takes a lot of work for us to put this together, especially for me to put this together and stand and teach. It would just mean a lot. It really helps out the channel. It really helps us to become bigger and grow a bigger audience. Thank you so much. Let's keep going. In this section 2.4, we're going to be taking a look at common peripheral devices. These are going to be common devices that you may have connected to your computer. For your exam, you don't need to know how to set these things up or go in and troubleshoot them or anything. That's for A+. What you guys now need to know is what exactly does these devices do? So let's get started with that. And I will talk a little bit about how to install them a little bit. So peripheral devices, what exactly does that mean? But peripheral devices, as you can see in the picture I have here, are things that we connect to our computer. Generally external device like keyboards, mouses, printers, scanners, and so on. So they're generally connected to the computer to extend the functionality, and how you install them depends on what they are. So let's go through some of these common ones. The first thing I want to mention is a printer. A printer is something that you're going to print paper out of. Generally, this is where you're going to print documents out of. A hard copy of that digital document that someone sent you. Maybe someone emailed you a document and you'd like to have a paper copy of it. You would utilize a printer to get that document. Printers comes in various types. Inkjet utilizes actual ink cartridges. Laser will utilize a substance called toner. And then thermal printer will utilize heat to heat up paper in order to form the images. You don't need to know all of these different things. I'm just mentioning them. To install these things, generally you have to install a driver, which is a piece of software that tells your computer how to use that hardware. We'll talk a little bit more about that towards the end of the section. Scanners. Sometimes you have a document that you would like to get into your computer, not out of your machine. So the printer would allow you to get a document out of the machine. A scanner would allow you to get it in. This is a flatbed scanner. You would put the document on the scanner, and the scanner would scan it, and then you would have it in your computer. So it converts physical documents to digital documents. This is a flatbed. There are some printers that comes with these scanners on top of them. They're called a feeder, or document feeder, where you can feed. This one just does one page at a time, but then it'll scan multiple pages at one time. A keyboard allows me to enter data into a computer, as almost every computer nowadays has to have some keyboard so we can get instructions to it. Keyboards could be wireless or they could be wired. Most of the time they're USB, and they're usually what's called, notice term, plug and play. Plug and play means you just plug it in and you play. You plug it in and you start using it. There's nothing to install or configure. You just plug it in and it starts working. A mouse. How do we move around the little pointer on the screen? How does the computer know, hey, I want to click here, I want to click there, I want to open that, I want to use that link? Well, that's going to be with your mouse. They're either going to be USB and they're going to be either optical or mechanical. Back in the days, these are all optical mouses now. They have a little light on them. But back in the days, they used to have mechanical mouses that had little balls, like track balls on them. Nowadays, they're all optical mouses. And some of them are not just one or two buttons. Some mouses have many buttons that allows you to do additional things like scroll through a web page. Like this one has a scroll wheel. Some of them will also allow you to speed up the cursor, and some of them have additional buttons for games. A webcam. You want to do Zoom meeting. You have Zoom meetings to do. How are you going to be able to show yourself to others? Well, that's going to be done with a webcam that catches the video of you. A lot of times on laptops, the laptops themselves will come built in with a webcam. Now, it's hard to see that, but this laptop, yeah, you guys can't see that. There's a little, this laptop here has a built-in webcam on it. And you can see that tiny little hole right there. That's the webcam that's built into this laptop. You can also purchase external webcam like you have here. So I have a couple of these. These are about $100. You would buy them, and it would give your desktop the ability to have video on it. They can be built in like the one on my laptop, or they could be external like you have here. Now, the other one that you may have that I recommend a lot of people to have is an external drive. This is external drive that you're going to connect to your computer, allows you to save data. One of the things that we should be doing is backing up our information, storing another copy of our data. I always tell people, it's not when this device dies. I've said that wrong. It's not if it's going to die. It's when it's going to die. We should be backing up our data on external drives like this. They come in a variety of different form factors. You have USB, eSATA, Network Connect. You have network ones also. You generally format it before using it. We'll talk more about that in the hardware section and software section. Speakers. Many devices comes with speakers. Your laptop generally has built-in speakers, allows you to hear what's happening on a computer. Now, they are external speakers that you can buy. All right, they are external speakers that you can buy and add on to your desktop, and then you can hear audio from it, especially if you're listening to videos. There are different headsets you can buy, like that one there. I'm showing you guys a headset. Some of them may include microphones. So if you just put a speaker in, you'll just be able to hear. But sometimes you may want a headset. You can see that headset I'm showing you there. That one allows you to hear audio, and it has a little mic so you can talk back into it. This would be useful for like if you're doing Zoom meetings or you're live streaming or you're talking to people online. You're going to want to have that microphone and that speaker to hear what they're saying. Right now, you guys are watching me on some kind of display device, whether some kind of a screen, whether it is a monitor like I have here. It's on your laptop monitor. You got to watch me on something. This is the visual output of a computer. What the computer is outputting is going to be on your monitor. Many computers support multi-monitors, which I highly recommend you guys should check it out. Never work with one monitor. They come in different types of connections, which we'll talk about in another video, the different types of connectors that are out there. Smart TVs. These are televisions. You're going to have smart TVs nowadays with the ability to access the internet. They can stream content. They have built-in YouTube, built-in Netflix, Peacock, and whatever other streaming services out there. They're basically like small computers inside of a TV. They're TV with internet connectivity. They generally support wireless, so you don't have to plug in any wires to it, and you can generally watch YouTube right off of your television. A projector. Now, this is a projector that you would find at home. You go to the movie theater, that giant screen is generally a projected image. People have projectors at home. I have one at home. They don't have to be very expensive, but they could get very expensive. But they do allow for large screen displays, especially a presentation. We use them at the school when we're presenting data in front of a large audience. They have a variety of different connections, whether it's HDMI, VGA, connectors that are out there. The problem with projectors is that it has generally to be a dark room because it is a beam of light generally hidden a wall or some kind of a panel. And the resolutions may need to be adjusted. For projectors to look good, the room generally has to be very dark. So we talked a little bit here about display devices, right? And display device, this is the main category. Smart TV is a display, projectors, monitors we talked about, dedicated computer displays. Remember guys, monitor comes in a variety of sizes. You can buy monitors as small as 18 inches and as big as like 50-inch monitors. So they come in a wide variety of sizes and resolution. You don't need to memorize that for your exam. For your A+ you do, but not for this exam. Another thing we want to mention is going to be power. Now, I recommend for you guys to connect one of these to your computer. This is called a UPS. This is a big battery. It's a battery backup for power outages. It protects against power surges. It generally has software for monitoring your computer. So let's see what this is. You buy one of these things, they go anywhere from $60, $70 to thousands of dollars for the big ones they use in computer data centers. But $100, $150 is probably what I would buy one for. I have one similar to this. And basically, you plug in all your computer hardware into it. You plug in your desktop, you're going to plug in your modem, your routers, and so on into this thing. I have my NAS connected to it. The reason why you want this is because when there's a power outage, first of all, in power outages, it may cause a surge of power, and that surge can destroy your computer equipment. This has a built-in surge protector. The other reason is that if your computer ever gets its power pulled from it, it could corrupt the operating system and it could damage the devices. This here will keep the power going for generally an hour to two, depending on how much devices is plugged into it. If you install the software that comes with your UPS, your uninterruptible power supply, it can actually shut your computer down. Like actually send a shutdown command and shut it down so your computer is not hardly pulled out, like its power is pulled out. So this is good to have, especially like if you have like a TV, a very expensive television, LED, LCD panels, these are good to have. Now, those are some different peripherals that we have out there. The question would be, hey Andrew, how do we install those things? How do we get those things installed on our computer? Well, there's different device configurations. Some are manual, some are automatic, some are easier than others. Some of them requires different approach. Some of them are just plug and play. You just plug them in and they start working. Now, the first one up is plug and play. A lot of times, and a lot of devices actually, you just plug it in and you start playing. You just plug it in, you start using. The operating system like Windows will detect the device and it'll start working right away. Now it will, every device, let's stop right here. Let's take a step back. Every single device that your computer has, whether it's a hard drive, a keyboard, a video card, a printer, every single device requires a driver, okay? A driver is a piece of software. Let me show you guys what drivers looks like, all right? Let me show you guys what a driver looks like. So where's my desktop? So here we are at my desktop. I'm gonna right click on the start button and I'm gonna go to Device Manager. And these are all the devices that are installed on my computer. If I go to, let's say, display adapters, here's my video card. I right click on it. You notice update driver. You guys see that? So this allows me to update the software that's telling Windows how to use that hardware. If I go to properties, I go to driver. So this is a driver. This software is published by who? Well, it comes from NVIDIA, the maker of the video card. And here's the date of my driver. All right, so I can see the details of it. I can update it. Now the point of what I'm showing you guys is this. What I'm showing you guys is this. Every single piece of hardware requires a driver. What's a driver? It is a piece of software that tells your operating system, that tells Windows how to utilize that hardware correctly. If you don't have a correct driver, the video card may not work well. It may display nothing. It wouldn't have the right performance. So you always got to have the right driver for the hardware. In plug and play, Windows itself comes with tons of drivers. So when you plug it in, Windows already has a driver for it, and it just starts to utilize it. It installs the driver automatically. No additional configuration. But big but. A lot of times when you install hardware, Windows doesn't know how to use it. I mean, there is like thousands of hardware that is out there, thousands of video cards and sound cards and RAM, hard drive, and all types of additional components. You can plug in USBs and blah, blah, blah. Windows doesn't have all the drivers. So you have to go and get the driver. The best place, the manufacturer's website. So if you ever plug in a peripheral, a hardware into your desktop, and you realize, hey, this thing doesn't work, what do I need to do? You probably need to install the driver. So you would download that from the manufacturer's website. And this generally is more of a manual step. You're going to have to follow the instructions, and that'll get your driver installed. Now, the other one here you have is going to be other steps. Sometimes, I want to mention other steps. Sometimes you need additional configuration. Sometimes you may have to set up network accounts or network configs, or you may have to install additional software. It depends on the device. For example, sometimes you install a printer and you install the printer driver, but you may have to install a specialized software to have the scanner function work, because you just can't scan just right out the box. The printer may need additional software. If it's a network printer, you may have to edit network configurations to make that work. Not for your exam. That's more A+, Net Plus for that. Some devices, like especially if you're installing like a network printer, you would need to know its IP address, which we'll come to later. This is devices with a network address. You need to know how to connect to them in order to install them. I do want to mention that you could install remote network devices. In other words, you can have a printer that's installed on a network. It's plugged into a network switch. And what happens is when people in the office want to print, they're all sharing that printer. They're all going to print to one printer, and that would be what's called an IP-based printer. IP means Internet Protocol. That is the address of that printer. So it requires network configuration. Web-based configuration. Some devices are access the device through a web interface. You type in an IP address and you configure it. Now, this is important because some devices like this, some devices, not all. So here is a wireless router. This is a wireless router firewall. In order to configure a device like this, you would need to enter a web interface in order to configure it. That device it gives you an IP address in a browser, and you would go and you would configure the device straight through your browser. It's how you would do that. Now, not all devices are like that. Some of them are not. A lot of the peripherals that we install is generally going to be some kind of driver that has to be installed. A lot of times, depending if it's a simple device, it's going to be plug and play. Sometimes if it's a more complex, you're probably going to have to get you have to go get the driver yourself. All right, make sure to review these sections. Remember, you don't need to know how to set all these things up. Just understand what they are for your exam. Andrew from the future. If you're enjoying this course so far, once again, if you would like to get the course notes, the presentation I'm using, you would like to get practice questions, and just watch it without, I'm pretty sure YouTube is going to put a lot of ads. If you would like that, don't forget to check out the links below. My website, TIAexams.com. You can get this course for just $9.99. The price of basically 2 cups of Starbucks. And you can also, I think this is also going to be on the Udemy platform if you have that also. You can get the course notes. You can get practice exams with it. Let's keep going in the course. In this section, we're going to be taking a look at a variety of what's called I/O devices. I/O means input-output, and it's how the interfaces we're going to use to get data into our computer and out of our machine. For example, in networking, we could use wired or wireless cards in order to get data in from the network into our machine. We can send data out of our machine through the network. We can also use things like USBs also to get data into our machine. Think about plugging in like a USB drive or some kind of USB device in there. So we're going to take a look at networking interfaces. We'll take a look at a variety of peripherals, as you can see. We'll also look at display interfaces. This is how we can connect monitors so we can see the actual display, and then we can even see how to do mirroring and casting. So let's get into this. The first thing we want to talk about is when it comes to networking. When it comes to networking, there's really two main ways you can get data in and out of a computer. Wired interfaces and wireless interfaces. So some computers does support wired interfaces, and that's probably going to be more of your desktops or bigger laptops. This laptop that I'm using here does not support wired connection. As you can see, there is no wire, no way to plug in anything in there. Like there's really no ports. It just has a single, I believe, USB port, 2 USB ports on it. No way to plug in nowhere to plug in a network cable. Here I have a network cable. This cable is not fitting anywhere in this laptop. But if you have like a desktop and the desktop has an onboard NIC card, you add a NIC card to it, network interface card, you would then have, like this one here has a NIC card, I would then be able to plug this network cable that I would plug into my router so I can have internet, and I can then plug it into here, and now I would have internet. So let's go into the first thing we're going to talk about is wired interfaces. And the first one we'll talk about is Ethernet. This is what you're going to have connected to your desktop. This is what you're going to have in your business, your home. You want to use wired connection, you're going to be using Ethernet connectors. Now, what they're talking about here in Ethernet connectors and Ethernet cable is this cable right here. This is an RJ45. All right, RJ45. RJ45 head is going. Are you going to focus for us there? Come on, don't focus on my hands. Focus on this. Focus on this device here. Doesn't like me. Doesn't want to focus. Doesn't know what it is. This is what this thing looks like. It looks exactly like if you would have a old telephone cable. It's just a little bit wider on here. And this is what you would plug into your routers. You plug this into your desktop also. Now this here is good. Nothing wrong with this. Standard, I use these in my house. We use these in our network in here. Standard network cable connector. The head, this head that we have on here, this is called an RJ45. All right, RJ45 connector. It's reliable. It does have much faster data transfer than you would have in a wireless connection. Now, in businesses where they have servers and they need to transport massive amounts of data, much more than this line can hold, they're going to use fiber optic cables. Fiber optic cables, I have a picture of these cables. Fiber optic cables is made differently. You see, if I was to cut this cable, the core of this cable is copper. In other words, just plain copper, just regular metal copper. Fiber optic utilizes either glass or plastic core. So if you cut this cable, it's either going to be, this one is probably going to be plastic. You can also have glass core. They allow incredible data speeds over long distance. Massive amounts of data could be transferred. When they run wires across the ocean, yes, there are wires run across the ocean called like transatlantic cable. The world, if you ever wondered how the internet works, the world is connected not by wireless, but by wired connections with fiber optic cables running under the ocean, connecting all the different continents. If you're really interested, you can Google that. Interesting stuff. Any which way, it's done using fiber optic connectors. So remember for your exam, fiber optic allows long distance, miles and miles and miles, and supports massive amounts of data transfer, 1,000, 3,000, 10,000 gigabit transfers. So fiber optic cables, this head you're looking at, the connector you're looking at there on there, this is not an RJ45, that's considered SFP or small form factor pluggable connectors. The other thing here we have is when it comes to wireless networking. When most people think of wireless networking, they're thinking about 802.11, A, B, C, and ACAX. There's different versions of it, but wireless networking is known as 802.11. The X is going to be a variable of A, B, C, N, A, C, X, and so on. There's many of these different standards. The newer ones are like AX and AC. Now they're called Wi-Fi 5, 6, and 7, and that just specifies the range, the distance, and the speed of these connections. Most, if not all laptops nowadays comes with wireless. So does desktops. Comes with wireless connectors built into them nowadays. I haven't seen a laptop that hasn't in the last 5 or 10 years or so. But if your machine does not have a wireless connector, you can add in one. We showed you guys something like this, but you can also get a USB card that allows you to add wireless to your computer also. The other thing here we have is going to be Bluetooth. So what's Bluetooth? Bluetooth is like your Ethernet wire. It's like your Ethernet wireless cards, right? It's like wireless, but it's more for short-range wireless connection. It connects generally to peripherals, and it's a very low power consumption. Bluetooth's famous for things like when you want to connect a headphone to your computer or a headphone to your actual laptop or your phone. It's good for connecting your phone to your car. It doesn't support lots of data transfer, generally very small amounts of data, whether it's voice, it's some video is not the best thing over Bluetooth, but voice or audio generally works well over Bluetooth because it has a low power consumption, so it doesn't drain your device a lot. NFC. So NFC is what's called near field communication, very short range. I'm talking like, if this is the reader, your phone has to be like here for it. It's a few centimeters. Where are we going to use this? NFC allows you to do payments. So I have an NFC on my phone, and it's something that you have to turn off. So let me show you guys what I mean by that. So if we go to the overhead cam, here's my phone, and right here, there is a little end device. You can see that? So if I click it, this basically turns on the NFC onto my phone. Now, I want to point that out because NFC allows you to do things like payments. It allows you can put your credit card in your phone, like your Google Wallet or Apple Pay, and then you can just go to readers and you would click it and you'll be able to pay like that. So you don't have to walk around with your credit card. Very popular, and a lot of people use it for that. Now, let's talk about some networking tools. Know what these tools are for your exam. You don't need to know how to use them. In Network Plus, I'm going to explain. I'm going to make network cables. So I have a giant network tool set. I will show you guys that in Network Plus. For your exam, just know that a crimper is a device that allows you to make the cable. What am I talking about? Well, it allows me to put the head on. So you imagine you just have a blank cable, a cable without a head, something like this, right? And then you want to put this head on, this cable. That crimper allows you to attach the connector to the cables. Why would you want that? So that way you could make custom cable. You can make your own network cable of custom length. Sometimes you buy them in a box like I did because I'm lazy to make one. Sometimes you buy them in a box and they come 6 feet, 10 feet, 20 feet, and you just want one that's 1.2 feet. Well, make your own cable. You will need a crimper to make network cables. Now, when you make a network cable, you have to verify if the cable actually works. Does the cable get the job done? Well, that's where this device comes in. A cable tester verifies that the cable that you bought actually works. So you would plug in one end into this little device right there, and you'll plug the other end into this device, and you can see there's a bunch of like little boxes. Those lights, they light up. And if they light up in a specific order, generally in the same order from both devices, you know that you made the cable correct. So a cable tester is used to test if you made the cable correct. If there's any breaks in the cable, it can tell you. If the head isn't on right, the cable is not functional, this device will tell you that. Now, moving on. Next, let's jump gear. Let's talk about peripheral interfaces. This is how are we going to connect different devices to our computer. A printer, for example, how do you connect that? A specific keyboard, a microphone, how are we going to connect that? There's different connectors that we can use. Now, back in the days, and I have this old motherboard because I want to show you guys some older connectors. Watch. I want to show you guys some old connectors. You see this motherboard? Parallel port, serial port, right? Even some old audio ports are here. So you see like all these, back in the days, when you wanted to connect devices, you had dedicated ports. Like this port here, you would put in a printer or a scanner. If you wanted to connect like a modem, you would connect it here. So everything had their own little ports. Then came the universal port. A universal port, a port that supports all devices, called a universal serial bus, or USB. So keep in mind, it's called universal because back in the days, all peripheral device. Now, I'm not talking display. I'm not talking display. That's connecting monitors. I'm talking connecting printers and scanners and microphones and different kinds of audio equipment and so on. They had, even a gamepad had its own port called a game port. So what they did was they created a very specialized port called a USB port or USB bus. Let's take a look at this. The most common is, of course, going to be USB in today's world. You have different USB standards that you should be familiar with. You have A is the rectangular connector. That's the first one. You have B, which is going to be this one. This is a square connector. You generally find this on printers. I've also seen this on different kinds of USB hubs also. And reversible USB-C. So I have this here. Let's take a look at them. So this is a normal USB-A interface. Now, this is not reversible. This can only go in a certain way because you notice the bottom of the port has a lining like at the bottom. The other end of this one here is going to be that USB-B. So this one looks very different. So this is the A and that's the B. See, A, B. And you can see that this one looks very, very different. It can only go in one way. The reason why I hate USB A and B, sometimes you're trying to plug something in and you plug it in this way when you should have plugged it in that way, right? You got to turn the cable over. Oh, I hate that. So that kind of sucks. Now, the good thing is that with USB-C, well, USB-C is different, right? USB-C, here's a little USB-C cable. It's one cable. With USB-C, you can plug it in anyway. You can plug it in this way, plug it in, don't matter. You can, newer reversible connector. I love using USB-C. So, newer reversible connector, almost everything nowadays in today's world comes in USB-C. Now, I want to mention something called a Thunderbolt port. Thunderbolt port is basically something that's it's a different standard. It's technically not USB, but it runs on a USB interface. It runs on a USB-C interface. Here's what I mean. USB is a standard itself. In other words, standards are important. For a USB keyboard to be plugged in and work through a USB port, it has to follow a standard. It's called a Universal Serial Bus Standard. And there is another standard called Thunderbolt. Now, Thunderbolt supports data, video, and power. Technically, so does USB, but it's a lot faster than USB. Some devices utilizes USB, but here's the cool thing, or I should say confusing thing. Thunderbolt works on a USB interface. In other words, let me show you guys something. This is a Thunderbolt cable. You'll know it because it has a Thunderbolt port on it. Has a Thunderbolt connector on it. So you see the Thunderbolt? You know it's a Thunderbolt because it literally has a Thunderbolt on it. But you notice it's the same interface as my USB-C. So this is a, where is that little cable I had? Somewhere around here. So this is a USB-C, right? USB-C, Thunderbolt. You notice it's the exact same port. Same connector. But this is a Thunderbolt, and how can you tell? Thunderbolt always has a Thunderbolt on it. And that's how you would know whether it's a Thunderbolt or it's a USB-C plane. Generally, if it has nothing, it's a USB-C. If it's a Thunderbolt, it's going to have the little bolt icon on it. Bluetooth. We spoke about Bluetooth. Bluetooth is very famous to make, you may have a Bluetooth keyboard, a Bluetooth mouse, Bluetooth speakers, Bluetooth headset. No cables required. A lot of desktops doesn't have Bluetooth. Nowadays they come with, this motherboard I have has Bluetooth, but a lot of motherboards did not. So you would have to use this tiny little USB thing. This thing is about this big. It's a tiny little USB stick that you plug in. It gives the computer Bluetooth so you can connect your Bluetooth keyboards or mouse into. Okay, the other one is called RF or radio frequency. This is very famous for things like it's radio. It gives you a longer range than Bluetooth. Generally used for wireless keyboard and mice. If the mice is wireless, but it's not actually Bluetooth, it's probably going to be running off of RF. Now, the other one you have is for you Apple folks. I'm not an iPhone user, but for the Apple folks, Apple has their own proprietary connector. This connector right here, we call a Lightning port. This is generally used to connect iPads and iPhones. It is a reversible design, just like USB-C, you can turn it over. But keep in mind, Apple is moving away from their own connector and also using USB-C. So remember, for your exam, Lightning is the Apple proprietary connector. Okay, switching gears now, let's take a look at display ports. Display ports is how we're going to connect our monitors to our computers too. And there's a wide variety of different display ports that are out there that you should just be aware of, at least be able to identify out there. Now, let me show you guys what I mean. So if you look at this motherboard here, technically you should be able to identify display ports. So this is a DVI port. This is a VGA port. This is an HDMI port. There's another one called display port and so on, but we'll talk about that in a minute. So, well, those motherboards are very sharp. So let's go ahead and take a look at the connectors that we can use when connecting our monitors. Now, some of these, there are multiple standards. Some of these allow you to connect a monitor and pass audio. Some of them don't. The first one up is going to be the old VGA connectors. This here, old VGA connectors. This is one of the older standards here, old analog type connectors. They don't support very high resolution, and that's because they were generally limited to, like, I think 1080p. You really couldn't go past with a VGA. So if you need monitors 2K, 4K, you're not going to be able to use VGA connectors. In fact, newer monitors are coming and doesn't even have this port anymore. New motherboards doesn't have this port on it anymore. So this here is really beginning to fade out. So it's older, it's analog, it uses a 15 pin. If you count the number of pins in here, you'd actually get 15 out of that. Lower quality. So let's move away from this analog connector and let's move up to a more digital connector, and this is going to be a VGA. Some people call this digital video interface or digital visual interface. Now, this is digital video. This is much higher quality than you would have with the VGA connector. I want to point out that even though this is newer than VGA, this is also going away. I haven't really seen video cards and our motherboards with this connector anymore, and monitors are not even coming with it anymore. But it is a it is digital. It does support full high definition and all the higher ups resolutions that are out there. And it did have multiple variants of it. There were different connector variants. A+, we'll get to what those are, but for your exam, just know, hey, they did support different variants. Look, you see how this one looks? You see all those pins in there? Versus this one right here, you'll notice that that one doesn't have the same pattern of pins that are in there. The one that we utilize today is HDMI. Now, high definition media interface. HDMI is the most popular cable connectors that are out there today. This is what you connect your 4K TVs with, almost all your monitors. Every monitor that I've ever purchased in the last 5 years generally has an HDMI port on it. Now here's the thing with HDMI. It's not just DVI, by the way, it doesn't support audio. Now I want to point that out because sometimes your monitor, in fact quite a lot of monitors, have speakers built in. So when you connect an HDMI using an HDMI cable, you connect to your computer, you'll be able to pass audio through this cable. You wouldn't need a separate cable for audio. So it carries both audio and video. Common, almost all monitors today, and of course TVs have this type of cable. The other one is a display port. Now, display port and HDMI. All right, a lot of monitors and computers will come with them. High performance digital interface. This thing is famous for supporting multiple monitors, and it carries both data and video. What do I mean by multiple monitors? A lot of times when you're connecting 2 or 3 monitors, you're basically going to use 2 DVI ports on there. Not DVI, I'm sorry, display ports on it. Small cable, much smaller than a DVI or VGA. Easier to use, a lot of monitors, a lot of video card comes with this particular port. Don't forget it carries both digital, carries both audio and data, and it supports high definition just like the HDMI. I also want to point out that you can also use USB-C to carry video signals. A lot of times you can connect, I have this monitor, I'm using a small monitor right here. This small monitor is actually connected utilizing a USB-C cable. So you don't necessarily need to use a DVI or HDMI or DisplayPort. USB-C can actually, because it supports high data speeds, you can actually use it to connect external monitors to. So if you have a laptop, like maybe if I want to connect an external monitor to this one, I can use a USB external monitor and I can have two monitors, the laptop screen and the other monitor. Now, the last thing I'm going to talk about here is display technology. This is mirroring your screen. So we can mirror, like I have my phone, I can mirror this screen onto a TV. And sometimes I do that when I'm doing like TikTok videos, or maybe when I'm doing presentations, I may mirror the screen from my phone onto a large TV so I can present the data. Now, there's a couple of ways of doing this called casting. Like you can use your Chromecast, AirPlay. This one also supports a version of this where we cast the screen over the network to a large TV like this. Now, that's all here we need to know for our exam. Where is our thing? Now, this one here, I want you guys to review this section. Know these different type of connectors. They're probably going to show up on your exam. For example, no VGA, DVI doesn't support audio, just video. VGA is much older, it's analog, versus DVI is digital. HDMI DisplayPort can support audio and video. Know the different types of wired connections that are out there, when it's best to utilize them, because these are pretty easy questions you can get on your exam. In this video, we're going to be talking about virtualization and cloud computing. Now, this topic can get very big very fast, but for your exam, you just need to understand the basic underlying concept of it. And if you haven't heard about virtualization, I'm going to show it to you guys because that's pretty cool stuff. And of course, almost everything nowadays, I mean, if you're watching Netflix, almost everything here runs in the cloud. Let's get started on this. The first thing I want to mention is virtualization. What exactly is it? Well, virtualization allows you to run multiple systems on the same physical box. Basically allows you to run multiple operating systems. It's like having multiple computers on one physical computer. And if you're asking yourself, why would you want to do that? Well, because sometimes us technicians, we want to run a Linux machine. We want to run a Windows server. We want to run an additional Windows 10 or Windows 11 to troubleshoot or solve problems. So what we do is we virtualize lots of different computers on one physical piece of hardware. This allows us to maximize our hardware. Think about this. If you buy one really powerful computer and you want to set up a small network so you can practice networking, would you go and buy more computers? No, you would just virtualize the rest of the machines. So this allows us to maximize our hardware utilization, improve flexibility. You want to learn Linux. What are you going to do? You're going to install Linux on your main desktop and you don't have a regular computer? No, you would virtualize it. Now, I have a virtualized machine set up. I have a dedicated machine, a really powerful machine that I run virtualization on, and I want to show that to you guys. Let's see what it looks like. So this is a machine here. Oops, wrong one. This is a machine that I set up to do that I teach with. And this machine here, I'm running a software that you can download. It's free. It's called VirtualBox. VirtualBox allows me to actually run multiple operating systems. This is the virtualization software that I'm using. And right now I'm running a Windows 10. I'm running a Linux, Kali Linux. It's a specialty version of Linux for penetration testers or bad people like hackers, and a Windows server. And you can see that here. So here's my Linux installation. So you see, like I'm running an operating system inside of I'm running a Linux inside of my Windows 11 machine. And here's my Linux box. Here's my Windows server. Haven't logged it in yet. Here's my Windows 10. So you can see how I have a Windows 10 inside of a Windows 11. So what exactly is virtualization allowing me to do? Well, it's allowing me to run multiple virtual machines, virtual systems inside of one physical system. Now, this is used a lot in IT because sometimes we need to run multiple services. I mean, what if you want to run a web server, but you want to run a file server? Would you buy two physical machines? No, you just buy one machine and you run a virtualized web server on Linux and you run a virtual file server on Windows. Things like that, you would use it. Now, when it comes to this virtualization that we have, I want to talk about something called a hypervisor. The hypervisor is what is making it work. It's the software that manages those virtual machines. It's what makes those virtual machines functional. That's how I can run a Windows 10, a Windows server, and a Linux on it. It controls, what the hypervisor is going to do is going to control access to the hardware from the virtual machines. There are two types of hypervisors. There's what's called a type 1 and a type 2 hypervisor. Type 1, this is more for servers. This is more for corporate installations. This is when it basically allows the virtual machines to talk directly to the hardware. It like bypasses the operating system. Type 1 hypervisors or virtualization software are basically operating systems themselves. A type 2 hypervisor runs on top of your operating system. So you would install it like an application, and then you would just install your virtual machine. The virtual machines themselves, the virtualized computers, don't have access to the hardware. They go through the hypervisor to get it. Okay, when you're running virtual machines, understand there's something called a guest operating system. So you saw just now that I was using Windows 10, Windows Server, Kali Linux. Those were my guest operating system on it. That is the virtual machines themselves. Now, the virtual machines, like my Kali Linux, thinks it has access to the hardware, but it doesn't. It's actually running on the virtual machine. I have multiple guests right now. You notice that I'm running 3 operating systems at the same time, right? So if you remember, I'm running a Windows 10, I'm running the server, and I'm running Kali Linux, and they all work at the same time. You guys can see that, right? So you guys can see that, and I can shut down these machines here. So you guys can see that you can run multiple guest operating systems at the same time. Let's go into cloud. Virtualization. Virtualization is linked to cloud because all the machines in the cloud are technically virtualized. What is a cloud? Well, it's a thing in the sky. That's a cloud too. Let's talk about cloud and IT. When you're talking about cloud computing, cloud computing just means other people's computing. One of the biggest providers of cloud computing is Amazon, AWS, Amazon Web Services. The 3 big providers of cloud computing, for your knowledge, is Amazon, the Amazon Cloud, or AWS, Amazon Web Services. You have the Google Cloud, or just GC, Google Cloud, and Microsoft has a cloud system called Azure. So those are going to be the 3 big names in cloud computing. When you say cloud computing, it basically means you're processing and storing data in somebody else's data center, in somebody else's network. That's cloud computing. It's not in the cloud, it's just stored in somebody else's data center. Amazon dominates this space. I think Amazon has the majority of this space now. It could be Google, but I think Amazon has the majority of this space. A lot of the applications you guys use, all your web services like Netflix, all of these things, they run through cloud resources. So when you're thinking of cloud resources, think of, well, I'm going to pay somebody else for their storage and to process my data in their data centers so I don't have to build my own data center. Think about this. Let's say you want to start a business and your business requires you to process mass amount of data. You have to store a lot of data. What are you going to do? You're going to go build your own data center? No, you just get Amazon now. Use Amazon's data center. Let them store it. Let them process it for you. So cloud computing is resources delivered over the internet. And here's the cool thing. You pay as you use. So if you don't use a lot of it, you don't pay a lot. It's very scalable, and scalable means it can contract and expand as needed. So you can get a little bit of resource or you can get a lot of resource depending on your need, depending on the need of your organization. Now, I want to talk about how it's set up. Cloud has 3 main ways: infrastructure, platform, and software as a service. When you purchase cloud computing, you're going to use one of these 3 methods. The first one up is infrastructure as a service. Now, this is really for companies and organizations. Infrastructure as a service is when the cloud provider like Amazon gives you a virtual machine that's stored in their cloud. This virtual machine has CPU, it has storage. You basically have to go in, install your own operating system, you have to install your own application, you have to configure the box yourself. So they're giving you the machine, the storage, and the network. You have complete control over this machine. This is infrastructure as a service. Basically, you're just getting a computer in their network. You control the operating system. You're going to be controlling the applications that's on it. You configure it anyhow you like. So basically, they're giving you the infrastructure to run that machine. They're giving you the network, the internet connection, the actual physical box that runs the machine. They're giving you the ports on it. And all you got to do is put your operating system. The other one is going to be platform as a service. This is very popular. A lot of people don't want to worry about the operating system. So you go to a cloud provider and you say, well, let me get a box. They give you a virtual machine, like you saw I have here. It comes with the operating system. And you have to put your application. So they're going to give you everything, including the database, the environment to run your apps, tools on it. And all you got to do is just put your applications on the box and you're ready to go. So if you have a particular, like a website or a web app you're building and you don't care about the operating system, you don't want to manage all that, get platform as a service. Now, software as a service is when you just rented an application. This is the most popular thing, and more things are like this. This is complete application. Office 365, Google Docs, Salesforce, QuickBooks Online. These are all SaaS products or software as a service. Anytime you hear somebody say, we're going to build a SaaS product, all SaaS means is that you're building an application that other people accesses it through the internet. Think of Salesforce is a very popular SaaS. So Gmail, Office 365, these are all going to be basically the maker, the SaaS, the people providing it, like Salesforce, they're going to control everything. They're controlling the application themselves. They design, they build, and host the application. All you're doing is utilizing it. Now, when it comes to cloud computing and networking, how do we deploy these things? There's different ways to implement computing services. When you are working in a network, there's different ways computer networking resources are available. And we're going to take a look at those two main models. Each model has its own benefits, and it just depends on what the business needs. The first model is going to be on-premises deployment. This is the old way. Back in the days, organizations, there was no such thing as cloud. Organizations, I set up, I'm old guys, I set up infrastructure. We set up routers, switches, we cabled them up, we set up the servers, we wired up all the network, all the servers was in our local on-premises. All the computing was in the same physical space. They were in our server room. The infrastructure is owned and managed locally. We had complete control over the environment. It is expensive because we bought our own UPSs, our own server, hardware, rack, you name it, we bought it, and we had to maintain it. Now, this is what's called if you ever see the word on-prem, it means on-premises deployment. Nowadays, cloud deployment. You have entire organizations that has no hardware. They don't have any server. Everything is stored in the cloud. All their servers, all their file sharing, their authentication services, their applications is in the cloud. Provided all the resources are done by a cloud provider. Lower up front, they don't have to buy any hardware. The provider provides all the maintenance and updates, but they don't have any control of the hardware. They don't have any control of the network. The provider does. This is becoming more and more popular. There are organizations coming out today that doesn't purchase any kind of major networking gear, like routers and switches and server gear, like different kinds of rack servers or desktop servers and so on. It's all within the cloud. Big organizations themselves are moving to cloud. Big organizations that once had big data centers are actually moving their infrastructure to the cloud also. And that's called a hybrid deployment. This is a combination of on-prem and cloud. Maybe they have a local file server, but they run on premises, but then they have application stored in the cloud that their users are also accessing. This is a hybrid deployment. It's a combination of on-prem and cloud. Now, why would you want to do this? Well, maybe the on-prem has very secret data. The problem is cloud has some security issues. When you put data into the cloud, remember, if it's in the cloud, it can be accessed from anywhere, technically by anyone. What's stopping a hacker from stealing a company's data now? A username and a password, probably. So maybe the super secret data you want to keep on your on-premises, in your network, in your physical space, and then things you put in a cloud. Now, less critical workloads you can put in the cloud. Okay, these are some concepts that you're going to want to know for your exam. Don't go in-depth into this stuff. They're not going to go in-depth into your exam. There's whole certifications on cloud and virtualization. You don't need to know that. Just understand this from a high level, and I'm pretty sure the exam is going to be pretty easy. In this video, we're going to be taking a look at different types of internet connection. Now, you don't need to go in and be super detailed on the different kind of internet connection. Just understand that there's basically wired internet connection and wireless. Depending on where you live, these are going to be the different services you have. For example, if you live in a big city, you may have cable or fiber optic internet. And if you live in a rural area where there's not much going on, you're probably going to have satellite internet. For your exam, just know that these things exist. Let's get started. Now, there's a wide variety of different internet, like I just told you. And these different internet types that are out there, the different technologies that are out there, has their own unique characteristics. Some are faster than others. Some have longer distance than others. Some are more reliable than others. For example, while fiber internet or cable internet is great, it's not available. The availability is not everywhere. Not everywhere has it. I have a older quote-unquote vacation home. It's like a shack I bought many years ago. It doesn't have much kind of internet. In fact, it only utilizes satellite internet. And depending on the internet, some of them are much faster and more reliable than others. Let's go take a look at them. When it comes into wired, one of the most famous kind of internet connection out there is going to be fiber optic internet connection. This you're going to have a Verizon Fios or Google Fiber, for example. This uses light signals through a cable. Fiber optic cable, the way it works is that it transfers data by passing a light pulse through the cable. The cable is either glass or plastic core. Because this is going to be an internet connection and the cable has to span miles, it's going to be a glass core cable. There are fiber cables that we use in our internal network called a LAN that utilizes a plastic core. Now, this is going to be the fastest available speed. Generally, you can get gigabit transfer speeds, so it's going to be in the gigs, not in the megs. For example, they do come in megs, by the way, but high megs, like 500, 750, 800 megs, 900 megs, 1 gigabit is what they're going to come in. So very high speeds. And one good thing about it is generally, not all the time, generally it's symmetric internet connection. All right, most of the time it's going to be symmetric. This means they give you the same up and the same down. What do I mean by that? Well, for example, when I got the Verizon Fios, it came with 1 gigabit connection. That means it's symmetric. The word symmetric means same. So I can download at a gig and I can upload at a gig. So it's generally symmetric. Fiber optic allows me to have very high bandwidth. In other words, gigabit. Low latency, the data doesn't take long to get there and there's no interference on the line. You see, we're going to talk about line interference a little bit later, things that can affect the transmission on physical media. It's the most reliable, but it's generally going to be the more expensive. The other kind of internet is cable internet. This comes through your coaxial cable infrastructure. This is going to be in a more remote place where they haven't updated the lines yet. Shared bandwidth enabled. It's not a dedicated line. It's going to be a shared bandwidth. This is something that's fading out towards fiber optic internet, but some providers, depending on where you live, may only offer cable internet. It comes through coaxial cable. Coaxial cable, if you see these in the back of your cable box, coaxial cable is what's used to transport the data. Now, this is better than what I'm about to cover next, called DSL. Speeds are not bad. Download speeds are not bad. You can get hundreds of megs. Not bad, but they're non-symmetrics. They're what's called asymmetrical line. In other words, the downloads are always better than the upload. You can get 200 megs down, but your upload may only be 20 megs. Performance varies during peak hours because it is a shear line and it's widely available in urban areas. Widely available. Fiber internet is now coming more and more available. Older things, I had this many, many years ago, 20 years ago. DSL, digital subscriber line. Here's what this does. This allowed you to get fast internet connection. And when I say fast, I'm comparing it to dial-up internet, which was very, very slow. It was 56K dial-up. If you want to know what 56K is, most internet connection today are in the hundreds of megs. This is 56 KB. It'll be 1000 K to 1 meg. So this was very slow. Back in the days when you had dial-up internet, very, very slow. The next level up was DSL, digital subscriber line. And the reason was digital subscriber line allowed them to offer broadband internet, fast internet across existing telephone lines. So they didn't have to run additional cables or additional fiber cables. Dedicated connection per user. Speed dependent on the distance from the provider, depending on where they installed it. Now, this is fading out. I haven't really seen DSL available, but in rural areas where there's no real other way to get cable internet, or there is no fiber internet, they may still have a DSL line. Providers still offer this. They may still have a DSL line because the house has a phone line. So if the house had a manual analog phone line, you can have DSL. Now, it's an always-on connection. It's always coming to your house. It's slower than cable and fiber, and it's available in rural areas. Now, what if you live far out there, right? What if you don't? How can you get internet if you live far out there? Well, there are ways of doing what's called wireless internet. Most internet connectivity that we bring to our house or our business is going to be wired. Think Verizon Fios or Google Fiber or what's the other one? Comcast and all these with their cable internet connection. They are wired connection, no physical wire, uses radio frequencies to transfer data, and there are multiple of these things available. The first one is going to be RF technology. This is when they're going to install big antennas. It's known as fixed wireless broadband service. It requires a line of sight with an antenna. They're going to put a big antenna and it's going to face the provider and it's going to transfer data. This is one way of doing this, RF. The other way is satellite. So as long as it can see the sky, this one is becoming more popular. Starlink is an example of this. Delivered via satellites available in almost anywhere around the world. High latency though, because of the distance between the antenna or the dish and the actual satellites itself. The other one is going to be the one you're familiar with, cellular internet connection. This is going to use what you see here, cell towers that is next to your home, next to your business in major cities. This is how we provide data to our mobile devices. Now you can use these cellular internet, you can actually have them at home now, not just on your phone. Speeds will vary by location and different types of network connections. All right. I don't want you guys to go too much into this section. I don't want you guys to bury your heads in too much into this because keep in mind, there's whole certifications to set these things up. All I need you guys to know is know that they exist and they shouldn't be too difficult on your exam. In this video, we're going to be talking about networking. And to start off, I'm going to be setting up a network. Are you going to help me out? Let's try this really quickly. So here I have a network switch. This is a device that allows me to connect my network cable to, and then I'm going to connect it to my two laptops. And then we're going to be able to share data between them. So here I have this switch that's plugged into port number 2 on the actual device. Then I'm going to connect this to this laptop. These laptops have Ethernet ports on them. And then I'm going to connect the other cable to the Ethernet port. Where is that? That's Ethernet port. If I can find it on this laptop, would be amazing. Here it is. Okay. Network. Okay. There we go, guys. Networking. What is networking? At its core, networking is two or more computers joined together to share resources. What are resources? Well, by connecting these two machines, they can share files. If the user using here can send a document or a picture to this computer, this one can send movies over to this machine. In its basic, most smallest fundamental level, a network is something that will share information. It is set up in order to share data, to share logical data across the network. Now, you don't only have to share data, but you can also share devices. If there was a printer connected to this machine can then use our network, this is a network switch, to then send data and send the printer data to this machine, and allows it to print out. So why do we set up networks? To share resources. That resource could be data, such as files and pictures, movies, and music. It could be devices like printers and scanners also. And that brings me to the exam objectives. So let's go through some of the things here we want to talk about. I just introduced you guys to a network switch, and we'll go through the rest of the different things in here. The first thing up we want to mention is going to be the basis of communication. When we set up a network, why are we doing it? We're using it to share data and resources. The resources is going to be things like printers. It does require, now I want to point out something to you guys. You just connecting a cable like I did here doesn't set these machines up to share. You got to go and you got to configure them. That is beyond the scope of this class. But in things like Network Plus, if you take that course with me, I'll show you guys how to do it. It does require what's called a protocol and standards for it to form. Now, I want to point out the word protocol. This is a word you're going to hear a lot of in networking. What is a protocol? A protocol is just a standard language that communications must follow. Protocol is not just used in networking. It's used in the English language. The English language follows a protocol. It's a protocol itself. Okay? For two people to communicate, they must follow the same protocol in networking. This machine runs a protocol called TCP/IP. For it to communicate with this machine, it must run a protocol called TCP/IP. Stands for Transmission Control Protocol / Internet Protocol. You don't need to go into that for this exam. You'll learn about that in A+ and Net+. But just remember, for computers to communicate, they must have a standard protocol. In fact, you know of one already, HTTP. Hypertext Transfer Protocol. For us to communicate, for you to communicate to a Google web server and get a web page, and for me to do the same, we must be able to read and use the same protocol. So this machine has to support HTTP to get it from this web server. Let's say this is Google web server. For this to send it here, they must have the same protocol. It's the foundation of modern computing. Protocols, the basis of networking. Now, network identifiers. When a computer is on a network, there has to be a way for the machines to be identified. There has to be some kind of unique address. So how does this machine know it's talking to this? This switch that I have here supports 8 devices. So how would it know, hey, this device is talking to this one wants to talk to that one? How would it know? Well, it has to have a way to identify the devices on the network. It allows systems to communicate. Different types serves different purposes. There's 2 types of identifiers. The first one we want to talk about is the one that a lot of people have heard about. It's called IP addressing, Internet Protocol Address. So there are 2 kinds of IP addressing, right? 2 versions of it, IPv4 and v6. IP version 4 is the older addressing. IP version 6, you can see this long number here. It's a hexadecimal, if you're wondering what that is. 128-bit hexadecimal. IP version 4 is a 32-bit address. This one here is just written in decimal. So there's 2 versions of IP addressing. This is the unique identifier for devices on your network. When computers want to communicate on a network, they're going to be utilizing their IP address. In today's world, your computer has both, an IP version 4 and an IP version 6. IP version 4, I don't want to get into it. It's not needed for this class, but technically we ran out of these public IP addresses, and the world is slowly but surely switching over to IPv6 as it supports a lot more addresses. Another way to uniquely identify computers is with a MAC address. On your NIC card, the actual NIC card itself, whether that's an onboard NIC card like I showed you guys earlier, or it's a USB or a expansion card, NIC card that we looked at in the hardware, those have their own unique addresses called a MAC address. The MAC stands for Media Access Control. A MAC address is a unique address. This is written in a hex also. It's a unique address assigned to the NIC card by the manufacturer. All right, it's generally not something you assign. I have never assigned. I have 6 Cisco certifications, and I've taken every version of Net Plus, and I've set up big networks, big and small. I've never had to really change a MAC address on a device. Technically you could, but there's really no need to change a MAC address. Technically all NIC cards in the world have a unique MAC address that's out there, and they're assigned by the manufacturer. This is called the hardware address. If you ever heard the term hardware address, that's the MAC address. The logical address, it's called the IP address. We assign IP address, the hardware manufacturer assigns the MAC address. Now, ports. This, when you study Net Plus and A Plus also is going to drive you crazy. You need to know ports. We're not talking physical ports. We're not talking like a USB port. This is logical ports. Your computer has, they're known as virtual communication endpoints. These logical ports, they are 65,535 ports on a computer. Now, why do we need this? Well, when data comes off the internet, let's say the internet device comes off the internet through the cable into the computer, how does the computer know what type of data that is? How does it know the data coming through its network card, whether it's wired or wireless? Hey, that's a web page. Hey, that's a file. It's because of the port it's coming through. The port directs the network traffic to a specific application or service. So, one of the most famous ports is port 80. Any data coming through port 80 is going to be a web page to show in your browser. Any data coming through port 25, actually sending port 25 is going to be an email. There's all kinds of ports. If it's a secure web page, it'll be port 443. If it's emails, it'll be port 25 to send out data. It'll be ports 110, 143 to receive emails. There's lots of different ports and issues. Port 21 if you're receiving a file, like file transfer protocol. Depending on what you're doing, you're going to use different ports. And every protocol out there has a unique port assigned to it. And there's a lot of ports, as you can see, a lot. As you go through Net Plus and A Plus, it's going to drive you crazy as you have to memorize these ports for the exam. Now, let's talk about basic networking concepts, some basic networking services that you should be aware of. When it comes to basic networking services, common applications, when we use a network, what are we using a network for? When you connect to the internet, what are you trying to do? Well, at its simplest medium, I mentioned, is just to share in data. It's built on a standard protocol. All of it, the protocol that we use to build the entire world on, it's called TCP/IP. It's not one protocol, it's a stack of different protocols. Even though it has transmission control protocol / internet protocol, it sounds like it's 2 protocols, but it's actually a stack of it. Well, but what are some services that are out there? Like when we connect to a network, when we connect to the internet, what are we doing that for? Well, number one is browsing the internet. By connecting to a network and connecting to the internet, you'll be able to browse the internet. If you guys look at the browser, you'll notice it's HTTPS. There is HTTP, Hypertext Transfer Protocol. That allows you to transfer web pages, but it's not encrypted. Hackers can sniff it and see it. With the S, it signifies that it's fully encrypted. It protects your data while your data is traversing the network. And it's indicated by a little lock icon in the browser. File transfer. Another reason you want to connect to the internet, to a network, is we can transfer files between machines. We can even transfer files between countries, utilizing things like file transfer protocol or secure file transfer protocol. There are lots of other protocols that does this, but that's another reason why you'd want to set up a network. Another one is to send and receive emails. The protocol called SMTP, Simple Mail Transfer Protocol, is what we're going to use to send, versus one called POP3, Post Office Protocol, or IMAP. These are protocols we're going to use to receive data. You do not need to know protocols for your exam, okay? Your exam does not cover protocols. I'm just giving you a heads up, just telling you about them. But one reason we would connect to the internet or connect to networks is so we can send and receive emails. Now, these networking devices, you could spend an entire career learning routers, for example. What you just need to know is understand what they do. All right, you don't need to go in depth into them. That means I should disconnect this because this is one of the devices we're going to talk about, a switch. The first thing I will talk about is a modem. In its core, the word modem stands for modulator, demodulator. It converts signal. Back in the days, we used to have a 56K modem. It used to convert analog telephone signal to digital data that your computer can read. So it would modulate and demodulate the signal. Nowadays, modem, everybody just uses the term modem to something that you connect to the internet. So we'll say cable modem. All right. Cable modem, you have people call them DSL modem, fiber optic. People just use the word modem a lot. But for your exam, remember, modem is actually a device that converts signal, analog to digital, and we used to use it to connect to the internet. A router is used to connect different networks together. When you set up large networks, you may have different network. Let's say you have a big company. And you have the sales network, you have the finance network, and you want them to connect and transfer data, you would generally a router. As it connects different networks. Sales network to the finance network. They have different IP addressing and subnets assigned to them. That sounds complex, but just remember it connects different networks. Where you would know it is, you would be connecting your internal private network to the big global internet. You're going to use a router for that. A router is how you're going to be able to connect your private network to the entire global internet, that public network. You're going to be using a router. So it's translating between your private internal IP addressing to your public IP addressing. Inside of your local network, you're going to want to connect your devices, your laptops, your desktops. If they have an Ethernet connection, you're going to use one of these devices, a switch. This is a bigger Cisco switch compared to my tiny little switch. This connects devices within your network. They create what's called a separate collisions domain. It's more intelligent than basic hubs. Now, back in the days, they used to have a device like this that we used to connect computers to called hubs. They don't exist anymore. Hubs used to have the data collide. Now with switches, we break up the collisions, and all that means is that when data comes into one port of the switch, let's say port 1 wants to talk to port 3, it comes into port 1, leaves on port 3. A hub is different. A hub would take data in from port 1 and send it to every port. And if somebody else sends data, it's going to collide with it. In other words, using a hub is very slow. Using a switch is much faster. So we say separate collision domain. It's much more intelligent than basic hubs. Hubs and switches looks exactly alike. Like if you see a hub, you wouldn't know it's a hub. Or if you see a switch, you wouldn't know it's a switch. You have to go and look at it. This one literally says the word switch. This one literally says the word switch on it. Access point. Now, an access point allows you to have wireless connectivity. If you have a network at home and you want to add wireless connectivity to it, you have your own switch, you have your own router, you would buy an access point, like this Cisco AirNets. An access point allows you to extend your wired network. Like for example, let's say I have my switch and I connect these two machines to it, and I want to add wireless. Well, I just buy an access point, plug it in, like this device, and that would give me the ability to take in wireless connectivity into my network. So remember, an access point allows you to give a wired network wireless connectivity. It's the central point of where all these Wi-Fi devices would connect to. When it comes to securing a network, you're going to buy one of these devices. This is a sonic wall. This sonic wall is used to, this is a firewall. This is going to use to block unauthorized traffic. Can be hardware or software. Your your computer has software firewalls, but a firewall allows you to block unauthorized traffic attempting to get into your network. This is a network firewall. This one sits at the edge of your network. The internet connection will plug into it, and then all your devices can plug into it. You can plug a switch into it. You plug in all your devices. This one also has a built-in access point. Some firewalls doesn't have this. This one has a built-in access point. And what you would do here is once you have all your devices connected, this will protect it. But you also have software firewalls that are installed on your desktop. That way, if there's a virus, this device stops viruses coming into your network. But if there's a virus already in your network, a software firewall can stop it getting to your computer if it's transferred within the network. For example, let's say Bob goes and downloads a virus. This is Bob's machine. And you have a firewall here. Well, the good news is that the virus can't get here because you have a software firewall. So the software firewalls are inside of your machines. Let's take a look at some different network models that are out there. How are we going to set up a network? Different approaches, different organizational size. They have their different characteristics and defines how devices will communicate. Because there's two models I want you guys to know, client-server and peer-to-peer. Now, in a corporate network, client-server is how everything works. On a corporate network, you're going to have a client-server model. The way this thing works is like this. What you're going to have is you're going to have a central server, and all the computers in the network connects to it to share data. So it's a central server, one device, provides services to all the actual computers in your network. You can have a web server, you have an email server, you have a file server in the network. Client server. So generally a server serving up everything for all the clients. You want this because think about this. Imagine you're working in an office with 20 people and everybody is sharing data with everybody. Everybody has to. They have to share data. They have to share spreadsheets and documents between each other. And everybody's just sharing data with each other. It will be a nightmare to maintain. If you're the administrator, how are you going to back it up? You're going to back up everybody's machine? Or you can have one machine where you have one server where everybody put data on and you just need to back that up. What I just explained to you was a peer-to-peer. And a peer-to-peer, all devices are sharing like a server and taken like a peer. All right, sharing like a server and taken like a client, I should say. A peer is a device that acts as both a client and a server. There's no central authority. Everybody is sharing and taking. Data is all over the network. You got 20 machines and everybody's sharing and taking. It's chaos to manage peer-to-peer networks. In big organizations, we don't use clients. We don't use peer-to-peer. We use client-server. Now, when it comes to a network, there's two main networks that we talk about: LANs and WANs. All right, LANs and WANs. A local area network. This is a network that has a geographical limitation of generally a building. All right, a home, an office, a school network, generally within a building. So if your network is within a building, within an office, within your house, you have a LAN, a local area network. It's generally very high speed connections. This you can support up to a gigabit on this. Versus a WAN. It's a wide area network. It connects the globe together, spanning large geographical areas. Have you ever used a WAN before? We all did. The internet is the largest WAN that you have out there. It connects all the LANs together. Think how the internet connects the world together. Whoa, this was a long one. Lots of terminologies here, guys. This is a career. Networking is a career. Learning about how to configure devices, Cisco networking is a career by itself. I think it's a really rewarding career, something you should check it out. I went down the path of becoming a network administrator. I did up to CCIE written. If you want to know how smart that is, just look it up. I'm not saying I'm that smart, though. I never finished it. I did Cisco, CCNA, CCNP many years ago, and I didn't follow it up. I did system administration instead. But networking is a fascinating area. There's a lot of jobs for it. You guys should check it out. Hopefully you enjoyed this section on the introduction to networking. Let's keep going. Let's talk about wireless. In this section, we're going to be looking at the different wireless standards. You don't have to get specific about them. You don't have to memorize their speed. You just have to understand that, hey, the newer it is, probably the faster it's going to be. Understand what interference is about and attenuation. And I want you guys to understand about the different bands that are out there. This is on your exam. You need to know the difference between them. I have a slide on that. But before we get started, let's talk a little bit about wireless. Let's say you go out and you buy a wireless router. You buy a wireless access point. There's some settings that you're going to see in there that you may not know. I want to show you what I mean. So let's say you go out and you buy an ASUS device like this. This is a newer one, wireless 7 router. Your exam only mentions up to wireless 6, by the way. And you buy this device. You plug it in at home. It's configured using a web interface. Well, if you want to see what the web interface looks like, it's going to look similar to this. This is demo.ui.asus.com if you want to check it out. It's demo, D-E-M-O, UI, that's user interface, .asus.com. Or you could just Google ASUS router demo. That works too. So I want to show you guys. So this is what it would look like if you're configuring the router. It's a demo of what the interface would look like. And I'm going to go down here to wireless. And you'll notice a couple things. Now this one here does not support the band of 6, the connection of 6. This only supports 2.4 and 5. We'll get to what those are in a minute. But you notice how you can go in here and you can say, well, I want 5 gigahertz, or I want 2.4, and I want 5. You see, you can just select the wireless bands there. You can go in here, 2.4. This router supports 2.4, this access point, 2.4 and 5 gigahertz in there. And then you can specify different types of channel. It's on channel 8 right now. We're not going to get into channel. We're going to talk about that doing A+, and so on. So you notice how you can specify and select that. And that's important because these bands here is what I'm going to be talking about. Let's get into it. The first thing I want to talk about is the wireless standards. 802.11 specifies wireless standards. The 802 is the standard, computer standards. That 11 is wireless. And then there are these specific standards like N, AC, and AX. They all have all kinds of letters in them. The ASUS router that we have, this one here, let me show you guys. This one is now called Wi-Fi 7. They stopped using these names N and AC and AX. Now they just say Wi-Fi 4, 5, 6. The new one is 7. That's going to be the newest one. Even this motherboard that I bought 2 weeks ago is now just Wi-Fi. Hard to see that. It's just Wi-Fi 6. So that's going to be the AX. Now, wireless N is up to about 600 megs. Wireless 11, the AC, this support up to several gigabits. 5 gigahertz focus, much more channels were supported. AX, high throughput, highly efficient. This is going to be the newest one here. 2.4, 5, and 6 gigahertz is out there. And if you're wondering, why does this matter? Why would I want to go? You see on the router, you can select whether you want 2.4 or you want 5. Why would you want to go with 2.4 versus 5 gigahertz bandwidth bands? We'll talk about. Now, with these standards, different standards has different speeds. Different standards supports different bands. And that's where standards are important. For example, if you went with the older standard, you're only going to get 600 megs. The newer standard can support multiple gigs and more bands. So the higher the standard, the more speed you get, the more bands you get. Now, wireless signals could be interfered. Okay, by what? By other wireless devices. If there's a lot of people using wireless, it can start to interfere, especially if there's a lot of people using a channel. Microwave ovens affects wireless signal. It interferes with it. So does baby monitors. Physical obstacles reduces the signal strength significantly. So if there's a lot of walls between where your access point of your router is versus where your device is, it's going to really significantly, and the thickness of the wall matters. So that's interference. The other one is called attenuation. If there's one thing we know, the farther you walk away from your wireless routers or your wireless access points, the weaker that signal gets. So attenuation means the greater the distance, the weaker the signal. Walls and floor was, of course, block signals. We talked about building materials will stop signals from penetrating. But understand this term for your exam, attenuation. The longer the distance, the more weaker the signal. Attenuation just doesn't apply to wireless. It also applies to wired connections, like copper cables, like coax cable or Ethernet cable. The longer that cable is, the slower the connection gets because of attenuation. Now, we just mentioned newer standards. Newer standards are more performance. They also support more security. All right? They handle more devices. So you want Wi-Fi 6 or 7. Right now, we should be using minimum is Wi-Fi 5. Band option. Now, this is important. You're almost guaranteed a question on the bands. 2.4 versus 5 versus 6. Each band has a unique set of characteristics. They have different frequency. Now, for your exam, you don't need to go into the specifics, but understand, not every standard supports every band. All right? And you got to understand different bands, depending on what you're using, you should use a different band. Depending on what you're doing, depending on where you are. If you have great distance, you might use a different band than if you have shorter distance. You'll see what I mean right now. So memorize this. You need to memorize this for your exam, okay? I try to condense it as small as possible, just to what you need to know. So as you saw the ASUS router, you could go with 2.4. 2.4 allows for longer range. So if the user is going to be farther away from the access points, 2.4 is good. It's longer range. It has good wall penetration. More interference and congestion in this one, though. There is a lot more because a lot of people uses this band. A lot of interference can happen here. A lot of different devices uses this, so it's very congested. But it has lower speeds. The only good thing about it is that it allows for longer ranges. A lot of devices operates in this band, and it's not that quick. But it does have longer range. So if you're going to be very far away, you might have to use 2.4. 5 gigahertz, this band has higher speeds, much faster, and I'm saying much faster. It has more channels, so it has lower congestion, but it has a short range. 5 gigahertz doesn't work if you're going to be very, very far away from your router. All right, it does have reduced band. It's less interference than 2.4. Not many devices uses it. The newer one, 6 gigahertz, and this one, much faster than 2.4, very low congestion, but you need new hardware. For this to work, you need to have, your router has to support it, and your wireless NIC card has to support it. So like this motherboard is telling me that the Wi-Fi card on the motherboard supports the 6 gigahertz, that supports the 6 gigahertz band. So you need to have new hardware, shortest range. So it doesn't have as long range as this 2.4 will. Most attenuation, in other words, the farther you go, the slower you're going to get very quickly. But this does support the fastest speed with least amount of congestion. So if you want the fastest one, go with this. If you got the longest distance, go with this one. Not every device supports this. If you want the faster speeds and you don't have 6, you might have to go with 5. Know these for your exam out there. All right, that is the wireless. Wireless can get very complex. In this course, you don't want to go too much in depth into it. In the other certifications, you will. But understand the difference of the bands that are out there and the different standards for your exam. In this section of the course, we're going to be talking about software, particularly 2 kinds of software. Your operating system, that's things like Windows, and the applications you utilize, like Microsoft Office. We'll take an in-depth look at different things such as the file system characteristics in your operating system, file management, like what are folders and files, systems application that you should be familiar with, services, processes, drivers, and even the different interfaces in this video. Throughout this section, this is going to be section 3. Throughout this section, we'll also talk of different kinds of applications. Let's get into it. So the first thing I want to talk about is going to be this concept of what is known as file systems. What exactly is a file system? Well, to understand a file system, you must understand that an operating system, what exactly are operating systems? Well, operating systems are things like I have here Windows 11. Operating systems are things that sits on the hardware itself. So when you build a computer, the physical box, when you build it, it doesn't really serve any purpose. It can't do anything. In order to make that hardware usable, you're going to have to install an operating system. And famous operating systems are going to be things like Windows, the Mac OS, Linux, Unix. Operating systems are out there. Now, what does the operating system do? Well, it's a software that manages all of the computer hardware. It's the interface between the hardware and the applications. You see, technically speaking, an operating system is not very useful. It doesn't really serve any purpose or function other than to interface with the hardware. Things that we use, when we use a computer, we're actually using the applications on the operating system, or what we install on the operating system. For example, Microsoft Windows is pretty useless the way it's set up. It looks nice, but it's used as a launcher in order to launch our applications. Like when I sit in front of a computer, I don't actually use Windows other than to open my apps. Like if I'm using Microsoft Word, Excel, my web browser, my database software, if I'm playing a game or something. So what exactly is the usefulness of the operating system? Well, it's there to interact with the hardware, and it's what's going to allow us to install those applications that we're actually going to use. So remember that. It's the interface between the user and the actual hardware itself. Now, in these operating systems, there's something we call a file system. File system is how data is organized and stored on the actual computers themselves. There are different features and enhancements and different functionality between the different types of file systems. For example, some file systems allow better security. Some file systems allow you to encrypt data or compress data, while others does not. Some supports big file size and some does not. Some allows more security and more efficiency. Let me show you guys how to find that on there. So I'm going to go back here to my operating system. So this is my Windows 11 is what I'm going to be using to teach this course. And you notice that all right, we got a lot of stuff installed on here. I'm going to right click on the start button, and we're just going to go all the way here to File Explorer. You guys see this? To File Explorer. Now if I go to File Explorer, oops, it opened on this side. I'm going to go to this PC. And you see, this is the computer that I'm using. And I want to show you guys how to find your file system. So what is your file system? So I'm going to go right here to my C drive. And I'm going to right click and go to Properties. And here I can see the file system is NTFS. This is the file system that is used on most Windows boxes. This particular file system allows me to encrypt data, sets security permissions, and so on. So by understanding this, these file systems that are out there, every single one of your operating systems will support a file system. Mac has one, Linux has one, and so on. Now, if you're asking, hey Andrew, do I need to know all those file systems? Not for this exam. For the other exams, like your A+, yes, but for this exam, just understand what's a file system. Remember, a file system is how we're going to store, organize, and manage data. Now, some file systems allow us to encrypt and compress files. So compression allows you to reduce a file size. Maybe you got a really big file on your hard drive and you just want to make it smaller. Well, if you compress the file, it's going to allow you to save space and reduce it. Windows has a built-in ability to compress data, and I'll show you guys how to do that in a second. And you can use third-party like WinZip. It's a very famous, or WinRAR, are third-party tools that we can use to compress data. Generally speaking though, if you compress your data, there is going to be a trade-off between the size and the access speed. In other words, when you compress data, it slows down trying to access the file. Because every time you access the file, the operating system has to uncompress it to utilize it. The other thing here we're going to talk about is encryption. This protects data with mathematical algorithms. Take, for example, why would you want to encrypt your data? Well, let me get my laptop here. Let me give you an example of this. Let's say you have a laptop. You got confidential pictures. Maybe you're working on a secret project that you don't want anybody to know about. Store it in your laptop. Then you go out one day to dinner somewhere and you leave your laptop in a taxi somewhere. Bad guy finds your laptop, right? And they try it, they open it, and they're going to steal your data. Well, here's the thing. They don't know your password. And if you're saying, well, without the password, Andrew, how can they get in and see my data? They just take the hard drive out. They just take the hard drive out and they mount it to another computer. They don't need your password. They just log right into your hard drive and they can see all of your data. Unless you had encrypted it. So you can encrypt data right in your operating system. And I'm going to show you guys how to do that in a second. This will prevent unauthorized access. So unless they know your password, they cannot decrypt the data. The password is like the key to holding that data. This is called EFS, or the encrypted file system that's built into the Windows operating system. It's generally built into things like your modern operating system. Now, before I get into the different types here, I want to show you guys how you can compress and encrypt the data. So let's go back to my desktop here. I'm going to make a folder. Right click. I'm going to say new. And I'm going to call this folder my stuff. Now I'm going to right click on it. I'm going to go to properties. And I want you guys to click on advanced. See this? And I have two options. Remember I said that the different file systems supports compressing the data. That's right here. It also supports encrypting your data. That's right here. Notice you can't do both. You can only do one at a time. Now, I'm not going to go into the differences and what does allow you to do both and so on and so on. Just know that this is how you do it. So what I recommend for you guys to do, if you're in a Windows operating system, especially on your laptop, and you have confidential data that you're utilizing, I would highly recommend for you to encrypt it. Just check the box and just say OK. And everything in this one here, notice, back up your encryption key. Notice that this folder and everything inside of it is going to be encrypted from now on. That way, if anybody ever tries to steal your laptop or your desktop, they're not going to be able to access your data. Okay, moving on here. What are some types and extensions? Well, different kinds of file systems that are out there. I mentioned NTFS, the one my computer is using. NTFS, the older FAT32. Another one is exFAT. You have Apple file systems, and you have ext4 for like Linux operating systems. So those are some different file systems. You don't need to memorize that. I just put it on there. The other thing I want to talk about is going to be extensions. So anytime you look at a file extension, files are not just name a file. Every file has an extension, and some popular ones are like .exe for like a program or application. .doc, this would open Microsoft Word. JPEG, this here would be like a picture, or .txt for like a notepad document. When you look at files on an operating system, so let's open up this file here. When we look at, I'm going to right click and say new, and I'm going to make like a text document. You notice this file extension right here. You see that file extension? That tells Windows that that is a text document. For example, let's open it up and let's put my secret data. Okay, I misspelled the word secret. Guys, don't bad talk my my spelling. Okay, I'm not very good at that. Okay, so you can see how it knows if I double click it, it opens up in Notepad. But look at this. You see, when you have file extensions, like if I change this, if I just take it off and I change it, look at this. You try to open it, Windows is like, hey, what is this? Where do I open this? What program am I going to open this with? The extensions tells the operating system, see if I put .txt, tells the operating system how to open that file. That's important, all right? Because the operating system needs to know, okay, that type of document needs to open with that type of application. So those are what extensions, file extensions, are used for. For example, if I right click here and I say new, let's go up to Microsoft Word document. So notice this one is .docx. So this is a Word document. docx generally opens in Microsoft Word. So let's call this one data. If I open this up, you'll notice this opens up in Microsoft Word. Let's type anything in there. Save it, yes. This is why you want to ensure that you understand different extension. Now, this course is not about memorizing knowing file extensions in depth. That's not what this course is about. But I'm just telling you guys that file extensions, every single file in your operating system will have an extension. And that extension is what's going to tell your operating system what application to use. The next thing we want to talk about is file management. So how does an operating system organize the files, right? In an operating system, you're going to have many, many different files, many different quote unquote folders. So how are we going to put this into management? Well, file management is about organizing and controlling access to all the files within the operating system. It's an essential function that we're going to be doing, and there is user and system level access, which means there's a level where users are going to access files and folders, and there's one where systems are. We're going to look at the user aspect of this. So files and folders. Now, I just showed you this. In an operating system, you're going to have folders like I have here, and inside of your folders, you're going to have files. So file and folders. Folders contains files. That's what you need to know. Inside of a folder, you can make another folder, and then you can start organizing your data. Maybe you could say data here. And then I can make another folder called pictures. Maybe I can make another folder called movies. And then as I put my pictures into this, I can then put it here. Maybe I have some data, I'll put this here. Maybe I have a picture, so I can say new. Okay, I don't have any graphics thing here. Oh, I do have. Let's call this one picture. Then I can put this inside of my picture folder. So when I open up my data, I can see data. I can see inside of here I have picture. So that's important. In an operating, when we are working in an operating system, we have files and folders. Folders just contain files or other folders. Files is what we actually use. We don't actually utilize folders. Folders are containers for storage, versus a file is what we actually use. A file is going to be like a text document. It's going to be like your report you're writing. It's a presentation. It's a picture. It's a movie, something like that. Now, permissions. Inside of these files and folders, or I should say on these files and folders, you're going to have permissions. Permission is going to control who can access these files and folders. We can control, hey, some of these users can write to them, some of them can read them, some of them can't see them. Different for users and groups. Now, this is not something that you should be assigning. This is something that a system administrator in an organization is going to be assigning. Let me show you what they look like, but it's not something you should be configuring at this level or in this particular exam. When you want to see permissions on a folder, you can just right-click on it. You can go to Properties. And if we go to Security, this is the permission structure. You see it says Permission. You can then edit this, and you can add and remove users. So by editing this, we can say that Mary, well, she can log into this folder and see the documents, but she can't add. You can then add Bob and say, well, he can log in and he can add documents and update documents. And then we can say Peter, well, he's denied access. So in this structure of permissions, we can now use our file system in order to provide security. Because if you think about it, in an organization, not every user needs access to all the data. Some users don't need access to certain data. For example, salespeople don't need access to financial data. So maybe we want to deny those folks access, but people in the finance department, they need access. Now, naming restrictions. When you try to name files and folders in your operating system, there might be a certain restriction that you should know of. For example, in Windows, we have a 255 or 256 character limit, and you cannot use certain characters when you name your files and folders. These are rules that are applied. So if I was to look back at my desktop, and let's go ahead and create a text document. So I have this text document. Now, when they say 255 characters, they're talking about characters on the keyboard. But I also said that there were certain characters that cannot be used. For example, you can't use a question mark. Watch what happens if I try to put a question mark here. You see that? Look at what it says. A file name cannot contain any of the following characters. You see that? So that means if you're naming a file, can't contain that. If you name it a folder or anything like that. You see, if I make a folder and I try to put in some, let's put that question mark again. Can't do it, right? So it's the same concept. This is called a naming restriction. This is when the operating system is restricting us to what we can put onto certain names on a file. Okay, moving on to the next thing here when it comes to these operating systems is going to be applications and utilities. All right? Applications and utilities that comes built into the operating system helps you to keep your operating system running well. These things allows us for proper operation, allows us to do maintenance, and they're generally built in for system management. Things like managing your display, your sound, your notification, your power settings, and so on are different utilities within the actual operating system. Now, for this exam, you don't need to go and utilize these utilities and know how to fix them. You just need to know they exist. In your other certifications, you're going to do that. I'm going to show you guys a bunch of these coming up here in a minute, where they're located and what they look like. Let's get through them. The first one I want to mention, one of these utilities that you're using is something called a service. In the background of the operating system are small little applications that are running that's essential to make the operating system work well. For example, you need to have networking services running on your computer for you to be able to send and receive data. These are called services, the little background programs that run on a continuous basis. They provide full functionality. For example, networking services, if that one is shut down, you can't send and receive data, means you can't be on the internet. You also have a print spooler. If this one isn't running, you can't print. So services are really important for the functionality of the operating system. The other one you have here is going to be processes. Now, processes, these are running instances of programs. In other words, what are you currently running right now? What is, like, you have your computer on, your computer is running a little bit slow, and you're like, what the hell is taking up all of this resources? What's taking up my RAM? What's taking up my processor? And so on and so on. Well, when you look at your process tab, you'll be able to see all the different processes that are running, and I'm going to show you guys how to find that in a minute. Each one of these processes has a unique identifier, and the operating system is managing the execution of these processes. So the operating system manages the execution of these. You're going to want to know what processes are running. So remember, what are processes? These are the applications that are currently running right now on your computer. Now, the other thing here is called a driver. I mentioned this in the hardware section. Drivers are software that interacts with the hardware. The driver tells the operating system how to utilize that hardware. So if you was to install something like a video card, well, Windows may not know how to use that hardware particularly well. Windows may not know how to optimally use it. So what Windows has is a driver. You would need to install that driver, or Windows may contain it. You can get drivers from places like the manufacturer website of the video card that you purchase. So these software controls the hardware. They're the bridge between the OS and the hardware itself. You have to make sure that when you download drivers that you match it to the operating system you're using. Because generally speaking, drivers are specific to the OS. You'll have drivers for Linux, drivers for Windows, and drivers for different versions of Windows also is not uncommon. Let me show you, before I get into interfaces, some of the different utilities like drivers, processes, and services that I just mentioned. So I'm back here at my Windows, and I want to show you guys, the first thing I want to mention is services. So I'm going to right click on Start, and you notice you have a lot of things here that's going to be showing up. Now, you notice services is not one of them. So let's go to computer management. All right, right click. We're going to go to computer management. And I'm going to, you see where it says services and applications. I'm going to open that up and I'm going to go to services. Now, this course isn't about going through all of these, but these are all the services that we are currently running on our operating system. And if I shut these things down, a lot of bad things can start happening, especially if you don't know what you're doing. Like one of the ones I mentioned earlier was the print spooler. And that's this one. Where is that thing? Print spooler right here. So if I was to go and I was to right click and stop this, well, I wouldn't be able to print. That's why it's not recommended for you to play around with this unless you really know what you're doing. The other one we mentioned are processes. Now this is something you should keep an eye on. Processes is going to tell you, hey, what are the current running programs on my operating system? I'm just going to right click at the bottom of my screen. I have what's called a taskbar. I'm going to right click on the taskbar and I'm going to go to Task Manager. And in the Task Manager, these are all the processes that I'm running. And you guys can see we have some anti-malware software. We have the OBS Studio I'm using to record this. We have our Internet Explorer, and you can see all the resources it's utilizing in memory. You can actually click on the actual resource, like the CPU, and you can see which one is taking up the most CPU, which one is taking up the most RAM. You click on it, and it sorts it by that. And you can see all these different processes that you're running. Now, you can right click on some of these and you can end them. I wouldn't recommend you doing that unless you really know what that process actually is. Okay, the other one we talked about was the drivers. Let's right click on Start, and we're going to go to Device Manager. Now, I showed you guys this back in hardware, but these are all the hardware components that are installed. So I'm going to go here to Display Adapters. Here's my video card. I can right click and you notice Update Driver. I can go to Properties and Driver. So we already have the driver installed for our video card. But if you don't and you notice your video card isn't working, here's where you can update that. Okay. All right, so those were services. We talked of applications, services, processes, and drivers. Coming up to the end of this video, let's talk about the interface. When you're utilizing an operating system, there's a couple different interfaces you can use. The interfaces determine how we interact with the operating system. Not everything is done in every interface. That's something I want to mention. Not everything is going to be done in every interface. The most commonly used interface is going to be not the command line. The most commonly used interface that we're going to be using is going to be our GUI, Graphical User Interface. This is what it looks like for Windows. What I'm using, it's a visual interface. It has windows that pops up. It has icons we're using, point and click, easier for beginners. As administrators, we're going to be using this thing. This is a command line. And the command line is going to be what we're going to use to type commands and administer the operating system. It's a text-based interface, not good for beginners. Learn more about using a command line in courses like A+, which you will need to know it, Network Plus, Security Plus, and so on, where we really will utilize the command line. So this is more for an administrator function than the graphical user interface that is out there. Now, the other thing I did mention and I showed you guys about was I showed you guys the file attributes. I showed you guys how we can encrypt and compress files. I also showed you guys where we can set permissions, and that's done with the file attribute. You just right click on the file or folder and you go to Properties and you're going to get this screen. This is where you can learn about the size, the date, the system designation of the file is all going to be listed here. And I just want to show you guys that one more time before we end this video. So when you right click on a file or folder and you go to Properties, you'll notice this is the box they're talking about, the attributes. Here you can tell how big something is. You can see when it was created. You can see when it was changed and so on. And you can also go in and see the security permissions I showed you. You can also go in here and encrypt it or compress it like I mentioned before. All right, long video, lots of things to be covered in this video. Make sure to review this. A lot of these terms will be appearing on your exam, so just ensure that you understand them. Andrew from the future. If you're enjoying this course so far, once again, if you would like to get the course notes, the presentation I'm using, you would like to get practice questions, and just watch it without, I'm pretty sure YouTube is going to put a lot of ads. If you would like that, don't forget to check out the links below. My website, tiaexams.com. You can get this course for just $9.99, the price of basically 2 cups of Starbucks. And you can also, I think this is also going to be on the Udemy platform if you have that also. You can get the course notes, you can get practice exams with it. Let's keep going in the course. Okay, let's talk about some of the things that the operating system is going to be doing, such as disk management, task and process management, application, and so on. And then we'll take a look at some different kinds of these operating systems that are out there. Let's get started. The first thing up is you got to understand operating systems. Anytime you hear the word OS, what's your OS? Well, they generally mean operating systems. And remember, the operating system is the core software that manages your computer. And there's different forms of it. The 2 most popular ones that is utilized by users like me and you is going to be, are you a Windows or are you a Mac user? Well, I'm both. And they provide essential services. They allow us to install our programs, manage our physical hardware, such as our hard drives. This here is the gap between what we want to use the applications and the hardware layer itself. Now, this we just mentioned. It is the interface between hardware and applications, right? Because you have your application, Microsoft Word, you have the hardware, the processor, the RAM, the hard drive, the motherboard. What sits in between it? The operating system is what's doing that. The operating system is going to translate what's needed for the application to function through the hardware. Applications don't directly access hardware. Applications have no idea what hardware is. What the application know is the operating system. Applications are not written specific, generally speaking, specific to hardware. Applications is generally written specific to an operating system. You have some apps that are installable on Mac that you can't install on Windows. You have some apps that are installed on Linux but can't install on Windows, and there's a lot of apps that you can install on Windows but you cannot install on Linux, even though they run the same hardware. So that tells me that applications don't actually speak to the hardware. The applications are speaking to the actual operating systems themselves. It provides a standardized programming interface with the actual application themselves. It is known as the hardware abstraction layer. This here, remember, hardware abstractions, applications work on different hardware. All right, doesn't matter the hardware, applications work as long as they have the operating system. It's the OS that handles the hardware specific details. It simplifies software development. Why? Because software developers just has to write their applications to work on an operating system. The operating system takes care of the hardware. Operating systems, application makers don't need to worry, well, is it going to work with this RAM? Is it going to work with this motherboard, with this processor? No. Yeah, software makers, all they got to worry about is, will it work with this operating system? And then the operating system talks to this hardware. Disk management. Your operating system will control and manage your disks, your hard drives, your solid state drives. The operating system organizes the files and folders within it. It manages and allocates the disk space as needed. So it controls the storage devices. Operating system manages the file system creation. It does disk defragmentation and optimization. It backs up and even recovery to different file and folders. The word defragmentation means this. As you utilize an operating system and you delete and add and delete files, your files become fragmented. Well, what does that mean? Well, here's a disk, right? Inside of this is a platter that spins. Imagine you write data here, and then you write data here, and then you write data here, and you write data around, let's say, the 4 edges of this picture, this sticker that I have on this driver. Let's say you put some data here, put some data here, put some data here, put some data here. Well, these are fragmented files because the data is scattered across. Defragmentation is when you take all your files and you put them maybe just in one section. So the disk doesn't have to spin. This works, defragmentation is mostly done on a hard drive with a disk spinning, so it doesn't have to spin a lot. because all the data is in one section, the disk doesn't have to spin around a lot. It makes it faster and increases the life of the drives. Tasks and processes. In the previous video, I showed you guys the task manager. And in there, we saw a whole bunch of processes that was running. You know what? I can show you that again. We can right-click on our taskbar at the bottom, and we say Task Manager. And in here, you guys can see all of my processes that are running. Who's controlling this? Well, the operating system is going to be managing all of these tasks that are here. It allocates the CPU to them. You don't go and allocate CPU, right? When you open up an application, you don't go and change the CPU access or up it or lower it, right? It just does it itself. It allows us to handle multitasking. So you notice we can have many things. The word multitask means running many applications at once, and you notice how many tasks that I can have here. Process scheduling. The operating system will determine which programs to run and when. Certain times the operating system will terminate programs, it'll add programs, depending on what you're doing, depending on what applications you're running. It wants to allocate resources in a way that's fair and doesn't bog down the operating system, doesn't make it too slow, doesn't lock up your system. Unless, of course, your computer, your physical hardware is not powerful enough. Maybe you don't have enough RAM. Maybe you don't have a fast processor. Maybe your hard drive is slow and you're running a whole bunch of applications. In that time, or in that sense, well, it's going to be a very slow process. So the operating system might lock up if you're actually lacking physical resources. The operating system, of course, allows us to install and remove software as needed. This here allows us to manage our applications dependencies and control the permission. So I want to show you guys that in the Windows OS, so I'm going to go back here. You can right click on this. Actually, you know what? I'll show you guys easier way. Just go to Start, and you can just type in Control Panel. See that? If you just go to just type in Control, it's just easier to find it that way. You click on Control Panel, and in Control Panel, you have a lot of things in here. All right. Now this is where you would start to change the settings in your operating system. If I go to Programs and Features, all right, let's make this large icon so you guys can see better. Programs and Features. In here are all the applications that I have installed. For example, I have Adobe Creative Cloud. I have the Microsoft Edge browser. I have things on my Wacom tablet. I have WinRAR. I have a lot of different OBS Studios. I have VirtualBox. So you can right click on these and you can uninstall it. So this tells me that in the operating system, it gives me the ability to actually uninstall applications. Generally, to install an application, you would just download it or pop in a USB stick and you would just double click it and it would just install. One of the things we have to do is when we are running applications is we have to make sure that our applications are compatible with our operating system. That's important because not every app works with every operating system. I mentioned earlier, you have applications that would work on Windows but wouldn't work on a Mac, and vice versa. For example, Apple doesn't make certain things like Final Cut Pro video editing software for Windows. But on Windows, we have Adobe Premiere video editing software that works on Windows and it works on Mac. So you got to remember, not every application is compatible with every operating system. When you want to do an application, make sure it is. If you're running the Linux operating system, not many applications work on that operating system. In fact, very few do. So that's one of its major limitations. So you got to ensure your program runs correctly, handles different software versions. That's another thing. Sometimes you have applications that would work on Windows 10 but wouldn't work on 11, or works on Windows 7 but doesn't work on Windows 11 because it's newer. It manages what's called a system library. These are all the operating system files needed to make your applications run securely. Your operating system controls hardware device access. We saw earlier in another video I showed you guys how to access your device manager. It loads and manages all the device drivers. Remember, the operating system is controlling those device drivers, and you got to make sure you give the operating system the correct driver to ensure that it communicates with those devices correctly. Now, all devices is going to be sending and receiving data from the operating system. This is things like printers, networks, and storage devices. You want to make sure that you have the right driver to make that work. This provides a uniform device interface. So now we can go into Device Manager, showed you in a previous video, of where you can have a unified space where you can see all of the devices that are out there. It allows access control. What's access control? Well, it allows us to manage users, control and add users to our operating system. Let me show you guys that. So I'm back here at the control panel. If you don't know how to get here, once again, you can just go to Start and just type in Control Panel. It's the easiest way to just type the word Control. You see it just popped up. I'm going to go here to User Accounts. Here, you can go in and you can add and remove users from your operating system. So you can say, hey, you know what? I'm going to add this user. I'm going to remove this user. Notice here, you can manage another account. Here you can, this is the administrator. You can change your account type. So here's where you would do that in order to add and manage users. Now I want to point out that something like this is more for your administrators, not really for home users. A lot of time in a home user is just one user using a PC or a Mac, and they generally just have one user. But a lot of times on some computers, especially in an office, you're going to have computers that are utilized by multiple users, and this is probably going to get done by the administrator. User security. When the operating system creates users, it's going to secure those user accounts with what? With passwords, right? You can't log into your account if you don't have a password. It controls, so first of all, it authenticates the user. The word, I want to define this term. There's two terms you should understand. We're going to talk more about this in security. Identification, authentication. Identification is telling somebody who you are. I'm Andrew. Authentication is proving the identification. So if I come to you and I say, I'm Andrew, and you say, okay, prove it. And I take out my driver's license, I'm like, this is my license. And you look at it, you're like, okay, I believe you're Andrew. That's the authentication. You see, identification is just telling people who you are. Authentication is proving who you are. To a computer, can't read your license, right? So when you go to a computer and you type in your username, Bob, and you type in, that's the identification. When you type in your password, that's your authentication. Now you're proving to the computer, hey, I'm Bob. And how are you proving you're Bob? Because, well, I am Bob because I know Bob's password. And assumingly, the operating system assumes that, you know what, if you know Bob's password, you're probably Bob. So remember that term, authentication and identification. The operating system controls what users can access. So in the previous one, I showed you guys how you can set permissions on files so it can deny or allow access to certain types of data. So it prevents system from unauthorized use, right? Maybe you don't want certain users accessing certain data. Now, what are some operating system types that are out there? Well, in this course, I should say, so far, I've been utilizing the Windows operating system. Why? It's the most used operating system in the business world versus Mac is probably used a lot in home. And because Apple products are generally expensive, it may be popular in the United States, but it's not very popular in the rest of the world, as a lot of the rest of the world still utilize Windows. So different operating system for different needs. They're not just home-based operating system. They're operating system for businesses, like what you would have in a big data center or big business, like server operating systems. They're specific operating system for small devices also. Each has their own characteristics. Just be familiar with these different OSs. The first one up is a mobile OS. So that's the one you're going to have on your phone. This is optimized for a touch interface. There's no general mouse or keyboard here. It's power management for battery life. It's optimized to manage your battery, as you generally don't have this plugged in as you would have on a desktop. The biggest examples is going to be the Android or the Google's iOS, or said that wrong, Apple's iOS or Google's Android operating system. So I have a Android. Some of the Apple users is going to have the iOS. All iPhones are iOS, and everything else is basically Android. When it comes to desktop and workstations operating system that we're utilizing, designed for keyboard and mouse input versus a touch interface. Full-featured applications, almost all apps can install on them. Examples here is going to be like Windows, what I show you, Mac OS, like I have on my book here, and Linux for high specialized users. Not really for everyone. The problem with Linux, but if you've never used it, it looks exactly like Windows. The problem with Linux is that very little application compatibility. Not many apps work on it. The server operating system. The Windows Server operating system, like we have here, is meant to be installed on specialized machine, like a Windows server or a particular server, that allows it to utilize tons of hardware and able to intake requests from thousands and thousands of users. A Windows Server operating system also runs specialized services, or I should say applications, to manage network users and network resources. They're optimized for network services. They have high reliability, high performance. They support tons of different hardware. Another one, if you don't want to use a Windows server, you also have a wide variety of Linux and Unix servers that are out there. Another one is called embedded OS. So you have a device, a watch, a fridge, a GPS, a Garmin GPS like we have here, different kinds of smart TVs and so on. These things have operating systems, okay? They have very specific operating systems built in. They're called embedded OSs. They're built for that specific device. Your car has a very specific operating system. Remember, hardware is useless. It needs an operating system to function. So embedded operating systems are on top of this hardware to make sure it functions well. These are called embedded operating systems, generally for appliances, Internet of Things. You guys remember that? Everything connects to the internet. Those things are going to run on the embedded operating system. Okay, that concludes this section on things about the operating system. Remember something, guys. You don't need to be an expert in configuring, managing, setting up operating systems for this particular course. Just know the different functionality of the operating system. When it comes to working on a computer, you're going to be spending almost all of your times in the applications that you're working in. So in this section, we're going to go through some different types of application software, whether it's productivity, collaboration, instant messaging, software that is out there that you should understand. Let's get started. The first thing up we want to talk about is software. Well, I want you guys to understand there's basically two major kinds of software. Your operating system, which we covered previously, and applications. That's what we're covering now. So these kinds of application software, they generally perform a very specific task. Think of like, and a software is like a video game. This is a very specific task of playing a particular game, or Microsoft Word to generate documents, or Microsoft PowerPoint to make presentations. So they generally perform very specific tasks. Some are used for productivity, like productivity just means getting stuff done. Like Microsoft Word for making a document. Some are used for communications, like maybe on the app, on your operating system, you have something like GoToMeeting, or you have things like Slack, or you have Microsoft Teams or something to communicate with other users in your office. Essential tools. These are going to be essential tools for getting work done. When you're working in an office, you're going to be using the software to get your job done. Let's go into some of these ones. The first thing I want to mention is productivity software. These are applications that helps you to get tasks done. This is what you're going to use when you're in college or even high school and you're trying to get some work done. You're trying to make a document with Microsoft Word. You're trying to make a spreadsheet or manage a spreadsheet with Excel. You're trying to do PowerPoint presentations and so on. These allow you to create, edit, and manage documents. This is basically Business Fundamentals 101. The first thing up we want to talk about is word processing. This allows us to create and edit text document. The most famous of this is Microsoft Word, or if you're online, you're going to be using Google Docs. Formatting, spell check, using different kinds of document templates are all going to be located here. Now, where is word processing used? Well, when we use things like Microsoft Word, we're making letters, we're making a report, we're making a manuscript for a play or something. We're making professional documents. We can even collaborate and have teams collaborate on making documents. For example, think of a law document. We have multiple lawyers working to come up with a court case document. So now we have collaboration on them. The other one you're going to have are spreadsheets. Now, what are spreadsheets? Well, in a previous video, I showed you Microsoft Word. Now we're going to look at Excel. This organizes data into columns and rows, performs calculations. Famous one is going to be like Excel. Why do we want to use this? Well, perform financial calculations and budgets. We can analyze data. This is where it's used a lot of. Calculations, financial analysis, and creating charts and graphs. Let's take a look at what this looks like. So I'm going to go to my Start button. I have Excel right here. Let's open this up. And I'm going to go, okay, we don't need all this. We can just close this up. So this is a spreadsheet. This is Microsoft Excel. In this kind of spreadsheet, one of the main things it does is that it organizes data. So maybe I can have numbers, I can have data in here. Let's say you're doing some numbers. Let's say I want to calculate what is the worth of all of my baseball cards. So let's call it baseball. And let's say card 1, card 2. So, and now the great thing about spreadsheets is that it's not just about typing data in. It's not just storing data. Now you can actually put in numbers in here. Let's say this card is worth 20 bucks and this one is worth $35. And the good thing is that you can go in there and you can then calculate on this type of data. So I can go in there and it says, well, how much is all my cards worth? Well, I can go in here and say equal this plus this. Now I have $55, right? I can even format it to show me as numbers. That's dollars, I should say. So that would be a spreadsheet. Now, Microsoft Excel, as I showed you guys, this isn't an Excel course, by the way, but you guys should know Excel, should learn it. Microsoft Excel is used extensively in financial departments. We're going to have to analyze a lot of data, accounting departments, as you can make accounting ledgers out of this. Presentation software, what I'm using today. Making slides. Microsoft PowerPoint is the most famous of these things. Creates visual slideshows where we can do text and pictures on this. PowerPoint, Google Slides is the most common version of this. Why do we do presentations? Well, I'm doing it for an educational lecture and demonstration. Other people do it for business presentation and training users. People even do it for sales pitches. Generally, when you want to sell a product, you may have a whole presentation. These course slides were created using PowerPoint. The other one here you have is going to be diagramming software. Maybe you want to make a flow chart or a particular diagram. Microsoft Visio is one of the most famous. This creates visual representation of a concept. So you can do different types of flow charts with a software like Visio. Now that you have, now that we talked about productivity, one other software is called collaboration. This allows people to work together at the same time. All right, so I can be working on a document while you're working. What are some things that's going to allow this? Well, Microsoft Teams is going to allow us to collaborate and work together in a shared workspace. It's essential for remote workers. Like, for example, just to have a chat software that we can all chat with throughout the day. Because if you think about it, if we work in a remote settings, we're not sitting next to each other, so we can just go and just talk to each other. But with a remote software like Teams, we can now go and talk to each other. It's like text messaging for your office, by the way. Enables teamwork across our office. Email. All right, what are some famous email clients? What are we going to use to receive our emails? Well, this manages the electronic mail that we're going to be receiving. Email clients such as Microsoft Outlook or Gmail allows us to organize our email together, send and receive email. All right, send, receive, organize emails. A lot of them will include calendars, so you can add things to a calendar. You can even put your contacts here, and it handles attachment and security. In other words, you can send files to people, and it can even do security. Some of these email clients can block malware or viruses from coming onto our computer. The other one is called conferencing software. We bring people together and we can see each other and talk to each other. Famous for this is Zoom. Even Microsoft Teams or WebEx are also famous for this. Teams just doesn't allow us to collaborate with chat, but it allows us to actually talk using video and audio with each other. Online workspaces. Where can we come together and collaborate and work on documents? Teams, again, does this. Slack does this. Basically, it's like a shared digital space where we can share files, update files, change files, centralized project management systems where if we're working on a project, we can put all the documents there and manage it in one particular space. This is becoming more and more popular as more and more people work remotely. Document sharing. We need a place to share documents. Teams also does this. Google Drive, if you have Google, you can share documents through Google Drive or Dropbox. You can also use SharePoint, also includes version control and permission. Version control means this. You can actually create a document and then go update it later. And then if you don't like the update, you can revert it back to a previous version. So this is called version control in document sharing. Instant messaging software. Teams does this. Slack does this. WhatsApp. This is software for real-time communication. So I can take out my phone that I don't have on me right now. I can take out my phone and I can text someone, or I can Slack them, or I can use WhatsApp. Quick, informal conversations that we can just send one. This is just instant messaging. Very popular today. A lot of people use it. I communicate a ton using some form of instant messaging. The benefits here is instant or immediate communication. It's less formal than an email. Email is when I want more formal communication. It does have group chat, so you can bring a lot of people in order to communicate with that. Web browsing software. So when you're utilizing a computer, one of the things that folks spend a lot of time on is browsing the internet. But what are you browsing the internet on? A lot of people, I'm a personal user of Chrome or Firefox. Apple users may have Safari on there. This allows us to navigate the internet. It depends. There's Microsoft Edge, there's the Opera browser, Firefox, Chrome, and Safari. Depending on your preference, they basically all do the same. If you want my recommendation, I'm a Chrome user, Firefox second. Even on a Mac, I use Chrome or Firefox. I don't think it matters so much. Some are better performing than others. A web browser allows us to display our web page and the contents on the web page. It allows us to do bookmark management. So what is a bookmark? A bookmark, when you bookmark a website, right? So when you go to a website and you bookmark it, what are you doing there? So I want to show you guys bookmarks. So let's go to the Chrome browser. So here I am. I just opened up Chrome. All right, so I have it on my taskbar. I opened up Chrome. I have a variety of bookmarks that you guys can see here. This is all the school bookmarks that's generally on people's machine. I'm going to go here, and you can see bookmarks and lists, and these are all the bookmarks that we have here. So you can show your bookmark. So right now I have it on show bookmarks bar. That's what this is. If you ever go to a website, say let's go to a website. One of my favorite one is Tech Bargains. All right, because I buy tech stuff. If you like a site like this, you see this little star here. All right, you can bookmark this, and now you can add a bookmark. So, and it's going to add it to your bookmark bar. So, why would you want to bookmark a website. It's taking a little long there. Why would you want to bookmark a website? Well, that way it's easier to come back to. And you saw I had a bookmark bar there, and you can show it. Now, I'm not going to go through the steps on how to do all this because you don't need to know it for your exam, and it's a little different for every browser that you use. But keep in mind, when you bookmark something, it just allows you to come back to it a whole lot quicker. That way you don't have to go and search for it. You can just click a button and your website pops up. So your web browser is going to allow you to do that. It's going to maintain your privacy in there. And that brings me, later on we'll talk about when you're browsing the internet, you're going to want to browse it in privacy modes. We'll talk about that. Another software you have is going to be remote support software. This is software that you're going to be utilizing in order, well, probably not you, not yet, till you become a technician. When you are a technician, I should say, you are going to use remote software like remote desktop, TeamViewer I use, in order to remotely access somebody's computer in order to fix it. You can also set up remote access software so you can access your own computer maybe while you're away, and you can just work off your desktop. I do that a lot. My desktop at home never shuts off. It's always on, and whenever I'm on the move and I need to access something that's on my desktop at home, I just remotely access it using software like Remote Desktop or TeamViewer to access it. It allows me to access my machine and use it, take resource off, but it also allows me, when remote access software, when something is broken on a network, it allows me to access those remote computers and fix them for users. All right, that ends this section on some different forms of application software that is out there. Don't forget, guys, the operating system, the whole purpose of that is to install our applications because that's where we're going to be spending most of our time. One of the most common applications you're going to be using on a computer is going to be your web browser. In this video, we're going to take a look at some of the things you should be aware that you can do in a web browser. Yes, surfing the internet is one of the things you're going to do, but there are some things that you should know that we can do in addition to surfing the internet or making our web surfing a lot easier or more secure. Speaking about more secure, let's go into this. So in this section, we're going to go through some different configurations. I'm going to be showing you how to do it on my Chrome browser. All these browsers basically support all of the features I'm about to do, but the steps to doing them might be slightly different. So my recommendation is just play around, look through the different settings in your browser. Let's get started. So we're looking at some browser configurations. We're going to look at how to customize your browser. I'm going to talk a little about security and privacy settings that you should be aware of and how to make it a lot easier to use. First thing up we want to mention is private browsing. Now, when you browse a site, as you browse the site, the browser is storing all of that information on you. It's remembering where you went. It's sending your data to these websites. If you want to hide who you are and you don't want your computer tracking anybody tracking anywhere you went, you should do private browsing. Cookies and data are not stored on your machine. Cookies is when the web server or the website you're going to stores information about you, whether it's your username, your passwords, or the different pages you've been to. This is useful for more sensitive or especially if you're sharing your computers with others. The benefits here is that it prevents people from tracking your browsing activity. It prevents people from tracking your login, and it keeps searches and downloads private. So it doesn't remember what searches you did. Now, let me show you guys how to do that. Let's go to, I'm going to open up my Chrome browser, and I'm just going to click on the little icon here at the top, our little three dots, and I'm going to go to incognito window. So in the Chrome browser, we call this incognito. And what incognito does, now when I go and I surf the internet, maybe I'm going to go back to my favorite website, Tech Bargains. This basically, now I can just surf it like I normally would, and the computer is not storing, the owner of this website is not tracking me and tracking cookies or anything like that. So it's a much more secure way of browsing the internet. Now, some people call it, some applications would call this private mode. In the Chrome browser, we call this thing incognito mode. The next thing we want to talk about is browser extensions. Extensions are small programs that enhances the functionality, that gives the browser the ability to do other things. Maybe to remember passwords. For example, I use a password manager, and that software stores username and passwords for all the websites I've been to. I'm not going to tell you which one, but famous ones that are different out there. You have ones from Microsoft, ones from GoToMeeting, all these different brands that you have out there that you can use out there. So that's some of the things you can do there. They customize the browsing experience. They are available from the official browser stores, and I'm going to show you guys what they look like. You can add extensions. This allows you to add it. There's a marketplace where we can go and check them out. There's an install button. You should review the permission to make sure that you can actually do it. And then, of course, from here, you can also remove extensions. So the browser is going to allow us to add browser extensions, remove extensions. Maybe we don't want them anymore. You just want to delete them. And if you're not using it, you can even enable and disable these particular extensions. It's just like a toggle button, which I'll show you guys right now. So maybe sometimes the extension causes problems on the browser, and you don't want to uninstall it, but you could disable this extension. Let me show you guys how to get to browser extensions. So I'm back at my browser. Let's click on our little dots here, and we have extensions. So we're going to go to Manage Extensions. Now, you notice that my browser has a few different extensions. Okay, you figured it out. I was using LastPass password manager. Okay, you guys figured it out. I also have Grammarly installed. This checks like when I'm the grammar when I'm typing in a browser. If I go in here also, you notice how, let's say, you know what, I'm not using this one anymore. I can just delete it, remove it. Nope, no, we're going to just remove it. It's fine, it's gone. If you're not using it anymore, you can just temporarily disable it. This is how you would enable and disable. So right now it's disabled. When it's in blue, it's enabled. So maybe I don't want it anymore. I'm just going to disable it. You know what? I'm actually not using that. I'm just going to remove it. So from this section, I can enable, disable, remove extensions. And if you want to see all the different extensions that are available, just click on right here, Discover More. You can go to the Chrome store. These are all different extensions that I can put in there. Maybe I want a dark mode so I can easily read. I can just click on this one and add it to my browser, to Chrome, and then I can enable and disable this particular extension. Okay, so that's extensions. That's really important to know. I think extensions really adds good functionality to your browser. Another one is caching. Every time you go to a website, your browser remembers all the websites you've been to. Sometimes it remembers your username and passwords, basically your entire browsing history. It stores all the web content. Caching is good because it helps to speed up when you want to re-access those sites again. But it can cause issues, especially it may give you content that's outdated. Some people would like to clear this browsing cache, removes temporary files, forces a fresh gathering of data of different web pages. It may fix some of, if your website has some problems, you may want to remove the caching on it. Now, how do you do this? Well, let's take a look at this. So I'm going to go back here. Let's click on our three dots. For this one, we're going to go to Settings. All right, I'm just going to go here. I mean, this is the easiest way to do it. You can also go here, delete browsing data. All right, I'm going to show you guys two ways. You know what? Let me show you this one here first. Clear browsing data. And this here is going to delete all of the files we had in the last hour, 24 hours. You can even go back and say all times on there. So this here is going to delete things like cookies, cache files, downloaded files, autofill forms that we did last 15 minutes, 24 hours, and so on. The other one you could have done was the three dots. You go to Settings, and we're going to go down here to Privacy and Security. And you also have, you see this one here? Where is it? Delete browsing data. You can also have gotten it from here. Brings up the same thing. So two different ways. Now I'm going to keep this one here, this settings open, because we're going to be utilizing this coming up in a minute. So pop-up blockers. So these are, your browser can do this. It blocks pop-up. So sometimes you go to a website and you have like a pop-up. They just put maybe spam or to try to sell you something, some kind of ad that's popping up on the website. Pop-up blockers blocks these unwanted pop-ups. They block intrusive advertisement, can be configured for specific sites. I'm going to show you guys how to do that in a second. On your browser, they do have the ability to enable or disable or block in these pop-up blockers. What you should do though, not every website is bad, and some websites you may want to allow pop-ups. You can add those to trusted sites and be able to control the notification on them. So let me show you guys how to do that. So here I am again at the settings, privacy and security, and I have site settings. And here you can go in, if we scroll down, pop-ups and redirection. And I have allow to send pop-ups or use redirections. You can add certain sites if you want to allow pop-ups. Don't allow sites to send pop-ups or redirects. So right now I have mine on. I'm not going to allow any pop-ups on my computer, but on these sites I will. It's up to you whether you want to allow this thing or not. Some people do, some people don't. That's a security settings. I'm going to click on the back button here. Some people want to allow it, some people don't. Compatible browser for applications. Now I do want to point out, sometimes when you're using applications, especially applications that a company made, maybe a small business, maybe a company you're working for, they may not always work with every single browser. Some of them works well with Edge, Microsoft Edge. Some works with Chrome, Firefox, Safari, and the opposite end there. Depending on the browser, not every application is compatible. My best advice to you is sometimes if you have a web application or a particular website and the website isn't functioning well, looks kind of weird, doesn't give you all the functionality, maybe if you're using Chrome, try it with Firefox. I have two browsers on my machine. Actually, I have three. I have Firefox, Chrome, and Edge. Or if I'm using my Mac, it's going to be Firefox, Chrome, and Safari. I'll just try another browser. A lot of times, that seemed to work. Now, remember, when we're talking about compatibility, older browser may lack the features that we have. Some sites are optimized for a specific browser. Some sites are written for Chrome, but doesn't show well in Safari. Update your browser for always the best compatibility. Generally, the more updated the browser is, the more apps it'll be able to hold. Another thing we have is profile synchronization. So when you use a browser, you should log into it with like your Gmail account. By doing that, it links your Gmail account profile to that browser. This allows me to synchronize bookmarks across all my devices. It will require to have a user account with the browser provider. Like with Chrome, because Chrome is owned by Google, you generally just use your Gmail. Maintains consistency. So this is important because one of the benefits of doing this, it allows me to sync my bookmarks across all my browsers. It's consistent browser settings, and it can even back up important data for me. It organizes features, all right? The browser is going to help me by doing my profile syncing. It's going to allow me to manage my browser more efficiently, allows me to manage my bookmarks and organization better, and it gives me quick access to maybe some frequently used sites. Now, we spoke about bookmarks already. I want to show you guys, let's go here. I'm just going to open another tab here. We looked at bookmarks earlier. So when you bookmark something, when you go to a website, what did we do? Let's go to Wikipedia. Let's bookmark Wikipedia. So I have Wikipedia. If you want to bookmark a site, you just go to the website, you click on the little star here, bookmark this, and it bookmarks it. I'm not going to bookmark it now though. When you go to bookmark it, you have a bookmark toolbar, and you can go and you can see all the bookmarks that you have. You can click what's called Show All Bookmarks. So if I go in here, I can see all the bookmarks that I have. If you want to see a toolbar, you can go here, bookmarks, and you can say Show Bookmark Toolbar, and then I have all the different bookmarks that I have. When you have a profile, all right, when you're doing a profile, if we click here and we go down to, where is it? Right here. You see this here? This is my profile. so I can sign in and out of Chrome. When you're signed into the browser and you do your bookmarks, you save your bookmarks, you remove bookmarks. When I log in, this is a desktop. When I log into my laptop with the Chrome, the bookmarks are synchronized. So let's say I bookmark Wikipedia. When I go home, I can then access Wikipedia from the bookmark right here on my laptop. So it gives me a good synchronization. What are bookmarks? Well, they're links to our favorite websites, so we can access very quickly. They're organized in folders, we can even access it from the quick access toolbar, like I showed you guys earlier. Let's create folders. Let's import. We can even import and export bookmarks, and we can even share these bookmarks with other folks. Let me show you guys something here. If we go to the three dots, we go to bookmark and list, you notice how you can import bookmark settings. You also have a bookmark manager that you can open up and see all your bookmarks, and you can delete them, you can remove them. Maybe I don't want this one, maybe I could delete it, maybe I can remove it from here. So I can go here, delete this one, remove it, and so on. The other thing that you have is what's called default search engine. So default search engine is when you're using a computer, what is the default search engine? What is the search engine that you're going to be utilizing most of the time in? That's your default search engine. It's choose your preferred search provider. Now, there's many search engines out there. Yahoo, Microsoft, Google. Actually, that's pretty much it. This affects the address bar. So when you go in here, and you just type into the address bar right at the top. Right now I have it as Google. But you can have it maybe as Yahoo. And when you just type in something in there, like what is the weather, and it comes up and it tells you, this is defaulting right now to Google. You can change that in the browser settings. Maybe you could make it other search engines. There's Yahoo, there's Bing. There's a more secure one called DuckDuckGo. Some are more feature-rich options, like Google. Some of them are more privacy-focused, like DuckDuckGo. Some browsers offer multiple choice. Some browsers allow you to choose it. The Chrome here, I'm just using Google on this one. Now, password management. Google and Chrome, most browsers can save passwords for you. This is not something I recommend you do. You shouldn't. I don't believe in saving passwords on a browser, but browsers does allow you to store and autofill secure credentials. Because if people come to your computer and they utilize it, maybe you just stepped away from your machine for a few minutes and somebody goes to a website to log in, the browser will just log it in for them. It does encrypt it, it does generate, and it could generate strong passwords for you. Now, it's convenient because it allows you to do a login. It's convenient because you don't have to remember long, complex passwords, so it makes strong, unique passwords. It does reduce password reuse. One of the problems people do is they keep reusing the same password for every single website. By utilizing complex password and having the browser remember it, now you have complex different passwords for every site. The problem here, though, is people leave the browser logged in. If they know your Windows username and password, they can actually see all of it. Not the best thing going. If you want a good password, if you want to manage your passwords correctly, use a password manager like LastPass or KeePass or some of those software that does that. Sometimes we have accessibility features. This is for people with disability. Some people have visual disability, mobile disability. The browser has features to help with screen reading capability, keyboard navigation for folks that are with disability. Now, it can increase the text size, contrast, voice navigation, and it could magnify what's on the screen. I'll show you guys that right now. So let's go here. You know what? I have site settings. Let's just reopen it. Three dots, setting. So this is my normal setting here. And I want you guys to, let's go down here to privacy and security. And you'll notice that I have. Wait a minute, autofill. You know what? Let's talk about password. I'm not going to click on this one because this is going to show you all the passwords that's saved here. But if you go to autofill and passwords, this is where it would manage the password manager, and it would show you all the different sites that are out there. What I was talking about a minute ago was accessibility. If I go here I can turn on live translation. You can use bigger cursors. You can customize captions. So this is all the accessibility settings that you can do when it comes to the Chrome browser. You also have appearance. Here you can change the theme, change the font size. Also, this is the next thing I'm going to be talking about. The appearance customization. We can change theme, visual appearance, font size. We can even enable dark mode on this particular browser. All right, quite a lot of things here, guys. When it comes to going through your browser, get to know your browser. Go through back this video. Try to find the things I did in this video on your browser. Utilize them. Download some extensions. Go through the list of extensions in your extension store. You'll be surprised to know all the different things you can find to make your browsing experience a lot better. One of the things that's changing the world around us is artificial intelligence. Over the last few years, things like chatbots, AI assistant, generative AI, has become more and more used by public users, and more people incorporate it into their daily lives. In this section of the course, we'll take a brief look into AI. We'll start out by talking about AI chatbots, assistants, what exactly is generative AI, and some of the things we can use it for. So the first thing I want to mention is, of course, AI chatbots. Now, artificial intelligence. What is it, and what is it going to do for us? Well, basically, it's when the computer systems simulate human intelligence. It doesn't actually have human intelligence. It attempts to show that it looks like it has human intelligence. In other words, it's able to learn from what you're typing in, it's reasoning, and then it's trying to solve problems. This is increasingly common in more and more applications that are getting built in today's world. One of the most famous ones that we're going to be using is AI chatbots. This is when you can have conversations with a AI assistant, for example. It answers questions, it provides support. It's available 24/7 for customer service. And in fact, a lot of companies are implementing AI chatbots on their website. So sometimes you go to a website and it's like, hey, would you like to chat with a customer rep? And it's basically a chatbot you're talking with. Now, the AI chatbot applications, people use this on websites, like I mentioned, to help customer support. We use this thing in help desk. Maybe somebody has a problem with a computer, they can access a chatbot. Sales and support of a product, they can help sell products online also. Another form of AI is going to be AI assistant. This is voice-activated intelligent helpers. This is the most famous of these, by the way, is going to be things like a smart home device. Like if you have a Google Assistant like I have, I'm able to say, hey Google in the morning, and it wakes up and it's able to tell me the weather or something like that. Siri, Alexa, all does this thing. It performs tasks like setting reminders. It can set the temperature in my house if it's connected to the right type of thermometer. They do respond to commands when spoken. Now, when it comes to AI chatbots, AI assistants, all of this is going to be built on what's called generative AI. Generative AI is that it's able to generate things, whether it's text, it's images, it's movies, it's pictures, and so on, based on what's called prompting, basically asking it to do things, telling it what you want. This creates new content based on training data. This is becoming more and more sophisticated. Some of the most popular ones are like ChatGPT and Claude, as I see that we have in the picture here. AI is going to help us to write code, automatically writes and program codes for us. This is going to assist developers with coding. A couple examples of this is like GitHub Copilot, or ChatGPT is able to write code for us. Code generation benefits, well, if you're using your generative AI to write code for you, well, this is going to make it a whole lot quicker. It helps learn new programming language. If you learn a new programming language, this can help you learn a lot quicker, as it helps to write the code for you. It reduces repetitive coding over and over. Another thing you find a lot of is AI-generated content. Articles and documents written by AI, artwork and images produced by AI, videos and audio, or videos in particular with audio being made with AI. This is becoming more and more popular. Content generation applications. There are applications that are being generated completely with AI. There's all types of marketing content. So marketing copy and social media posts. A lot of people that post on social media, a lot of content being pushed out on social media, a lot of videos on TikTok or Instagram or YouTube is done with generated by AI now. A lot of writing and storytelling is done by AI. Educational material and summaries are also done by AI. A lot of people are using AI to help summarize books for them, so they don't have to read the whole thing. When utilizing AI, let's just utilize an AI quickly. You guys are probably familiar with this, as most people have used. Let's just go to Google and type ChatGPT. I'm just going to click on the first link here. And here you can use it. And this is, when you open ChatGPT, it brings you to a screen where you have to ask it what you want. This concept is called prompting. So you can ask it to maybe solve problems for you, help you with your homework, write code for you. We're going to use it to help write a code. Can you give me the HTML for a web page that will explain why people should use AI? Now, I'm asking it what I want, but I want to show you guys how it's being utilized to help in businesses today, because you notice now it's giving me all the code of this particular web page. And then I can copy it. It tells me what it's doing. Now, I'm not going to get too far into this. This is beyond the scope of your exam. But just understand that we can use it. You can ask it all types of questions. You can ask it medical questions, advertising questions. You can ask it video generation. You can also ask it to generate pictures and movies and so on, depending on the actual AI model that you're using. AI predictions and suggestions. AI, one of the great things, something like with ChatGPT, you can upload files, pictures to it, and it can analyze that for you. So it can analyze data, and depending on what you give it, it can then predict other things about the data. It provides personalized recommendations of that data, and it learns from user behavior patterns. So depending on how long you're using it, what you're using it for, it actually remembers things about you. And once it remembers things about you, it's then able to personalize those outputs for you. Predictions. For example, it's able to forecast weather improvement, so weather forecasting. It can, depending on the data you give it, it's able to do stock and financial analysis and tell you, hey, this is a good stock to buy. Depending if you have medical issues, you can give it your symptoms. It can attempt to give you diagnosis assistance. It doesn't diagnose you, that's a doctor. Now, depending on what you tell it, it can suggest streaming services. Hey, utilize this streaming service. It can suggest what to buy online. It can suggest what social media feed or even when to navigate and do all types of traffic, when to go drive somewhere. AI is here to stay. It's going to affect a large part of our lives. For our exam, we're probably going to have one or two questions on this. Just understanding what it is, understanding what generative AI is. It's used to generate text, pictures, movies, just new content based on our prompting of it. It shouldn't be too complex, and I'm pretty sure a lot of you guys are already utilizing it. The best thing we can do right now in this world of AI is to get better at using it. Just a quick note here. It's Sunday, December 7th. It is 7:24 p.m. and I've been recording since about 12 o'clock this afternoon. My back hurts, my leg hurts, and I'm doing it to get you to pass your exam. All I'm asking you is just to like and subscribe. If you did it already, thank you so much. If you haven't, please help me out. I put a lot of work into this. It would mean the world to me. Thank you. Let's continue the course. In this section of the course, we're going to be talking about programming. And I know this is the section that a lot of people don't like, but it's not that difficult. You don't have to be a programmer to pass this exam. You don't have to write code to pass this exam. Although we did write some code, and I want to show you a game that we wrote just to demonstrate some of the examples that we're going to be talking about, just to make it easy to understand. The main thing you're trying to get out of this section is understanding, not knowing how to write code. That's not what this course is about. So I want to show you my game that I made. It's a very simple game. And then throughout the rest of the sections in this, all of it, all these different sections in this domain of the course, we're going to be going through that code. So I want to show you guys that. Let's go to my desktop. And I am at online-python.com. This is going to be a simple Python game that was written. And I'm just going to paste my code in here. Don't worry about the code. This is a lot of code here. Don't worry about this. We're going to go through and look at this code more in depth as we progress through the sections. But I just want to show you what this does. Exactly what is this? So I'm going to click on Run, and it's going to run my code. And it's a really simple thing. All this game does is that it has a number, and I have 5 attempts to guess the number. Okay, welcome to Guess the Number, all right? So Guess the Number game. Enter my name. So my name is Andrew. Okay, I have 5 attempts to guess. Guess the number between, it already knows a number. I'm going to try to guess the number it knows. So let's say 10. Too low, try a larger. 15. Too low, try an even larger number. 18. Too low, try a number. 20. Correct. I have guessed it, the number correct. That is all this code does. Now, I'm going to execute this one here. And I want to run this code again. And I'm going to run it again. And there's a reason I'm doing that, because I want to see what happens if I don't guess. Guess the number between 1 and 20. How about 20? Too high. Try a smaller. 1. 1. I want it to fail now. So I did one when I passed, and I wanted to do when I failed. So I want you guys to see what my game does. So in this one here, nice job, Andrew. I was able to guess it. Versus in this one, I wasn't able. Sorry, Andy. You ran out of attempts. The secret was 14. It was going to tell me whether the number was big or small in there. Let's go back to this. So very simple game I made with Python. We made with Python here. It doesn't have a lot of comments. You do not need to know how to write that. I'm just going to use that to demonstrate what I'm talking about as we go through these, I think it's 4 or 5 sections in here. Let's get started. So we're talking here about different types of languages that are interpreted, compiled, and query languages out there. Let's go into this. The first one we want to talk about when it comes to programming language. When you are writing in when you're writing code, when you're writing an application, you have to know, hey, what type of code base am I going to use? What language do I want to write my application in? So when you develop software, this whole concept of software development, software is developed by writing code. As you can see, as you guys can see here, I have a whole lot of codes here. This is software development, guys. It's about writing codes. Now, when you do this, when you write an application, maybe you want to make a game. Maybe you want to make a specific website. Maybe you want to make an application on your mobile device. You have to know, well, I'm going to write it in this particular language. And there's more than one. There's different approaches to writing it. Each category has specific purposes, and understanding them will help you choose the right tool. Now, this isn't a course to make you coders, but it is a course to help you understand it. What you saw I have here, this particular code base I'm using, this is of course called Python, and this here, where is my thing? Python is called an interpreted language. This is important because the code itself is being executed line by line by line. So when I had copied the code that I wrote and I pasted it here and I said run, it basically interpreted every single line by line by line. See, it says interpreted. It's basically, it was reading every code line by line, compiled it all or read it all, and then executed it. So this one here, there's no separate, you don't need to compile the code. You just push the code in and the code is executed. This is generally easier to write. I generally only write Python. Easier to write and test and debug. Another famous one is things like Java does this. Interpreted language. Codes run directly from the source. You don't need to compile it and turn it to machine language. Slower execution. This is true. It does execute a little bit slower. Remember, it's easier to test, but it is going to be a little bit slower to execute than a compiled language, which we'll talk about a little bit later. This is performed independent with an interpreter. So this software, this website I'm using here, online.python, this is the interpreter that's interpreting the code for me. Now, the next thing we have is going to be a scripting language. This is a subset of interpreted languages. You can do things like automate tasks, often used for quick solutions. A lot of this scripting language, when you write scripts, whether it's Windows PowerShell or PHP scripts, it's generally done to do task automation inside of like a server, is where I would use PHP and or Windows scripting for. Python supports this. JavaScript, Windows PowerShell scripts all supports this kind of things. Generally used for automation and data analysis is where Python would be used. JavaScript for web interactivity. A lot of automations that's happening on websites is going to be done using JavaScript. And then you have PowerShell for Windows. I utilize a lot of PowerShell scripts in order to do things like automate my backups, checking my data, reviewing logs or clearing out log files from our Windows server. Now, the one that you guys have been utilizing a lot are markup languages. A markup language describes how a document should structure and how it should be formatted. It's not a traditional programming language, but it does define how content should be displayed. Where do we use a markup language a lot? HTML. If you guys want to see a markup language, if you just open up a website and you right click and you do view page source, this is the HTML that's on this web page. And what this does is that this language is formatted and it's telling the browser how to display that page. It structures it to tell it how to display that particular page. HTML, one of the most famous one, HTML for web pages. You have XML for data organization. So the thing with XML is when you save data in XML, you can then import it into different applications and it knows how to read that particular data. They also have Markdown for simple text formatting. Compile programming languages. Now, I want to point out something, that there is something we call machine code. What's machine code? Machine code is ones and zeros, guys. It's what the computer actually reads. If you remember what I told you, the processor is made up of transistors. And in order for the processor to execute something, it needs the instructions in ones and zeros. So we have machine code. When applications are written, it has to be translated into machine code for the computer to execute it. Now, compiled programming languages takes what's called source codes and it translates it into this machine code. So people write code and then this code is then compiled and it turns it into machine code. So source code is generally things that we can read, human readable code. Completion happens before the execution, so you would compile it before it executes. It's faster execution than the interpreted language. Interpreted language reads code, reads line by line by line. Compiled codes compiles it all into all ones and zeros and then executes it, so it's a whole lot quicker. Compiled languages, it's a separate build step is required, so it's built differently. It's machine-specific executable files. It compiles it differently, whether it's for a Mac or it's for Windows, and it will always have better performance. Common examples of compiled languages, guys, are going to be like C and C++. Java compiles the bytecodes. This is good. This is the go for modern development. This is what we're going to use when we are developing modern programs that are out there. Now, another thing we want to talk about, we have a whole nother section coming out on databases. You have what's called a query language. Query languages is specialized for databases. A database basically stores data. And what a query language does is that it's able to go out and retrieve data from the database, manipulate data from the database, add data to a database. So it's used to retrieve, manipulate, and store data within that database. So remember for your exam, a query language is used to add, store, manipulate, even delete data from databases. Now, query languages are going to be things like SQL, structured query language, or NoSQL, basically to storing documents and different types of data sets. SQL for what's known as relational databases. We'll talk more about databases later on in this course. Another one you have is assembly language. Now, this is called low-level programming. This is when you have direct control over the hardware. This is as human readable at the closest you can get to write into a machine. Assembly language is something that's very, very difficult to work with. Not a lot of people even know this type of thing anymore. It's human readable. It is human readable, but difficult to read version of machine code. So it's a human readable version of machine code. It gives you the most control over programming an application. Platform and processor specific. It is very platform specific. It has to be rewritten for different platforms, but it's very fast in the execution. It is difficult to write and maintain. Okay, those are some different programming languages that we have out there. The rest of this course, we're going to be talking about some characteristics of when you do programming, and we're going to go back and look at that small application that we wrote there, that game that we wrote there, so you can better understand specifics on programming. When it comes to writing code, you have to understand different data types. The way the code is structured is heavily dependent on the language, but almost all codes will follow some kind of data types. In this section, I'm going to take a look at some pretty common data types, whether it's a char, it's a string, it's some kind of a number or some kind of operation being done in Boolean. These are some things you want to just be able to understand. You do not need to thoroughly understand this and go write your own code. Just something to know. Let's go take a look at it. So the first thing I want to mention is data types. What we're about to cover are all different data types that you can find in code. It doesn't really matter what language you're using. A lot of these data types will remain the same. So let's get started. So data types are the basic building blocks of almost all programming. In fact, when you program and you write code, you have to define, hey, tell the application, hey, what type of data is this? It defines what kind of data can be stored, and different languages can determine the availability of the operations that's done on this particular data type. The first thing I want to mention is the char data type, one of the most common data types out there. This char defines a single character in the code itself. Letters, numbers, or symbols can be used, usually occupies 1 byte, not bit, 1 byte of memory. And examples of this would just be like the letter A, or the number 5, or a symbol of just the dollar sign. It's usually enclosed in single quotes. Remember that, enclosed in single quotes. Versus, we'll talk about something else in a minute that has double quotes. Now, ASCII or ASCII or Unicode encoding is what allowed this. You don't need to know this part for your exam, but just remember, a char is generally a single character with just single quotes. The other one we want to talk about is what's called a string. A string is a sequence of characters. Text data like words and sentences, when you're writing codes, would be, when put together, multiple letters, multiple numbers and letters and characters put together to form things like words and sentences would be considered a string. They can have variable length depending on the content itself, and they're almost always enclosed in double quotes. Like when you say hello world, that would be double quotes. They could contain spaces and special characters versus a char, which doesn't have, it's just a single character. Now, string operations, they are concatenation. They combine multiple strings. So you can combine 2 or 4 different strings into one. The length function counts the character limits. There is there is a function in there to count how much you can have in there, and then you can extract portions of the different strings that are out there. Now, before I get into numbers, I want to show you guys that. So look at this. Okay, this website doesn't scale very well here. Look at this code that I have here. All right. Can we make this? Yeah, could push our game over. We don't need to. We saw what the game does already. Look at the code here. So you see how this is a char example. You see how this A, it's just a single letter. And how does Python know that this is a char? Because the single quotes. See that? But look at this. In the game, we have where we greet the player. Welcome to guess the number. That's a series of text. This is a string. Why is this a string? Because you notice it's a whole lot of those chars put together. It has spaces. It has a symbol in there. Also, so string is a whole lot of these characters coming together. I'm going to point out something to you guys, so we'll cover it here in a minute. There's something else, a data type we call integers. Integers represents whole numbers. So when you just type a number in there, the system knows it as like, how many attempts were we given? Well, we were given 5 attempts here. The minimum number was between 1 and the maximum number was 20. You notice when we type it in here, when we were coding, by the way, when you read in code and you see the pound sign and text after that, that's a comment. That's not executed. I commented the code to make it easier for me to explain it to you. All right. This is not, this green thing here, right after the pound sign is not executed at all. It's just there to make the code easy to understand. So you notice how this 5 says integer, which is a whole number, is 20, but then we were given 3.5 seconds. There's sometime was 3.5. That would have been a float. The other one we have, notice how this thing says Boolean. Debug in mode, do we need to turn it on or off? Well, this one here was false. You notice how the Boolean was a true and false value. Okay, we're going to cover integer, float. Notice 3.5 is a float, and Boolean has its true and false. Okay, when you're doing numbers in code versus when you're doing like characters, the char for a minute there, we were in the beginning, when we were doing characters, we were looking at, so a char is a single character versus a string is multiple, right, combined. But when you're looking at numbers, there's 2 ways to look at numbers. Numbers are going to be used for calculations or precision, looking at a range like we have here. Now, integers are whole numbers. Remember that for your exam. Integers are whole numbers without decimal points. They can't have a decimal point. If you just put the number 5 or 6 or 10, that's a decimal. That's an integer. It could be positive, it could be negative, it could be 0. It's generally a fixed amount in the memory. They could be negative, 42, negative 17, 0, no fractional parts, limited range based on memory size. So they can, depending on the memory or how the memory is limited in the application, that's when you can limit the size of the actual integer. Floats are decimals, numbers with decimal points, also called floating point numbers. Can represent very large or small values. So it could be very big. It depends on how many decimal points you have out there. Example like 3.14, we had 3.5, 2.17. Scientific notation is supported where it's like E or exponent 8. Limited precision due to storage format. So once again, if the memory is limited, it's going to, then you can stop how many decimal points you can have. Another thing we want to mention is the Boolean data type. This is a logical operation on the data itself. If you think about this, when you program applications and you're doing something in programming and it's like, okay, if this person does this, then do this. If this person does this, then do this. So for example, if a user double clicks on a mouse, you should open this file. If this user clicks on this link, then you should open this page. If this user clicks on this section of the page, then do nothing. So you're always having like this if then. If somebody does this, they do this. it always represents a true and false value. Was the condition meet? Was the value true? Did the user click on the link? Yes or no? Was it true or false? It's used for logical operations, is the foundation of all conditional logics that are out there. The Boolean characteristics we mentioned generally outputs true or false, used in if statements and loops. We'll talk about loops later. It's the results of comparing different things. Boolean operations and or not are some of the most common ones. They compare different things. They're essential to the way program flows. Just remember for your exam, Boolean generally is a true and false logical operation. That's really all you need to know for your exam out there. All right, just some really quick things there on different data types. You don't need to go in and be a master of coding, but at least understand these data types. Okay, moving along in our coding journey, the next thing we're going to be taking a look at is what's called identifiers. Arrays, functions, and objects. Now, some of these terms here, you're going to want to understand them for your exam, and once again, don't go in depth into them. So when you are coding, you need to be able to label things. You need to identify what those particular things are and what they're going to be doing. So that brings me to an identifier. What are identifiers? Well, these are names given to the programming elements that we're using. In this particular course, we're going to talk of two of them, what's called a variable and a constant. They must follow specific naming rules, and basically by using identifiers, it makes the code a lot more readable and maintainable. The first thing we'll talk about is a variable. When you declare something as a variable, what you're saying is that the storage location with changeable value, which means that this value can change. The user, the person using the application, will change this value as they consistently use the app. It holds the data during program execution, and the values can be modified as needed. So remember, variable is basically something in the code that's changing a lot. For example, different people will have different ages, their names will change. Can be specific or inferred. In other words, user can say what it is, or the application can try to guess it. The scope determines where it should be accessible and where they should be pulling that code. The other thing you have in a code is something called a constant. This is where there's a fixed value, cannot be changed after it's been assigned. So it pulls in one value and it stays there. It prevents accidental modification. Constant characteristics, for example, a constant is like pi, that'll never change. Or the maximum size of characters in this field is 100. This improves the code reliability, makes it a whole lot easier to maintain. Now, I want to show you guys those two things. So, where are we here? We're 4.3. So you notice, the first thing I want to mention here is we are identifying it. And you notice I have a variable, I have a constant, all right? So the variable, this can change. These are things like the current level of the game. The current level, this game can go multiple levels, is 1. So we can change it to 2 or 3. Versus guess the number, that is the name of the game. We will agree to never change this. All right, that's something that you guys should understand. That in a constant we don't change, but the variable could change. The next thing we want to talk about is something called an array. An array is basically a collection of related data items. Its element accessed by indexing the position, by the index position, basically where it's capturing the data from. All elements should share the same data type. So you can't have an array with numbers and character and letters. The array should be, if it's all numbers, it's numbers, or if it's all text, it's text. Maybe the scores, maybe the names of something. It could be fixed. In other words, the array can hold a certain amount of numbers, a fixed set of numbers, or it can increase and decrease as needed, what's called fixed or dynamic sizing. It stores multiple related values. It's efficient data organization. It loops through these elements easily as needed. And we have an array, and I'll explain that to you guys in a minute. Actually, you know what? Let's take a look at it right now. So what was an array? Well, remember, in the game, we had to guess numbers. Remember this? Attempts left is 5. Guess a number. First, we guessed 10. Well, that wasn't it. Then we guessed 15. 18, and then we guessed at 20. So that was the array. The array, we use arrays to store these guessed numbers. We're using that array to store all of the values that the user has given us. Another thing we have is a function. A function is a reusable block of code that does a specific task. Now, we call these functions to do things in coding. For example, in this one here, we have a function, and some of the functions we have is the print function. This can be called to review the game history. So the print outputs whatever is happening that the user wants. So basically the function, like the print function, would be used to print to the screen what the application is doing. This particular function is basically a code. It's a small set of code that's called over and over in the actual application. It accepts input parameters. If you notice, this is the function, and it has an input parameter in it. So you would have to customize that, and then it returns a result. Function characteristics is generally defined once, called multiple times. Parentheses, parameters pass data into the function. If you notice in here, you have the print function, and then you have, hey, this is what we're passing, and this is what we wanted to print out. Returns value and sends the data back to the user. Now, what's the benefit? Well, it reuses code duplication, makes it a lot easier. You don't have to rewrite code all the time. Makes the program more organized and easier to test and debug. The last section of this is going to be an object. Now, what are objects? Well, objects combine data and behavior together. They model real-world entities in code. They're the foundation of what's called object-oriented programming. Now, objects are used a lot. Java, for example, is one of the most famous object-oriented programming. Here's the thing when you do object-oriented programming, or OOP, object-oriented programming. Object-oriented programming, or when utilizing objects, allows you to reuse objects. So you write code and you write large blocks of code as an object, and then you can keep pulling it back and keep calling it, so you don't have to rewrite that same set of codes over and over. It just makes code writing a lot easier. In the objects themselves, they have properties. Data stores within the objects. They represent the characteristics of the objects, the attributes of the object. So for example, when you make an object, you're going to have a property of the object. One of those properties is maybe you're defining the users in your application, the name, the age, the height. Maybe it's something with if it was a car, maybe you're talking to the color and the make, the account balance in there. So you would define this once, and then you can call the objects over and over. For example, let's say you're making a banking application and you want to define the user. So you define the user object. Well, the user object is Andrew, and his name is Ram, and he lives here, and he has this social security number, and blah, blah, blah. So every time they need to reference me, they just call the object. They don't have to pull the data or recode me back again. And that would be stored in the properties, by the way, of the object itself. The methods, the functions that, methods are functions that belong to the object. So these objects have methods. These are going to be the functions within the object that define what the objects can do and operates on the object's data. Can the object walk? Can they speak? Can it start? Can it stop? Well, if we're doing a banking application, the method that we can do is that we can say, well, Andrew, as a user, we can deposit or we can withdraw. So that would be the method. Basically, what can the object do, right? It's the functions that belongs to this object. All right, so just a couple quick things in here. Once again, you don't need to memorize all this stuff. You do need to understand it. If you understand it, they're pretty simple to get right on your exam. When it comes to programming, you have to understand how organizations are going to be programming themselves, and you got to understand some logics of how codes actually work themselves. Let's get into it. So we'll take a look at what's called pseudocode concept. Object-oriented programming methods. I mentioned a little bit about that before. We'll talk about why you need to comment on your code, what is a flowchart and why that's used a lot, and then the logic concepts behind it. Let's get into this. The first thing I want to talk about is pseudocode concept. Now, what is this? This is human readable programming description. This is written in the code. It's written in plain language. It's a bridge between planning and coding. You see, it's important to understand that when you're coding, you understand that we humans don't think in code. We think in normal human language. And pseudocode concepts is us writing down what this application should be doing in readable terms. It's not really executed by the language, but it is showing. Like, here's a pseudocode concept, and you can see for the game, they start the game, we ask the player for the name, we create a player object, we pick a random secret. While attempts left and not guessed, we ask for a guess. If guess correct, show success. Else, if the guess is too high, show too high. If it's too low, and then show a final score. This is pseudocode. What this is doing is, it's very human readable. It's just text. It's written in plain language. It makes it a whole lot easier to code if you see that. The benefit is that it's plain logic before writing actual code. Before you go in and you start writing all of your if-then statements, why don't you write it out here first? It's language independent approach, right? It doesn't matter what language you're using. It doesn't matter what programming language, you should still do this. It's easier to review and to modify. The next thing we want to talk about is object-oriented programming. Now, this is when you're organizing code around objects. You write code as objects. It models the real world, because in the real world, everything is not separated. Everything is an object. In the real world, think about it. We are people, and my name is not separated from me. I'm still me. So object-oriented benefits. It allows us to reuse code and makes code very modular. Easier to maintain than extend code. Natural problem-solving approach to code. Because you see, in codes, when you're writing code and you've already defined something, you don't want to have to just keep calling and redefining things. If you define something as an object, as a user, as an object, and it has all these properties, his height, his weight, his name, his account balance, what he does, you can just keep calling back that object, making the objects a lot easier to use. Something else is called comments and documentation of your code. When you are writing code, it is important to explain the code. It's basically explaining the text within the code itself. Like, if you look at this code here, you see, and I told you guys, anytime you see a pound sign and a set of text, this is the comment. This is not being executed. This is that anybody that reads this code, like me and you, we be able to understand what this code is doing. All right, that's why we need commenting, because it allows us to understand what this code is doing. Without that, people looking at the code 1 year from now, or people not familiar with your code, is going to have to sit there and manually figure out what you wrote. So it describes the purpose, the functionality. It's essential for maintaining the codes. Single line comments for brief notes. You also have multi-line comments for detailed notes. Documentation comments for API references. Documentation comments is when you call different programs to help run your program. Benefits? Well, when you comment on your code, it makes it easier to read. You should also have documentation on your code. This code does this, this application does this, these functions were used, this was the main function. It helps others to understand your code. It explains complex logics for your code, and it reduces the maintenance time window on your code itself. Next thing we want to talk about is something called a flowchart concept. This is a flowchart. So a flowchart is a visual representation of a logic of a program. So when a user logs in, they authenticate. If they put in the wrong authentication, it kicks them out. Put in the right authentication, allows them in. When they're in, they have these options. If they click this, they get this. If they click this, they get this. Notice I'm forming this diagram. It shows decision points in the process. It's like the entire flow of the entire application itself. It's a good planning tool that we have. It describes the sequence. If they're going to do this, then we should do this. If they're going to do this, then we should do this. One step follows another. Now, speaking about if they do this, then they should do this, there is something we call a logic concept. Every application has to have some kind of logic to it that this application, if they're going to hit this wall, they should be able to, if they're going to do this task, then it should do this. If this doesn't function, then it should do this. This is called logic. It's a lot of if-then statements, if-then-else statements. It enables complex decision. All programming logics are based on this. There's something we call branching logic. The program chooses different paths based on the condition or user inputs, also called conditional statements. For example, if then do this, or switch or case statements. So remember for your exam, a branch is when the program chooses different paths for the users. Here's another one I want you guys to see, and then I'm going to show you here. Versus loop-in logic. It's when you repeat code sections multiple times until a condition is met. This allows for an efficient way to process data. The loop-in benefits, it processes large amounts of data, it reduces code duplication, and it automates repetitive tasks. So loop-in is going to process a lot of data quite often. Now, I want to show you guys loop-in and branching. So remember, branching chooses a path for the user, and loop-in repeats something over and over until a certain condition is met. Remember that. So let's go back here, and I want to show you guys something. We'll look at this loop-in. Now, we're not going to read the code here, but just this code here, this was the part about the loop-in. So repeat until the player runs out of attempts. So it kept doing this. It kept looping over and over. It kept asking us to keep guessing a number until we ran out of attempt. So this was a loop that kept saying, hey, guess this number. Hey, guess this number. Hey, guess this number. Oh, you got it right. You got it wrong. You got it wrong. You got it wrong. The branch was compare the guessed number to the secret. So the branch was, if they guess this thing correct, tell them they win. If they didn't guess it correct, tell them they lose. That was the branching. It's comparing the guess to the secret number, and this is the code that did that. We don't need to go into the if statements here, but you notice this is a giant if statement versus the loop-in had used it a while. We're not going to get into all that, but while loop-in it's called, but that is okay for this exam. All right, that was the section on programming, guys. Hopefully it wasn't too complex. You don't need to go and write codes and all that to pass this section, but you do need to understand it to ace this section. In this section of the course, we're going to be learning about data. Just plain data. We'll also take a look at databases and how to back up data. So let's get started in this section. The first thing we're talking about is section 5.1, where we're going to look at just overall data. Let's have a discussion on all this big data that's being accumulated throughout the world. Let's talk about data analytics and how it's being monetized, and how businesses that are data-driven is going to probably be more successful, and why data is probably the most valuable thing on planet right now. Let's keep going here on this. The first thing we want to talk about is, what is data versus information? Well, data is just raw facts about something. Data about me, well, I'm 6 feet tall and I weigh 220 pounds. That's one data is I'm 6 feet. One data says I'm 220. Well, what we're going to do is we're going to take this data, we're going to process it, and we're going to find out information. So information is processed data with meaning. That means that when you process data, you can say, well, Andrew, you're technically overweight. You should be under 180 pounds to be not overweight. So when you process data, you end up with information, which is generally meaningful data. Now, a couple of quick things here about data. Both are valuable in business. Businesses accumulates data, processes data into information, and makes it valuable. Information is an asset. I would say the most powerful asset on the planet, the most valuable asset is not gold, it's data. Data drives everything. We're going to learn about this coming up a little bit later in data analytics. Modern businesses depend on data. It's how modern businesses work. It gives them a competitive advantage, and we're going to have to protect them. Think about it. If a business knows what users are looking for, when they would buy a product, if they have the type of data that tells them why you would buy something, where are you looking, so they know where to market to you, how to market to you. These businesses can sell more products. So data is very important to businesses nowadays. Critical data would be essential for business operations versus non-critical data. Well, they have it, but it's not critical to their business operation. Different protection mechanisms for the data. Obviously, critical data is going to require much more protection than non-critical data. Maybe critical data, we're going to encrypt it, we're going to put user permission on it, versus critical data, we're probably not even going to encrypt it. We'll probably back both of them up also. Now, what are some examples of critical data? Well, your financial information, your bank account number, how much money you have in your bank, your purchases, product designs and patents. Maybe a company has a secret way of designing certain things. Employee personnel records has their name, their social security number, their addresses. Non-critical data are things they have on their website. Publicly accessible information, general company announcement, marketing brochure. Generally, if they're giving away the data, it's probably non-critical. A lot of business decisions in today's world is data-driven. Nobody should be making decisions in a business without having the correct data. The data will tell them if what they're doing is right. For example, let's say a business wants to offer a new product. Is there a market for that product? Would people actually buy that product? How should the product be designed? That's a data-driven business. If they know what consumers are looking for, how they're looking for that thing, what they want out of that thing, and businesses are able to make that thing and deliver it, that business is going to be pretty successful. So we want businesses that are data-driven, using data to guide strategy, to guide what products we want. Replaces guesswork, guessing, hey, you know what, maybe the public wants this. This is, of course, going to improve outcome to from our products. Data capture and collection. How can we go out and gather data? How can we gather raw information from various sources? How can we know if customer is going to interact with that? Are we going to look at different transactions? Are there different sensors or surveys or observation of how people are browsing that we can determine this is the products that customers are looking for? Let's take a look at some methods. When it comes to gathering data about, let's say you're building a product, how do you know whether users want that product or not? How do we know if the users are going to use that product or not? Well, maybe we can ask surveys. Maybe we can have online forms and surveys. Maybe we can look at what they're buying, a point of sale system. Maybe we can look at what websites they're going to. Analytics and tracking. This is tracking what websites people are going to. It's a common thing that businesses do nowadays. Once you have all this data and you start gathering what website people are going to, what things people are buying, what surveys were done, now you have to correlate this. You have to look at relationships within the data set. Well, they're going here, they're looking at this, they're tracking this. Identify patterns, and then this is going to reveal insights that is not so obvious that consumers are trending here or trending there. Consumers of this age group are looking at this or not looking at this. Now, once you have and you correlate all your data, now you can make meaningful report. This is converting data into actionable insights. You could make presentations, tailor it to the audience. If it's like the CEO of the business, you can tailor it to them, to those people in particular, and you'll be able to make the right business decisions. Now, how do you convert data into money? Data monetization. Well, there's a lot of companies that are selling insights. There's companies that actually sells your data. This helps other companies improve products and services. For example, companies like TikTok, Instagram, Facebook, YouTube will gather and they got tons of data on users. What users are looking, what are market trends. Companies like this will turn around and sell this data to other companies, to large organizations, to determine what products are popular. What are people searching for? For example, let's say you own a company that makes products. Maybe you own a company that makes mouses. And you're going to ask the question, well, what are people searching for? You might go and pay YouTube to look up what are people searching for? What type of mouse searches are they looking for? How would they like their mouses to be designed? And so on. So that's where you can turn data into money. Now, the other way of doing this is that if you have the right data, you're able to make the right decisions to make the right product. This allows you, of course, to monetize the data that you have. Because if you know the right product to make, you can make money with that product. Monetization example. Well, we just talked about the data licensing. So YouTube can license out their data to all their different partners so people understand what products to make. Targeted advertising. There's one way YouTube and Facebook and Instagram makes money is by targeting the advertising. Based on what you're looking for, what you're watching, what you're searching, they're going to be able to target ads towards you, and hopefully you watch those ads so they can collect their money. Premium analytics. People sell the analytics of the data. This is what I was mentioning earlier also. Data analytics. Data analytics is basically analyzing data. It's the process of examining bulk information. Statistical analytics, looking for patterns. It transforms raw data into knowledge. Data analytics is very popular. For example, in Netflix, it does a lot of data analytics. It realizes, well, he watched this movie, he watched this cartoon, he watched this TV series, well, he's going to like this. That's data analytics, is when they take data that they have, like you like this, you don't like this, you watch this for an hour, you changed it, and they're able to then present to you the next program they think you should be watching. That's a form of data analytics. When you buy things from Amazon, Amazon is going to notice, oh, you know what, he bought milk, he bought this cup, then it might recommend, oh, you want to check out some coffee? Because you have the milk, you have the cup, you might as well get the coffee. This is data analytics. It's analyzing data to come up with meaningful information. Big data. The world is built on big data. The whole world, this whole thing about, think about how much data. Every time you surf the internet, it's just mass amount of data. Every time you add something online, email, Word documents, presentation, videos, it accumulates into data. Extremely large and complex data sets. In organizations today, they have big data. They have too much data. All these documents, they accumulate over the years. Inventory information, payment information, customer information. All these things accumulate into large data sets. They now need ways to process them and analyze them to have meaningful information about them. And that is becoming more and more complex. All right, that concluded this section, just a general discussion on data. Understand, data is growing all around the world, and it is the most valuable asset. Andrew from the future, if you're enjoying this course so far, once again, if you would like to get the course notes, the presentation I'm using, you would like to get practice questions, and just watch it without, I'm pretty sure YouTube is going to put a lot of ads. If you would like that, don't forget to check out the links below. My website, TIAexams.com. You can get this course for just $9.99, the price of basically 2 cups of Starbucks. And you can also, I think this is also going to be on the Udemy platform if you have that also. You can get the course notes, you can get practice exams with it. Let's keep going in the course. Let's start a discussion on databases. One of the most used places to store data is within a database. All of our data is stored in some kind of database somewhere. Famous databases like Microsoft Access, which I'm going to be showing you guys today, Microsoft Access, Oracle database, MySQL, Microsoft SQL. These are very famous databases where we store data. Almost all of our data. And when I say data, I'm talking websites you visit, your name, address, social security number is replicated throughout millions of databases across the world. But what is a database? Well, that's what we're going to answer in this question. What's the uses of it? What's a flat file versus a database? What are records? How do we store it? And how does it become available? Let's get started. Now, I do have a database that I'm actually going to show you. It's built on Microsoft Access. It's like a student database that comes with Microsoft Access. I'll give you guys a quick tour of it so we can understand some of the concepts. The first thing we want to talk about is the database itself. What is a database? Well, it's an organized collection of structured data. That's what you guys got to understand. It structures and organizes a bulk set of data. It enables efficient storage and retrieval of this data, and it is the foundation of all information systems that are out there. Almost all systems that we're going to use today, whether it's a website, It's an application, has a database. Every single website that you use today, whether it's LinkedIn, it's Facebook, it's just Amazon, it's just some guy's text website, they all have some kind of a database behind them that's holding that information. The only time you don't really have a database is if it's just a page with just text, like there's nothing on it. But if your website stores and tracks some kind of thing, whether it's user accounts or people logging in and buying products, you're going to have some kind of database associated with it. All applications have databases. When somebody say an application front end and an application back end, the front end is what we use. For example, when you logged into LinkedIn and you're using that interface and you're just seeing all these different posts and you can update your account, that's your front end. The back end is the database behind LinkedIn that is storing all of that data. Now, why do we use databases? Multiple operations for data management. It allows us to store data, correlate data, and categorize them. It's essential for almost all business functions. Supports various organizational needs. A company is going to have somewhere where they store their customer info, like their name, their customer name, first name. They're going to have somewhere to store the credit card information, the shipping information. Let's say you own an e-commerce site. You're going to have somewhere you're storing your customer's name, phone number, address, shipping, products they bought, how much they paid, and so on. You're going to have some kind of database to track this. Now, when you're thinking of a database, create database operations. So this is when you add new records to a database. It's an input used to input fresh data into the database. It helps expand the data with new information. I'm going to show you guys this coming up in a minute. You have import export. You can also import data from text files into databases. You can also, this is going to allow us to do bulk entries. So let's say you have like an Excel sheet with a whole bunch of customers' information. I can import that into a database system. Now, query operations. When you are trying to search your database, when you're trying to extract information on your database, that's when you use a query. It allows you to search and retrieve data in a database. For example, let's say you have a database that tracked a whole bunch of user accounts and you were selling different widgets A to Z, and you want to find all users that bought widgets A and B. That's a query. A query allows you to filter out the records in a database to find whoever bought a specific product. Now, reporting. Every database is going to give you some kind of report. You have to have a report. Let's say you have this product database, this e-commerce, you're selling online database. You have to have some kind of report to show you what this data is about. Maybe you want to report on, give me all the users that bought product A. Give me all the sales we did last week. Give me all the sales we did today. Give me all the refunds we had to do. That's a report. It's a presentation of the data. It summarizes and analyzes the data, and it should be formatted for whoever needs it. Now, I want to show you a database before I get into this flat file thing here. So what I have in front of me is a Microsoft Access database. And in this database, you have what's called tables. Tables is where we store data. And I want to show you one of the main ones is called My Students. So this is a database that tracks students for a school. So if I open this up, I can see that I have two students already. I have Andy Ram, and his brother, Peter Ram. This is their student ID numbers. This is their grades. One is in 5th grade. Peter is in 7th grade. This is their date of birth. So this database is tracking students. This database will be able to track who's the student guardian, and it can also track their attendance. So this is a database, all right? So what is the database doing? It's storing the data for this particular school. And again, there's all kinds of databases that are out there. Another thing we want to mention is what's called a flat file. You can see how this is sorted. You see how this looks? This here has Andrew and Peter. It sorts it by table. I can even go in there and put in attendance. Who's the guardian of these people? I can filter it out. This database allows me to store lots of data in all kinds of fields and all kinds of related information. Another way to store data This is a Microsoft Access database. Microsoft Access is a system is basically a database system. Other famous software you can use to make databases is MS, Microsoft SQL, Structured Query Language is the name of the software. You have Oracle. If you have guys heard of Oracle, they're big. Oracle is one of the biggest database systems out there. If you want to open source things that are powering up the internet, would be MySQL, MySQL. There's some very popular ones. We'll take a look at other types of databases there, but those are going to be some of your popular ones. So what is a flat file? Imagine you just open up Excel or a text document and you just type in data. That would be a flat file, instead of having it in this structured approach that I have here in Microsoft Access. So it's a different approach to storing data. Each of these are a different approach. Each has advantages and limitations. The choice depends on the requirement, actually. I wouldn't say one is better than the other. I think there are certain usages of flat files, but databases have more usage. So a flat file, when it comes to concurrent usage, which means I can have 4 or 5 people entering student data at the same time in my database. If you're using a flat file, let's say we were storing people's data just like an Excel sheet or maybe like in a text document, it'll have very, very limited users can connect, maybe just 1 or 2. With a database, you can have thousands of people connect. The database handles more concurrent. It's more scalable. It's difficult to expand a text file because it's one single file, like one Excel file, one Word document. It's difficult to expand. Databases are meant to grow. These files can grow into the terabytes. Very big. They handle lots and lots of data. Flat files are slow for data sets versus databases are optimized for speed. Guys, the New York Stock Exchange runs on a database. All right, so databases are used. Amazon with the billions of products or millions, who knows, of products. That's all a giant database. Flat files generally handles one type of data, simple types of data. You could put complex data sets and you can relate data in a database, allowing you to handle multiple data formats. Inside of a database, you have what's called records. Now, I want to talk to you guys about how data is stored in a database. In a database, records are stored the data is stored in tables. A table is where you store the data. Let me show you. So let me go ahead and open up one of these tables. I want to show you guys, this again is Microsoft Access. You notice how it says tables, and I have one called students. All the records, all the data in a database is going to be stored in these tables. Like I have a table called students. Inside of this table, I have a record for Andy. I have another record for Peter. I have 1 record, 2 records. You notice that this is a row in the database. A database also has what are called fields. You notice I'm tracking the last name, the first name, the email, the student ID, the mobile phone number, the home phone number of all these students. These are called fields. So fields are like columns in the database, and the rows, as you can see here, is where the actual data is being stored. Now, this is all databases are like this. It's not just Microsoft Access. Whether you're using an Oracle database, a Microsoft database, they're all going to basically show you these things. So they contain the database records are individual entries, like how we have Andy and Peter, and they contain related information, like a customer record we have. Now the record structure. Each one of these records has specific fields and data pieces, like what is the first name, what is the last name. Each record has a unique identifier, and I want to point out to you guys what that is. So each one of these records must have a way to identify them. You see this field here? This field called the ID uniquely identifies this record. Every record in a database needs to have some kind of number that uniquely identifies it so it can be called. It's called the primary key of the database, of that table. This uniquely identifies the record. The database doesn't actually care about the other fields. When it's pulling the data, it cares about that unique field. The database needs to know, oh, you want that record? I'm going to get that one. But how does it know it's that particular one with this unique field? In society today, our government doesn't know us by our names, right? A lot of us have the same name. It knows us by this unique identifier. They're generally called the primary key of that particular table that you're storing your data in. Consistent. Now, one of the things is that this is going to do is going to allow us to have consistent records across it. Where do we store data? Well, one of the great things with databases is how and where data is physically kept, storage. Depending on where you store it, it's going to affect the performance and accessibility of it. And it's critical for how you're going to manage your data. So you have to know where you want to store it. Now, databases has a term we call data persistence. Database data survives power loss unlike RAM. The moment you enter data in a database, you click next, it saves it. There's no save button in a database, not like Excel where you have to keep saving it. All right? It's essential for business records and transaction. If a system fails, the database should be able to save that data while your bank account survives system reboots. That's right. The database is saved. Every time you type in there, it saves it right away. Databases has high availability, depending on where it's stored again. If a database is not configured right, doesn't have the right setting, people can lose it. But if it's configured right and it has the right backup settings, redundancy built into it, it can survive and it can last a long time and it'll always be up. So what's database availability? Well, it's how and when you can access your database. This can affect business operations because if your database becomes unavailable, your entire data set can drop. You must balance between access and security. I want to talk about this because you don't want to give too much people access to a database. Giving too much people access could mean that's a security risk. Hey, Bob doesn't need access, but Mary does. Maybe even vice versa. So be careful who you give it access to. Let's talk about where we're going to store it. When it comes to storing our data, are we storing it in the cloud or are we doing local storage? Cloud is generally going to be in a remote server like AWS. On-prem or local is where you're going to be storing it on-premises. Each has its own security and access implications. For example, if you store it locally, it's more secure in the sense that you have more control over your database. Generally, the outside world can't access it. But because the outside world can't access it, it might be limited in its functionality because if you have different offices around the world, then those offices might not be able to access it either. And then you have to have the equipment and the resources to secure it and maintain it. If you put it in the cloud, AWS, Amazon can secure it for you. Anybody can access it, so it becomes accessible to the world. They'll maintain it. But then it's a security issue because now everybody can access your database. So you got to think about, do I want cloud storage or local storage? And some organizations will go with cloud, some will keep it secure. So in the cloud storage, it's accessible from anywhere. They do all the backups. They scale it up so they have the hardware. If your database is growing, you don't have to worry about getting more hardware to maintain it. With local benefits, you have more control. There's no internet. You don't need any internet. It's probably faster and it's probably going to be more secure, but then you kind of lose all that accessibility functionality. Online versus offline access. Well, online means you need an internet connection to access the database versus offline works without connectivity. This affects when data is available. This Microsoft Access database, this works offline. I don't need an internet for it. But if it's a database in the cloud, you're going to need internet access to access it. Something to think about. All right, guys, interesting things there on a database. Let's go in now and take a look more in depth into what databases are in the next lesson. Let's take a look more in depth into databases, and particularly I want to talk to you guys about the Access database that we've been talking about. That's known as a relational database. I'll show you. We talked a little bit about tables, but I want to show you guys what the schema looks like. We'll also talk a little bit about structured versus semi-structured and unstructured data and a non-relational database. Let's get started on this. The first thing up I want to talk to you guys about is the database structure. This is the way databases are structured, or data in general are structured. There are different ways to organize and store data. Each approach serves a very particular need, and they does affect the performance and capability of the database. Now, most of the databases we have are basically going to be structured databases. So what's a structured database? Well, a structured database is like how I have Microsoft Access. That's going to be a relational database. Microsoft Access, Microsoft SQL, Oracle databases, MySQL are going to be relational databases. They have a schema. We'll explain what that is in a few minutes, with specific fields and relationships to how the database is designed. They're highly organized in a predefined format. This is a structured data. Now, the other type of database is, and I'm going to have all of those things. Structured data characteristics, guys, they're consistent across all records. They're easy to search and analyze, but they do require a lot of planning. You have to know all the table structure. You have to know all the fields that you want in your database before you make them. The other one is going to be semi-structured databases. Some of these are just going to be like text files, but it's well-structured text files that it can be imported and read by multiple applications. Some organization does this. For example, if you store data in JSON files, this is a type of a structure where this file has a bunch of data, but it can be read by multiple applications. It tags or provides markers to see what this data is about. Good characteristics is very flexible. It can be read by multiple applications. It's pretty self-described, and especially if you use JSON. All right, I'm not going to go into like the specifics of like JSON and all that. We'll do a little bit more of that in Net Plus. But JSON is an example of that. Non-structured. This is just no real formatting. It's free text form content with no fixed schema, no real markup language to say what the data is. It's just jumbled up. Non-structured data are things like emails and just random text and documents and pictures. It's very flexible. You can't really search it. And it does require specialized tools to analyze. So not the best thing out there. Now, the database that we're going to be talking about, and because just almost all the big applications runs on them, is relational database. All your corporate databases uses relational databases. Data is organized into tables. Now, I showed you guys a table earlier. So a table is made up of two things. A table is made up, let's open this table. A table is made up of two things. Rows, right? So we saw Andy and Peter, those are the rows, the records, and fields, the things about the data, like the last name, the first name, the email, the student ID. So this here allows us to have a very structured approach with the data with a fixed schema. Most common database type is a relational. Almost all database types are known as relational databases. Now, this term we keep coming up with, the schema of the database. The schema of the database defines the database structure, how the database will look like, how the tables will look like. It specifies the tables, the fields, and the relationships within those tables. This must be designed before data entry begins. So people create this schema in the database. And benefits, it ensures data consistency, enforces the rules of the data, and provides clear data organization. So we know how the data will be organized. Once again, I'm going to show you a schema in a minute. I'm going to show you guys that. Let me cover tables. What's a table? Well, it's a collection of related records in a database. It's organized, we said, by rows. We have Peter, and columns. Those are going to be all the things we're tracking, first name and last name. Each table represents a particular entity type. Remember what rows are. Those are the lines across the data, individual entries. Each row contains a complete data set. So each one of these rows here that we saw for Andy Ram, you notice this is a complete record of Andy. Represents a single entry instance. So each row, one is Peter, one is Andy. They're each individual separate entries in there. We talked about inside of that table, we have columns, right? Those fields, those individual data elements. There's the individual data elements for the first name, then the last name. Each column has a specific data type. For example, you'll notice that this one here is a number. This is text. How do I know that? Well, when you are designing your table, I'm going to click this button here. It takes me to the design view. These are all the fields. You see, like the ID is a number. It's an auto-generated number. The first name and last name is a short amount of text. The date of birth is a date and time. You can go down, you can see it's telling you it's all text and different types of data. So in this one, we can see that when we design our database, we have to know that these column types support a specific thing. You can have column types that just supports links, just supports numbers, just support text, and you can specify the length of how much text can fit in there. Each table has to have a primary key. All right, each table has to have a primary key. It's a unique identifier for each one of the records. It cannot be null or duplicated. In other words, you can't have two records with the same primary key. It's like having two people with the same social security number. You specify that when you create the table. It ensures every record is unique. Remember this, the primary key can never be duplicated. It has to be unique. Let me show you guys what it looks like. Here's my data here. So if I go back and I'm looking at this table, I can go back to my design view, and you see this one right here. See this one, this ID number? It's an auto-generated number. You see how it has a little key next to it? I know it's kind of hard to see that, but you see primary key is selected. That's the primary key of this table. This number, number one, number two, we only have two records here. This is an auto-generated number. It should never, ever be duplicated. What are some examples of primary key? Maybe the customer ID, the product code, employee number, your social security number. What's a foreign key? This I'm going to hold on. I'm going to hold on to this. I want to show you guys something. I want to talk about, before we get into this, I want to talk about the schema and the relationship. Why are things called relationship? Why are databases known as the relational database? Because in a database, you have multiple tables to store different data. For example, if you have a student database and it tracks the students and it tracks their attendance, you have to make two tables. One table for the student and one table for the attendance. One student will have multiple attendance. You follow me? Right? So one student has because he attended 10 days. Let's say he went to school 10 days of the year. So he has one student has 10 days worth of attendance. I want to show you guys how that actually looks in a database. Watch this. I'm going to close this. I'm going to go to database tools, and you have something called relationships. This is the schema of the database. I'm not going to get in depth into this, but the schema of the database. These are all the fields that was in that student table, the first name, the last name, the email. And then you have student attendance. All right, so you notice there's a 1 here, but there's an infinite sign here. That means one student can have multiple records in this database, in this table, I'm sorry. And you notice how there's a student here that this is linked to. You see if I double click this line, you see it's the ID field from students links to the student field in the student attendance. This is important to know. And you notice how referential integrity is checked. You see, what this is telling me is, when you go in and you put in the attendance in the student attendance table, this is a table. Student attendance is a table. You see, it's a table. All right, so we can see the different design view of it. So student attendance is date and time. So watch this. If I go in here and I say student 1, Andy, and you notice you can select, right? Andy, what's the attendance? Well, on this day, he was present. You guys see that? So student 2, notice I got to put in Andy again. It's this day. Now you give him another day. Present. So what this is doing is that it's telling me it's tracking the attendance. So notice I can go and, you know what, let me show you guys one more thing. I can go in there and add Andy again. Actually, Peter. present. So you can notice how the Andy RAM has 2 records in this database. Peter has 1. What does this tell you? Well, one student has multiple records in the student attendance, and this student ID is linked to this student right here. Let's talk about this for a second. So you have 2 tables, one table that tracks all the students and one table that tracks all the attendance. We relate these 2 tables together with a field, the student ID number field, to the student field here. And what that is doing is that it's relating these 2 tables together. That's why it's called a relational databases. Relational databases is basically when you have a database with all kinds of tables and then you have the fields related to each other. A relational database. Now, watch this here for a second. Let's go back here. There is a term I want you guys to know. You see this term called referential integrity. Enforce referential integrity. You know what that means is, referential integrity means that you cannot have an orphan record. What's an orphan record? Well, you see, these kinds of relationships are called parent-child relationship. The parent is a student, the child is the student attendance. In this relationship, you have a primary key, the student ID from the student's table linking to the student in the attendance table. This is called a foreign key. So the primary key are linked to foreign keys in these kinds of relationship. They're called one-to-many relationships, one student, many attendants, or parent-child. One parent has many child. You can say that to them. But what they're doing is they're maintaining referential integrity. When you enforce referential integrity, you're saying that you can't have attendance without students. Nobody can go in and just enter an attendance without putting in a student. This prevents what's called an orphan record. An orphan record is basically an attendance without a student. It's a child without a parent. So what are foreign keys? Well, they link to the primary key in another table. That was the student name in that student attendance. It creates the relationship on the database. The benefits here, guys, it prevents orphan records. We just mentioned that. It enforces the data relationship and it joins the table as we just saw. Now, can we go in and do constraints? Well, I showed you guys that when you're making a database, you can set a constraint. You can say, hey, that particular data set can only be numbers. So when you create the fields, you can constrain it. It can only be numbers. It can only be text of certain characters or lengths. So this allows, it limits the allowable data and it ensures data quality. Because, for example, if you're selling a product and you have a product database and you have a price field, you don't want people to type text in there. Somebody types text, it's going to screw up all the data calculations. So what you want to do is you want to limit it to just numbers. Now, let's talk a little bit about non-relational databases. What I showed you guys was a non-relational. NoSQL is a type of that is a type of database called NoSQL. It has no fixed schema. What I showed you there is those relationships is a schema. Handles a wide variety of data types very efficiently, especially large data. This is becoming more and more valuable or more and more used. You have key value databases. This is a simple structure with just a key value pair. It's fast retrieval using unique keys. Examples of this, DynamoDB is very famous, or that's Amazon's DynamoDB is very famous for this. Remember for your exam, key value databases, extremely fast, very simple data model, but it's hard to query the data. It doesn't have as much querying or search functionality. Document databases. This stores data as document. Very famous is MongoDB. It has a flexible schema within documents. MongoDB is a perfect example. Basically, just remember for your exam, a document databases basically stores data as documents. If you have lots of different applications and outputs, this is a natural fit for that. It does support flexible data structure and it's easily to scale horizontally. In other words, the same data types. All right, guys. Interesting things here on using a relational databases. Hopefully you guys learned something in this one. If this lesson spin your head around, I used to create Access databases a long time ago, and I've made quite a few SQL databases. It can get complex, so hopefully I simplified it enough. What I told you is just what you need to know for your exam. Don't try to go complex or try to figure out or make your own databases. That's a whole career by itself. Just know what I'm telling you for your exam. In this video, we're going to be talking about data backups. There's an old saying in IT. No backup, no restore. It's not if, it's just when. What do I mean by that? Let's put it to you guys this way. It's not if your systems are going to fail. It's not if this laptop is going to die. It's not if this phone is going to die. It's just a matter of when, right? And whatever I have on it, this and this is going to go away. Whatever I have on this is going to go away unless I have a backup. And that brings me to this one. Let's talk about backing up our data. Let's talk about file backups, system backups, restoring data, and we'll talk about, should you store your backups locally? Should you do cloud storage? Some interesting concepts here. Let's get into this. Number one, data backup. Creating copies of important data. Something as simple as just making a copy of your data to a memory stick or an external drive is what I'm talking about. It protects against data loss. It's not if, it's when whatever you're storing your data on, whatever drive you're using, will die. It's essential for continuity because if your data is gone, there's no continuity left. You can't use your data, right? You can't, if a business, think about it, a business has tons of data on its customers and its operation, then one day the database fails or the hard drive fails, the server dies. Do they have a backup of all that data? Again, it's not if, it's when. What's the backup? You want to protect against hardware failure. That's what I'm thinking about. But there's also other things. Accidental deletion. Sometimes you have people on a network, they accidentally delete data. Now, restore after malware attacks. A lot of times when malware gets into your system, it deletes the data, it corrupts the data. Sometimes it affects the data to the point where they encrypt the data and then they want to charge you for it. It's called ransomware. So if you have a backup, you can just delete the infected data and restore with your good data. Backup types. Well, data types for backup. I would say important documents and files, system configuration settings, application data and databases are things that you should be backing up. And there's one thing I don't have here that could never ever be recreated, that I lost. There is one particular data type that you have to back up, that you could never recreate. You see, things like documents, files, system configurations, and settings can be recreated. But there's one thing that you could never, ever, ever, as of this moment in time, recreate, and that is a picture. I lost all the baby pictures of my daughter because I put it on I had it on my desktop that died, but I also had backed it up to a hard drive that also died, and I lost it all. So I have no baby pictures of my daughter for a couple of years, unfortunately. So I'm preaching to you guys about data backup, but when I was very young, thought I had it backed up. I should have had it. Nowadays, I do multiple levels of backup. I'll back it up, put it on a drive, I'll put it on a USB stick. I'll have it in the cloud somewhere. So keep that in mind. To get a picture, you need to go back in time, guys. And sometimes, at least for now, time machines, it doesn't exist. Let's do file backups. This is copying specific files and folders. Something as simple as just dragging it over to a memory stick, user documents and work files. You do have backup software that does this. You can download specific backup software. Corporations use backup software that automate the backup and knows what files to back up. Benefits here, it's quick, it's very targeted, it's easy to restore individual files, it's an efficient use of storage space also. You should do system backup. This backs up an entire operating system, the complete copy of the entire system. That includes the operating system, all the programs, all of the data could be fully restored. So if your computer is like a terabyte big, you have all your applications, your data. You can back up the full system backup. Backs up everything. Your machine dies, just restore all of it in one shot. Versus a file backup, you're just backing up individual files. If your system fails, you need to reinstall your operating system and restore the data individually. System backup benefit. It's a complete system recovery, backs up everything at once, protects against major failures. Restoring data. Well, when you back it up, this is the process of recovering it. Restore data to a usable state. It's critical when the original data is lost. You have to find a way to restore it. This can be as simple as just plugging in a USB stick from data you backed up and just copying it back to your desktop. Some considerations. Verify the data integrity. When you back up things, all right, verify that the data didn't get corrupted. There's sometimes people back up and they go to restore and they realize it's been corrupted. Choose your appropriate restoration point. Depending on the software you use to back up your data, you can restore data at certain points. You can revert data back to certain versions. And when you back up data, always test or restore. Test restore data for completeness. When you back up, you must restore 1 or 2 files from the backup sets to make sure they work. You don't want to be stuck with a point where the data is gone and then you have to restore it, because then it doesn't work. Where do you store your backups, right? Where are backups copied, stored? You should have multiple locations. Store them in the cloud, store them on premises, store them in a hard drive, store them in a USB stick. Just don't keep all your data stored next to each other. What if your house burns down? Your computer is gone. If your house burns down and your computer gets burned down, so does the hard drive next to it. Do you have it in the cloud? Do you have it in a secondary location? Businesses should have multiple locations. Store it locally, kept on site with the original data. You have more control over it. It's good for immediate access to it. Major organizations has multiple physical locations and they store data across. So let's say they have 2 sites, one in New York, one in San Francisco. The New York data will be stored in San Francisco. San Francisco is stored in New York. So God forbid something big happens, they'll be able to pull the data from either locations to restore the other one. So store locally, store it on site, but you should also be storing across different sites. Where do we store data? Well, I think an easy thing to do is just use a USB flash drive for home users, small businesses, small data sets. These things do go up to like a terabyte, easy to transport, but also easy to lose. So be careful with those. Consideration. They go up to like a terabyte. You're not really going to get much bigger than that. Can be easily lost. Think about that. Good for personal file backups. External hard drive can hold tons of data. I've seen external hard drives with 20 terabytes. Large capacity, connects via USB, suitable for systems. Companies, people with lots of data would use an external hard drive, not a flash drive. Big capacity, pretty inexpensive, and it's generally a fast backup. Another thing you can use if you have a really small data set is SD cards. And they're generally removable storage. We mostly use these. I'm using this in the camera right now that we have on mobile devices. Convenient, maybe for backing up devices or device configurations more than backing up an entire server. I mentioned you want to store your data. Store them in case different sites. Don't have them all just in one site. A lot of people use cloud storage. There's things like business cloud storages, like Carbonite is a very famous one. That's a company that does cloud storages for businesses. You also can store your data in Dropbox, Google Drive, and so on. This stores the data in the cloud for you. It's basically a remote backup via the internet. Stored in a provider's data center. It's accessible from anywhere. And some people may not want to do this because if it's accessible to you anywhere, it's accessible to me, the hacker, from anywhere also. So some things to think about. You can automate it. It protects from local disasters. Like I said, what if your house burns down? And it's accessible from multiple devices. But there are some security benefits of that I would want to be worried about, right? Data security. Do you have a reliable internet connection? They'll probably charge you a monthly fee. And then the data security. What if Amazon gets hacked? What if you store your data in Dropbox and Dropbox get hacked? Dropbox is based in Amazon. What if Amazon gets hacked? People can steal your data now. So now you're dependent on the security of Dropbox or Google or Amazon to secure your data. Here's what I would tell you. Data, like just general pictures and documents, I'll store it in the cloud, no problem. But super secret data, like my social security number, credit card information, I am putting that. I'm not going to take a picture of my credit card and put it in a cloud because Dropbox, God knows how secure it is. I'm just being a little paranoid. But something to consider, because remember, you're dependent on the provider, whoever the cloud provider is, when storing your information. Okay, guys, that concluded this section on data management. We looked at databases and we looked at data management. Don't go too crazy on databases. You're only going to get a few questions on your exam, and they're probably going to be pretty simple if you just go through the exam objectives like I did. I promise you, this is the last time I'm asking. Can you please click like and subscribe? My leg and back really, really hurts right now. I'm going to go drink a couple of beers. And if you can click on that like and subscribe, that beer is going to go down a whole lot better. Thank you, and I hopefully you're enjoying the course so far. In this section of the course, we're going to be talking about my favorite topic, IT security. If you have been taking or you follow me online, you notice that I teach a lot of IT security classes. I used to be a pen tester for a while. I used to secure networks, and I used to, quote unquote, hack them for a living. So IT security is one of my strong suite. I also teach a variety of wide, from Security Plus, CISSP, Certified Ethical Hacker, and so on. IT security is a hot topic in today's world. Let's get started. In this section, I'm just going to give you a good introduction to it. We're not going to go in depth into it. You don't need that for your exam, but at least just a really good introduction to IT security. Let's get started. The first section it's just a variety of terminology that I need you to know, like the principles of IT security, what's called CIA, confidentiality, integrity, and availability. We'll talk about why privacy is important. And then we'll look at a variety of terms, authentication, authorization, accounting, and non-repudiation. Let's get started on this. The first thing we want to talk about is security concepts. This section here, what I'm talking about, is the foundational principles of security, CIA. Confidentiality, integrity, and availability is the foundational concept of all information security. We're talking about protecting data, systems, and people. Believe it or not, the most important asset that an information security professional secures is not data, it's people's lives. People's lives are more valuable than data. You can always recreate data, but you can never recreate a person. Now, these concepts and principles are going to guide the policies that we're going to use when we secure our systems. And the first principle I want to talk about, in fact, when you're thinking security, most people is thinking of confidentiality. It protects information from unauthorized access. Only authorized users can view certain data. Prevents data breaches and leaks. Now, what are we talking about? When I say confidentiality, confidentiality is a concept that ensures that only authorized people can access their authorized data. For example, in the accounting department, only accounting users. Salespeople is denied access to accounting data. Mary can access the data, Bob cannot. That is confidentiality. Only authorized users can access certain data. Integrity, when I hear the word integrity, I'm thinking the modification of data. We want to prevent unauthorized modification of data. This is integrity. It ensures data consistency and completeness. Think about this. If anybody can just modify data, even if they shouldn't have access to it, then the data is technically not complete. The data is not very accurate. If anybody can just go and edit any data, the data would not be trustworthy and reliable. Integrity is about the modification of the information. For your exam, remember, data confidentiality is about ensuring the right people have the right access to read it. Who could modify it is integrity. We need to ensure only the right people could modify the data. And the last one we want to talk about is availability. This ensures systems and data accessibility. Who can access the data? Now, it doesn't matter what type of security you have. You can have the world's greatest security. But if every time I need to access the data is offline. Maybe the server broke. Maybe server hard drive blew out or its power supply, so the server is offline. Maybe you're having a denial of service situation, in which case hackers are flooding your website and bringing down your website. It's called a denial of service. In that particular one, I can't access the information. So we need to have high availability. The data needs to be accessible when needed. Think about this. If Amazon, the website goes offline, is not accessible, how much will Amazon lose for every hour it's offline? Tens of millions of dollars probably. So we want to ensure that authorized users can access the information when needed. The other term we want to talk about is privacy. This is big in the world of security. A lot of people talk about this, privacy. Privacy, when you think privacy, think personal information. Names, social security numbers, addresses, your browsing history. That means like websites that you've been to, videos that you have watched. Privacy is big. A lot of countries like the EU have laws like GDPR, we'll talk about a little bit later, that is trying to protect users' data. So it's about protecting your information. Give us, the users, control over how our data is collected and used. There's a lot of legal and ethical obligations that are coming out on this. Throughout the years and the years going forward, we're going to see a lot more regulations that are regulating companies that collects our data, like social media sites, Google, for example, YouTube. Because a lot of social media networking or social media sites collect a lot of information, such as your profile information, the posts you do, your friends, your friendship list, your connections. Some social media sites are doing location tracking where you're located, what videos or posts that you're watching. These are things that are being tracked on you right now, and there are laws that may or may not come out that will help protect you against them. Email privacy. What's inside of an email? Message content, what's attached to it, the sender and recipient of emails. Email metadata are things like the timestamp, when it was sent, who it was sent to, can be tracked by email. File sharing privacy. Documents and media files, who is sharing what file, who has permission and the sharing history of it. This is the metadata embedded in the files, like who created a file, when the file was created, are things that are going to be considered private information. Instant message privacy. This is, by the way, all these things I mentioned are all private, technically considered private information, like your social media things, who's your friend, who's your connection, what videos you watch, your email, who you're sending, what attachments are. The previous one we looked at, what file you're sharing, who you're sharing it with, instant messaging, who you're talking to, your chat history, who is your contact, did you upload, did you do any calls, anything like that on your instant messaging. Notice term, PII, personal identifiable info. This is also big on the privacy. Your name, your social security number, your address, that's considered PI information. Data that identifies a unique individual, it's name, address, phone number, social security number. This all falls under the umbrella of privacy, guys. When we're saying what is private data, all of these things here. What we do on social media, who we're emailing, what files we're sharing, our instant messaging, our name, our phone number. Now, how do we protect our PI information? PI protection. Companies have a legal obligation to protect your PI information. Companies have a legal obligation to encrypt your data and notify you of, hey, your data was breached. You guys ever got a letter in the mail about this company was hacked and your data has been compromised? I got quite a few of those in the mail already. They're legally obligated to tell us this. They should be encrypting our data and ensure only access controlled, ensure only the right people have access to our information. Now, in Europe, there is a regulation that's called out on your exam that applies only to EU residents. It's called the GDPR, the General Data Protection Regulation. It's a standard that gives data, the control of data back to the user. If you guys ever go to a website, in fact, almost every website, and they're like, hey, do you accept this cookie? It's because of GDPR. So what GDPR does was that the companies has to tell the users what they're collecting, and it has to give users the ability to delete whatever they're collecting. So GDPR, you can send out GDPR requests, and companies have to delete the data that they have on you. The requirement, explicit consent for data collection. It's because of GDPR you're having all those things on the website. It says accept the cookie every website you go to. It gives users the right to access and delete their data, and it's basically data protection by design. Again, that is for EU residents. There is something similar in California. You don't need to know for your exam. It's called CCA. It's very similar to GDPR, but it's for California residents in the United States. The next one is cookies. When you go to websites, they're going to be tracking what you're doing on the site, what pages you visit, what you looked at, what you add to a shopping cart, what you might buy. Website tracking is tracked in a small text file called a cookie. Users must approve of cookie. Companies nowadays must be transparent about what they're collecting. Okay, moving on now to the other part of this. After privacy is authentication. I mentioned this earlier. Authentication is proving who you are to the computer. Identification is just identifying yourself. When you come to a computer and you put your username, that is your identification. You verify your identification. You prove who you are by authenticating with a password. I have a whole section on passwords coming up. We'll talk about creating secure passwords coming up later. But this is the first step in access control, is to authenticate to the machine, to prove who you are to an actual computer. One of the weakest forms to authenticate is what is known as single factor authentication. You see, there are 3 ways to authenticate. This is beyond the scope of your exam, but I'll give you a level up. There are 3 ways to authenticate. Something you know, something you have, and something you are. Something you know is like a password or a PIN. Something you have is like a smart card, or they send you a number to your phone, a text message, or authenticator. And something you are is biometrics, like a thumbprint. When you do single factor authentication, you're using one factor. For example, one method. For example, maybe you're just using a password. You just type a username, type a password, and boom, you log in. That is considered single factor authentication. It's the most basic, and it is not the most secure. What you want is multi-factor authentication. Okay? Multi-factor combines multiple methods. I just mentioned something you know, something you have, something you are. So you need to have multiple. Like, for example, if I want to log in to my banking application, my banking website, I need to provide my username, my password, something I know, and then it's going to send something to my phone. So I have to have my phone with me, the Authenticator app, something I have. That's 2 factors. That's multi-factor. There are systems out there that does it all. You got to put in a username. They send you a code to some kind of device, something you have, and then you got to put a thumbprint. The more factors increase the security. So that way, even if I could give all of you guys my banking password right now, it's password 123, you still can't log into my bank, guys, because you don't have my phone to receive the code, because it only goes to that phone. So the more factors you're using, the more secure your systems are. Another term you want to be understanding is what's called a single sign-on, SSO. What is single sign-on? Well, oh man, there's one thing I hate. Passwords. Every application you use, you got to know this password. You got to know this password. You got to know this password. Remember this password. Don't you guys love it when it says, use Google to log in here, use Google to log in here, use your Gmail to log in here? Don't you guys love that? That's a form of SSO. What that is that you use one login, you log into Google, log into your Gmail, and then when you want to log into all the different websites, you just keep reusing that username and password, right? It's able to utilize the authentication from Google to log into different websites. And that's great. So I can use my Gmail to log into my LinkedIn, my Facebook, my YouTube. So I'm using one username and password to log into multiple resources. This is SSO, single sign-on. It reduces password fatigue. It centralizes the authentication. And password fatigue is that way you don't have to remember a whole bunch of different passwords on a consistent basis. Another term you want to understand is authorization. This is determining what authenticated users can actually do in your network. Authorization, so authentication allows you to log in. Authorization allows you to access certain files. Are you authorized to access those files on the accounting server? Are you authorized to access those files on the sales server? Authorization gives you access to documents, to applications, to pictures, to movie files, to a database. It determines what you can do. It's permissions and access right to something. It controls the system and data access. Authorization is all about this when the system is telling you, you can access this, but you can't access that. When it comes to authorizations, keep in mind it works with permissions. Now, I showed you this earlier in the class. It's specific. What is permissions? Permissions is just rights given to people. Some of us can read files. Some of us can write to files. Some of us can delete files, open files. Permissions applies to files and folders. As administrators, we can say, Mary, you can edit that document. You can read it. You can write to it. You can open it, but Mary, you can't delete it. We could do that. We could say, Bob, you can only read it. You can't do anything else. You can open the document, but you can't add to it. You can just read it. That's permissions. And in IT security, this is vital because you don't want too much people having, for example, write access, too much people there. If they don't need it, they can corrupt the file easily. This is against the laws of integrity. Administrator accounts versus user accounts. Your administrator accounts has full system control. As an administrator, you can install programs, remove programs, you can create user accounts, you can delete user accounts, you can set permissions, you can remove permissions. Versus a user account, if you're just a normal user, you log in, you can't even install an application. You can't change any settings. The most you can do is just utilize the applications on the machine that you have access to. The administrator determines who you have access to. This separation reduces security risk in a system. Now, one model that we should be using is called the principles of least privileges. In an organization, when we create a user account, we have to ensure that they have the minimum access needed to do their job. If you work in accounts receivable, you work as an accounting department, and you work in accounts receivable, that means you send out invoice to customers and you get payments. You should have access to only the accounting server. Good. On the accounting server, should you have access to all accounting data? No. You should not have access to payroll information. You shouldn't have access to accounts payable information or banking info. All you need access to is accounts receivable, just to send and receive data. That's principles. Users gets the minimum required permissions to do their job. It reduces potential damages from breaches. Because if you think about it, if all your users have the administrator account and one of their accounts gets compromised, now compromise means like a hacker stole their data, stole their password. Now the hacker can access all of the system. You want to do a regular review of the rights on your systems. When you hear the word accountant, I want you guys to think about tracking what users are doing. We do this with log files. On a computer, we can track when you logged in, what file you accessed, when you updated it, when you closed it, we can access what you did with it, and so on. This is accounting. It's tracking and recording the user activities. Who did what and when. This is essential for security, and almost all companies that I know that has good security enables auditing on their folders. Where is this stored the audit in? In log files. These log files, you have log files in Windows. All right, let me show them to you. In Windows, we have log files. Let me just minimize all the stuff I have open. So I'm going to right click on the start button. I'm going to go to computer management. And right here I have event viewer, and here I have all the Windows logs. See this one, the security log? The security log is very big. It takes a long time to load. This security log is tracking everything I'm doing, everything I'm accessing, all the files I'm trying to read, when I logged in, when I logged out, what file I use, and so on and so on. It's a whole lot of things in here, guys. So, yes, all systems have this enabled. This records the system and user activities, login attempts, file access. It's evidence in incident investigations. So let's say there's an incident, somebody steal data, somebody corrupted data. We can then use the log files to recreate what they did. It's good for evidence in that. Now, location tracking. This is tracking where activities occur. When you go to a website, all right, that website has a log file that's tracking your IP address. So they can then say, well, your IP address is geographically located, by the way. Based on your IP address, I can tell you where you're located. So they're able to track it. A lot of applications ask you to, you ever install an app on your phone? It'll ask you, hey, can we know where you are? Can you enable our ability to track where you are? This is recording where you are. IP address, geographical data, physical location of mobile devices. Your boss, if you install certain, what's called MDM, mobile device management on your phones, your boss can even track where your phone is or where you're located. If you have an iPhone, you know you can track your iPhone, where it's located. That's an example of that also. Web browsing history. Remember something I showed you guys earlier when we were talking about web browsers. Web browsers is a record of all the websites you've been to, all the things you searched. This is useful for forensics investigation. God forbid somebody kills someone, somebody commits a crime. When the forensics investigators go, they check the web history of these users to see what they were looking for. Maybe they were searching how to dispose of a body, how to build bombs and things like that is going to be in your web browser history. Okay. Pretty big section and a good introduction to IT security. Obviously, what I just taught you there is just a little tiny taste of IT security. But we have more to come, so let's keep going. In this section of the course, we're going to be talking about security awareness. I want to talk to you guys about just being more aware of what's happening around you, with social engineering, what is phishing. How do we secure our workstations? What are some device best practices to secure a device? How about some safe browsing habits and things we want to consider when it comes to privacy? Let's get into this. The first thing I want to talk to you guys is just about being secure, just about being aware of what's happening around you. There's always going to be a bad guy trying to steal your information, manipulate your data, steal your money. So these are things that's going to happen more and more on the internet, especially now that the internet has connected us around the world. Let's have a common understanding of all the threats and risks that are out there. Recognize when there's suspicious activities that may lead to you getting compromised or your data getting compromised. And let's talk a little bit about the first line of defense against these attacks. The first line of defense is good user education. Let's get into it. The first thing I want to mention is social engineering. You see, here's what I would tell people. You can have the world's best firewalls, right? Here's a firewall. Here's a sonic wall. Expensive piece of device. Really good secure. You can have the best firewalls. You can have the best encryption. You can have the strongest passwords. You can have the best antivirus software. But if I could call up your users, let's say you work in an organization, I could call up your users and just ask them for the password or the data and they just send it to me. You don't have really good security, do you? Social engineering is manipulating people to reveal information. It exploits the psychology rather than the technology. So social engineering is calling the users and asking them for the password versus trying to break through this secure device. It bypasses all your technical controls, things like your firewalls. Social engineering is very, very effective because people are willing to help people. I think it's our nature. And hackers will utilize it in order to steal our data. One way of doing this, one social engineering method, is called phishing. Not with an F, with a P. Phishing is something we're probably all familiar with. It's when you get fraudulent emails requesting sensitive information. It appears to come from a legitimate source, and it tricks you into revealing your password. One famous way is like PayPal or banking. You may get an email from American Express or from PayPal. Hey, your account is compromised. There's a whole new transaction. Click this link to log in to PayPal. Don't click on the link, guys, because that link takes you to a fake website. When you click on that link and you put in your username and password on the fake website, it boom, steals your username and password. You won't even know. So keep that in mind. That's a phishing attack. Example, fake logins from bank accounts, urgent messages about account problems. They give you a link to some kind of malicious website. Malicious or compromised content. A lot of times you may be downloading files. People share files, especially in social media places, that are disguised to maybe look like a picture or some document you should read or some application. But they contain harmful code. They have bad data in them. They steal your information. They damage your systems. They delete your data. So these things you have to be careful with. You shouldn't be downloading anything from people you don't know, especially random people on the internet. If I don't actually know this person, if I haven't speaking to this person over the phone, I haven't met this person, I'm not downloading anything from anyone. And if I speak to you over the phone, I would have probably had to meet you or at least have to some kind of verify who you are. So it's really important to know where you're getting data from. Now, let's talk a little about securing our devices, protecting mobile devices and workstations. We'll look at multiple levels of doing this, and they're both technical and physical ways of securing your workstation. The first thing you want to do is device authentication. You should not, like this laptop. The first way we can secure our laptops is by having a username and a password on it. Put it on biometrics. Put a pin on it. Secure our phones. But that, don't just open up your phone and it just logs you in. It should be able, you should secure it with some kind of pin, some kind of password. Prevents unauthorized device use. That's number one. So when somebody wants to use your device, they have to authenticate into it. This one here, anti-malware. This is going to be like antivirus. Everybody should have on their computer. Fortunately, I hear Mac users tell me, oh, Andrew, I run a Mac. I don't need antivirus. There are tons of viruses on a Mac. I am a Mac user. I have antivirus on my Mac. Please get antivirus on your Mac. Get antivirus, obviously, for your desktop. Removes anti-malware. It does real-time scanning, regular updates for new threats or new viruses that comes out. You're going to have antivirus on your computer. That's at a minimum. Put firewalls on your computer. The computer should come with a firewall. This blocks unauthorized network connections coming in. Maybe I have a laptop here. What if I have because maybe you have another laptop, but maybe I have this laptop right here. Is another laptop that got infected, and then it tries to send this malware into my Mac. Well, my Mac has a firewall, and this firewall blocks connections coming in, so the malware cannot come in and get my laptop. Monitors incoming traffic. It could be hardware or software based. More than likely, it's a software based if it's on your Mac. If it's protecting your entire network, this is a hardware based firewall. Okay, patching and updating. A lot of times, malware gets into holes in the operating system. They find and they exploit holes in the OS. In other words, bad coding. Or Microsoft forgot to code something in the actual operating system. So what we want to do is we want to patch it. We want to update it. You should be updating your computer. I do it for my Mac. I do it on my Windows books on an automatic basis. All right, this is what I would say for users. For businesses, it's generally not automatic because we want to test all those updates. So one of, IT Security 101, keep your machines updated. There have been many publicized hacks like the Equifax hack, where Equifax, the credit agency, was hacked. So many hacks that I can think about where the big businesses was hacked because somebody didn't update a system. Somebody didn't update Windows, didn't update an application. It fixes the known vulnerabilities that are out there. Oops, where are we? Next thing up we have is physical device security. So when you are thinking about, but how can I secure my physical device, right? This one here doesn't have it, but you could do cable locks to lock down certain things. Physical device security protects against physical theft, securing devices, especially in public places. It's a part of what's called physical access control to ensure that only the right people have access to the data, to the physical devices. One way of doing this is this thing I have in this picture called a cable lock. You can see it right here. So cable locks attaches to your desktops, sometimes your laptops, and it locks on to the desk. So people just can't grab it and run away with it. This is good to have, especially if you want to just lock up your laptops. Some of these fits into laptops ports and it expands into the port so nobody can take it. That's a good way of doing it. You can do what's called USB locks. This blocks access to USB ports. Organizations do this because let's say you go work for a company and you're malicious and you put malware on a USB stick and you try to insert it into the computer, you can't. They put these things to lock the ports so people can't just connect USB devices to corporate machines. When it comes to device best practices, guys, a couple of things here you're going to want to do. Proper software management. Just don't install software that you're not sure of. Legal and security. Do you have rights to those software? And then we want to make sure that we maintain them right. Let's go through some of these things. The first thing up is licensing. It is illegal to use software you don't have access to. That's called pirating software. A license gives you the legal permission to use software. For example, Microsoft Office. You have to purchase a license to use Microsoft Office. Different models are available. And compliance, requirements, and costs. Generally, compliance is mandatory. If you're not paying for it, you're probably using it illegally. Costs can vary depending on the software itself. Now, there's two kinds of ways software is made. Open source and proprietary software. Know the difference for your exam. Open source means this. The source code of the application is free to the public to use and modify. Open source is generally free. Okay, anybody can see the source code. Whoever made it, Linux, by the whole Linux OS is open source. There are many applications that runs on Windows are open source. In other words, they're free to use and people can manipulate them and you could see the source code. So if you're a software programmer, you could manipulate the software. Proprietary software are things like Windows, Microsoft Office, Adobe. These kinds of things are generally commercialized and they come with massive restrictions. You're not allowed to see the source code. The source code is hidden by the vendor. There are different support and feature sets between them, but just remember, open source, you're free to use. Proprietary, generally you have to purchase it and you don't have access to the source code. Some of them are subscriptions. Some of them you purchase right out. For example, I have Adobe Creative Cloud. We pay on a monthly fee to all the Adobe products, Photoshop, Illustrator, Premiere, versus Microsoft Office. We did one-time payment. We bought the entire license. We own it for a very long time. You also have things that are called perpetual license. These are lifetime access. In other words, you have access to the lifetime of the actual software. When you purchase software and you're going to be installing it, they're probably going to give you a product key and a serial number. When you're installing it, they're going to ask you for the key. Like here's a Windows setup. You're going to have to put the key in. It's a unique identifier for the key itself, required for installation and activation of the software. So remember, when you buy the software, they give you the key. When you're installing it, they're going to ask you the key to install the software. Software sources. Where are you getting it from? The best place to get the software is from the manufacturers themselves. So if you're getting Windows, download it from Microsoft. You're getting Adobe, download it from Adobe. Where to obtain legitimate software from the manufacturers. Avoid malicious or counterfeit programs. Do not download counterfeit copies of any software. Why? Because those counterfeit copies contain malware within them. When you install them, you're installing the malware. Verify the authenticity, where it's coming from, before installing it. Researching and validating these sources. So check the developer. If you're going to be downloading software that you've never used before, check the reputation of the developer in the reviews. Sometimes people publish software they claim is good, but actually the software is malware stealing your data. Verify. A digital signature verifies that it came from that particular manufacturer. Compare with legitimate sources. Do you know people that use it? Are legitimate organizations saying that this software is good? OEM is the original equipment manufacturer side. The OEM is the manufacturer, basically. If you download things, get it from the OEM. Third parties and resellers generally will, for example, when you have Dell is a reseller or distributor of Windows. That's fine. Third party and resellers that are associated with the manufacturer is generally okay, not just random people. OEM sites are generally more trustworthy than third party or resellers. Application stores. Where are we going to get the applications from? You should be downloading them not from random websites. When you download apps to your phone, where are you getting them from? Are you getting them from the Play Store? That's the Android. The App Store on your Apple device, Microsoft Store, when you're downloading it to your Windows box. Where are you getting your apps from? If you're downloading it off of joeschmo.com, it's probably not the right place to download software. Make sure the stores you're downloading from is trustworthy. For example, generally speaking, Apple and Google does a good job of ensuring that the applications in the store is secure and is not full of malware. Eventually, you're going to have to remove software. You don't need it. You don't need that software. You should uninstall unwanted programs and harmful applications and programs. I can show you guys that right now. Hold on. So if I just go to Start, type in Control, we go to Programs and Features. And in here, whatever you need, you can just go and uninstall it. Maybe I don't need, and this is a lot of stuff because I've uninstalled quite a lot of things in here. Maybe I don't need this one here. Is this for my keyboard? I think that's for my keyboard. That is actually for my keyboard. So anyhow, whatever you don't need, I was going to uninstall something, but maybe I don't need WinRAR. I can just right click on it, uninstall it. Yep. Oh, took the camera. Okay. We'll continue, yes, we'll uninstall that. So this is how you would uninstall an application on there. So software removal. Eventually, you should uninstall unwanted apps, or if you find something is bogging down your system, maybe it's harmful. This is how you maintain good performance. The more apps you're running, the more things in RAM. It slows down your computer, and it helps increase storage on your machine. It actually ups your security because less software means less ability for your machine to get infected. Remember something, even if you have good software, the more software you have, the more probability that those software gets hacked and now your machine gets hacked. So the best thing to do is just remove what you're not using. Unwanted software removal. Programs no longer needed. A lot of times you bring home a computer and it comes with a whole bunch of junk. It's called junkware. And or some adware or advertising, all kinds of garbage they put. Bundle software. You know what I do? The moment I come home, I uninstall all of them. It reduces clutter. It improves performance. Malicious software. Now, malicious software is not going to be just in your control panel for you to uninstall. In fact, a lot of them are going to require specialized tools. Like, they're going to require specialized tools, for example, like antivirus or anti-malware software to be uninstalled. So keep that in mind. Sometimes you may have to do a complete system scan. Use things like Norton Internet Security, McAfee, and things like that are good antivirus to use. Software piracy. I mentioned this earlier. This is using software without the right licensing. illegal use of software. People downloading copies of Adobe products, Microsoft products, and using it on their computers. This is software privacy. More than often enough, they contain malware and backdoors into your computer. If you really like the software you're using, my recommendation is to pay the manufacturer. Let's talk a little bit about just safe browsing habits. You're browsing the internet. What are some safe things that we should be doing? Well, you know, the number one place that people get viruses from, people get infected, is while they're browsing the internet. They click on things they shouldn't be clicking on. They're not sure what they're looking at. They follow links and they just click on things. So recognize legitimate versus malicious sites. What are some indicators to look for? One of the things you should look for is a site should be secure. When a site is secure, it's going to have what's called a certificate. It's a digital credential that verifies the website is who they say they are. A certificate on a website is basically like my driver's license. Like, yeah, I tell you guys, I'm Andrew. How do you know that? Well, I showed you my license. And you're like, oh, okay, yeah, okay, he's Andrew. A certificate does the same thing. It verifies that that person is who they say they are. It encrypts the data. With a certificate, you're going to get what's called TLS, or the other one, SSL. Transport Layer Security, TLS. This enables encryption of that web page between you and Amazon. Think about this. If you go to Amazon and you purchase a product, and you type in your credit card number, you send it to Amazon. That credit card number leaves your computer from your house under your desk and goes all the way across the internet to Amazon data centers, God knows where in another state or country. It's traversing the internet. People sniff those lines all the time. Is your data encrypted? Well, if your website had an S like HTTPS, that means it had a valid certificate, you know it was Amazon, it was encrypted and it was trusted, you're okay. Certificates, and here's a copy of what a certificate would look like, is issued, all right? Valid certificates are properly issued from an authority that you trust, and they should not expire. Sometimes when you go to a website, it may say the certificate expire. I wouldn't go back to that website. It could be malicious. When they're good, there's generally a green lock in your browser. It's safe to enter sensitive information if the website has a certificate. Now, the good news is that when there's an invalid certificate, it could be because it expired, self-signed, or there's just no mismatch. The good news is the browser will give you a warning that says, hey, this certificate expired. This certificate name does not match. I wouldn't go there. I would just go away. If there's any kind of certificate error you're getting when you're browsing, go away from that website ASAP. Let's wrap this up. Let's talk a little bit about privacy. So protecting your personal data online. Understanding how that data is collected is important, and managing your privacy setting. Let's go through this. A couple of quick things here is social media. So social media, how is your data collected? By you just using it. You enter your information, you use it. You're telling the social media site, this is how I'm using the data. Profile information, your posts, your friends list, your location, what things you're watching. That's how it starts to accumulate your data. Email privacy, what you're sending, sender information. This can all be monitored. File sharing, who you're sharing your files to. Sharing history, who you gave file to. Where you're storing it. Is it in the cloud? Instant messaging, what's your chat history? Who are you chatting with? What's the status? You need to make sure that you have good encryption here also. Now, the last thing we want to talk about here is privacy, is AI consideration. A lot of people are typing into chatbots like ChatGPT, things about them. This type of data is being used to train the AI system. Never give personal information to your AI systems because you're training it with your data and you're revealing potential personal data to the AI chatbots. AI-generated content and privacy is going to become a big topic because I want you guys to remember something about the AI generation. These systems are storing large amounts of data on you. The more you give it, the more it knows. While that's something that may or may not be a good thing, it could be a bad thing because now it has all of your information. This is something that should be, in my opinion, not be done. Don't ever share private information with randomized system, because God knows what OpenAI or Google with the Gemini or Meta and their AI systems, who knows what they're going to be doing with your data. Do you trust OpenAI with your private information? I certainly don't. So keep in mind, don't share private information with any chatbots is what I'm trying to tell you. Things to consider. Okay, quite a lot of things here to keep you secure. Make sure to follow them so we can at least use the internet securely. In this section of the course, we're going to be taking a look at password management. All of these things here are going to be done in order to keep you secure. One of the most, onto today, the most common way to authenticate to websites, your own computer, to devices, is going to be with a password and or PIN. And in this section, I want to go over some terms you want to understand about passwords. Before I do that, I want to show you guys in Windows where you can actually find this. So I want to show you guys something. So I have, I'm going to show you guys what is called an MMC console. All right, MMC console or Microsoft Management Consoles are administrative tools we use to manage Windows. And I'm going to show you guys how to open it and show you where these policies are. This is not a course for that, but just to give you a hands-on aspect of how you can do it. So to do this, I'm going to click on a little start button here. And you're going to type RUN. Just type run. So you can open up a little run box. Type in the box MMC or Microsoft Management Console. Yeah, you got to click on. It's going to prompt you. It's the user access control. I'm now going to add a snap-in. I'm going to say file. We got to add what we want to manage into our console. A snap-in is the component of Windows we want to manage. I'm going to scroll down here and I'm going to select Group Policy. Group Policy, its name is Group Policy Object Editor. I'm going to add that in here. Local computer is fine. I'm going to say OK. And this is the local computer policy. This is the policy that runs Windows. I'm going to open this up, computer configuration. We're going to go to Windows settings, security settings, account policies, password policies. And this is where you find all this, like maximum password age, minimum password length. So you can go in here and it says, hey, you got to have at least 8 characters in your password. Does the password have to meet complexity? I can enable it. So people just can't have password as their password. So these are 2 settings I would always enable. I could say the maximum they can keep a password. Right now it's 42 days. After that, they have to change it. Password history. Right now it's set at 0. Password history means that it remembers passwords. We'll talk more about this in a second. But it's from here where you can set all your password policies. And that brings me back to this. So as you can see, we can set this in Windows. Now, in large corporations, we're going to set this across all the devices by taking that policy and applying it to all the computers, utilizing a Windows server. That I'll show you how to do in a whole nother certification. But for now, let's talk about passwords. Password best practices. Guys, complex passwords, don't reuse passwords, change your password on a consistent basis is the essential of security. Why? Because, well, like I said, many things are still done with password. Protect accounts and sensitive data, reduces the risk of unauthorized access. Password length. So passwords, depending on what you read, at a minimum, we used to say 8 characters. Now it's, some people say 10, some people say 12. I have 10 to 16 characters is recommended. The longer the passwords, the more secure. Each additional character increases that security exponentially. You see, in theory, every password is crackable. Every password. They just have to guess the complexity of the password. They have to guess your password. They can try every combination known to mankind, and eventually they'll guess your password. So the more characters you have, the harder is it for someone to guess your password. There is an attack on password we call a brute force attack. So a brute force attack is when they try every combination, every word and characters and letters for your password. The bigger your password, the more complex it is, makes it harder for a brute force to work. The next thing here is length versus security. 8 characters is nowadays is pretty easily cracked. Computing power has gone more and more stronger. The faster our computing power, the faster we can crack passwords, guys. 10 plus characters, much stronger. You can also use passphases, can both be long and memorable. One of my passphases that I used to use many years ago was I like chocolate cake. Try cracking that password, and I used to put my weight at the end. So it's a giant password. The longer the password is, the more complex it is. That would be an example of a passphrase. Easy to remember, but also very strong. The other thing you have is password complexity. Notice I enabled it. Password complexity forces users to use uppercase, lowercase numbers, and symbols in the password. This avoids dictionary words and common patterns. There is a password attack, we call it dictionary attack. Basically, it runs the dictionary against the prompt, or it runs the dictionary against the login screen. If your password is car, it'll log it in like that. If your password is anything in a dictionary, like that. So by enabling password complexity, now you're not utilizing dictionary words. Here's some complex password. This is weak. This is just the word password 123. It's a common dictionary word, and it has repeated numbers, like consecutive numbers. This is stronger. I don't know what that is, but that is pretty strong. This is a passphrase that's very well written. Coffee morning at 7 a.m. Notice long, uppercase, symbols, and numbers. I like this password. Not bad. You want to do password history. This prevents reuse in recent passwords. People love doing that. People, the system will prompt them to change their password, and they'll just use the same password. So they have the same password like forever. With password history, you can say 12, and that way it'll remember 12 of your previous passwords. So you can't keep reusing it. You would have to keep changing your password to a new password on a consistent basis. So the system remembers previous password, forces the creation of a whole new password. The benefits here: prevents cycling through just a few passwords, enforces the password change. 5 to 12, I do 12. I do 12 on the history. Typical requirements, 5 to 24 previous passwords, it remembers. Expiration. Depending on the organization you work for, they expire the passwords 30 days, 60 days. We do 60 days. 90 days is common. Forces people to create new passwords. And because if you enable complexity and history, they got to create a complex password, and they can't reuse the older passwords. Expiration. Passwords should expire 60 days, 90 days. You don't want too frequent changes, because too frequent changes causes weak password. If people have to change the password on a consistent basis, they tend to create weak passwords. There's balanced security with usability. Modern trends towards less frequent expiration. Right now, there's a trend moving towards, hey, we don't want to have too much change in 60, 90 days. Password reuse. Do not reuse the same passwords on multiple sites. Okay, especially banking sites. Now, I'm guilty. Crappy sites that I don't really care about that I have to log in, I probably use the same password on all of them. But any site that has my credit card, any site that has my personal data, any site that I'm like a, if you ever follow me on YouTube, you realize I'm like a social person, pretty prominent person in my industry. Anything that has any type of important data with me, it's different passwords for every single site. And I'm going to show you why I do it. My passwords are super long and super complex, and they're pretty much all different across almost all my websites, except crappy sites that I don't care about. Reusing a password is a major security risk, because if they compromise one website, they can then use that password and log across all the confidential websites that you may access. A lot of people do this. A lot of people has one password, generally, technically, hopefully a good one, that they keep reusing on all the websites. Never do that. When you reuse risk, it's a single password breach. Every website goes through some kind of breach. A lot of vendors are getting breached and the data is getting stolen. Credential surfing attacks, credential stuffing attacks can happen, in which case they're trying same username and passwords across multiple sites, and it's difficult to track when your things are going to be affected. As you saw earlier in this course, guys, I use LastPass. There's also KeePass. These are password managers. This is software that stores and generates passwords for you. It's a unique password for every account. It encrypts the storage with a master password. When you use a software like LastPass, like I have, this creates passwords and it stores passwords. I don't remember passwords. You ask me the password to my bank, it's like something this big. It's crazy. I don't know it. That's why you have a password manager to help you manage your password. Creates the password, updates the password, stores it for you, and types it back for you. I do have one giant master password that I use to get into the password manager. It generates strong random password. It autofills the logins. You only need to remember your master password, and this gives me access to everything that I need access to. Password privacy. Keeping your password confidential. Guys, comments, don't share your password with others. Shoulder surfing. So, you got your phone. I've done this with my kids. I've watched them. I've stand over their shoulders. They open their phone, and they type in their PIN. They don't know I'm watching them over their shoulder, and I see the PIN. That's called shoulder surfing. This is a legitimate attack that people do. So password privacy, how do you protect it? You can put a privacy screen on your phone. I'm not sure if you guys know what those are. Those are the screens you put on that only at a certain angle you can see the screen. Being aware of your surrounding, keeping your password confidential. Don't share it with anyone. Now, some privacy thing. Don't write your password on paper. I've seen people write passwords on sticky notes and stick it to the monitor. Don't do that. Don't have a file on your desktop called passwords that you store everything. Some people that did this too. They have a file on their desktop called passwords. And in that file, they have all the websites and passwords. Get a password manager. Don't share via email. Email is a plain text. Email is never really encrypted. Okay, don't share through text messages or anything like that. A lot of times when you have a password, there's going to be a reset process. What is that? Well, that's a secure way to recover forgotten passwords. A lot of websites do this. You forgot your password. Well, what are you going to do? Well, what you're going to do is you're going to reset it. The way to reset your password is they're probably going to send you an email, or they're going to send you text messages, an SMS to your phone with a little code or a question, and you're going to have to answer it. Sometimes it asks you like a security question like, what was your mother's middle name, to reset your password. This is common in today's world to recover forgotten passwords. Reset best practices. Use alternative contact. That's good to use. Choose strong security questions. Depending on how public you are. I don't do security questions because I'm a pretty public person, a little bit. So I don't do this because sometimes I talk about myself. And sometimes people know things about you. So use strong security questions that no one would know. And always update information regularly. Default password. So when you use devices, different devices has different default passwords. A lot of devices, like you buy like this Sonic wall, admin was the username, password was admin. Okay? They have default credentials on them that are publicly known. You have to replace the default credentials on here. This is the first step, especially in securing devices. Back in the days, a lot of wireless routers used to come with the password, username, admin, password is admin or password. So you could just click on people's Wi-Fi and just put in the word password or admin and boom, you're logged in. This is changing though. So this is what's called default credential. Credential being the username and a password. They're highly known. They're easily found in manuals and online. They're common targets. They leave you completely vulnerable. You must change the default credentials. Enable a password. Activate a password on them. Now, there's certain devices out there that you should do this on. You should enable passwords on your phone. Enable passwords on certain devices if it has it. Required for accounts and devices out there. often disabled by default. Sometimes these devices comes and the passwords are just disabled. You should enable them. For example, your BIOS has a password. You should enable a password in there. Set up a lock screen for your device. Some application supports this on your router. Actually, like my Sonic Wall there, it's a firewall. But your router, your admin password, you should enable a password on those accounts. There's a lot of devices that are out there that has a username and maybe does not have a password and people just log into it. You don't want that. You want to make sure that if it has a password to enable it, because unfortunately, guys, we still use passwords around the world. So make sure your passwords are secure and you're using it well. In this section, we're going to talk about one of my most favorite topics to talk about. This is actually true. I teach a giant section on encryption in my Security Plus. If you have my Security Plus, check it out. Or my CISSP. I am very, very knowledgeable in this topic. And I want to make it a little fun and interesting for you guys to see. So today we'll talk a little bit about what is plain text versus ciphertext. We'll talk about why you should be encrypting at file, disk, and you better be encrypting your mobile devices. And where do we use some of these encryption? Email, right? You should be encrypting your email, your web pages, your VPN, and of course your mobile apps. Let's get into it. The first thing I want to talk about is encryption. Encryption is about converting readable data into unreadable format. All right, and then you can then decrypt it. So encryption is taking what's called plain text, text that you can read. It encrypts it, and then you get ciphertext, text that is not readable. Then you can decrypt it by taking the ciphertext, turn it back into the plain text. This protects information from unauthorized access. As data is traversing the internet, you're going to have ciphertext. You don't want your data traversing the internet in plain text. So we have to encrypt it. This is essential for all modern day systems. So plain text I mentioned is readable versus ciphertext is the encrypted data. Let me show you guys a pretty interesting that I have here. So I went to Google and I typed plain text to ciphertext online just for demonstration purposes of you guys to show you guys what it looks like. I'm going to just use the first link and I'm going to erase this and I'm going to type in our plain text. I will study, can't spell, study and pass my exam. Okay, this is the plain text. Notice readable. And this is the ciphertext. And this is done with an encryption algorithm called Caesar Cipher. Take my Security Plus. I'll teach you more about how this works. It's actually pretty easy to work. And it has a variety of other things here we can use in order to encrypt our data. This I'm not going to go into. We'll keep this for another class. But this is plain text, human readable, versus ciphertext, generally unreadable. Now, encryption is when we convert this plain text to this ciphertext. So we always want to make sure data, as it's traversing the internet, stays in this ciphertext. Anybody sniffing the line or gain access to ciphertext doesn't mean anything because hopefully they cannot decrypt that data. Now, the encryption process takes the plain text and it does it with what's called an encryption key. It utilizes what's called a key. It utilizes an algorithm that generates a key that's used to encrypt the data. The decryption reverses this. Only authorized parties should have the key to decrypt the data. Now, data, before we come in here, I want to talk about data states. Data lies in three states. Data at rest, that means it's stored on this phone right now, stored on this hard drive. Data in use, that means you have the file open and you're adding things to like a document. Data in transit, data is being traversed in a network. So encryption is basically affects two things. Data at rest. So when your data is on this hard drive and your data is on your phone, and phone is turned off, you're not using it, your data should be secure. That's data at rest. It's encrypted. Data in motion or traversing in transit should be encrypted. As data, your username and password your credit card information left Amazon and it's traversing the internet back to your computer, or maybe from your computer to Amazon, that traversing in motion should be encrypted, right? It should be ciphertext. The one that, in this section, we're going to talk about data at rest, data in use. We're not going to talk about data, we're going to talk about data at rest and data in transit. We're not going to talk about data in use because technically speaking, data in use, data is not encrypted. For data to be used, it has to be decrypted. You can't use encrypted data. No one can really read it. So when we're talking about encryption, we're actually talking about data at rest and data in transit. Remember that for your exam, okay? So we're talking about data at rest here. This is information stored on a system. It could be a file, it could be a database, it could be a picture, a movie, a backup. They're vulnerable when storage is compromised. So, for example, I have data on this hard drive. If you were to steal this hard drive and plug it in, you can steal all the data. Unless I encrypted it, then it's all ciphertext. And unless you have the key, you cannot decrypt this data. Protection at rest. You want to encrypt it when the data is stored. Even if the device is hacked or stolen, like my phone, it's protected at multiple levels. Now, file level encryption. I showed you guys earlier in the course how to do encrypting a file on your desktop. That was known as file level encryption. It encrypts individual files or folders, protects sensitive data. The users, you choose what to encrypt. You encrypt that folder, you encrypt that file. File level benefits, good control, good protection, easy to share encrypted files because it's just a file. It doesn't really affect system performance too much, by the way. Now, you can do, Microsoft has something called BitLocker encryption. The BitLocker encryption encrypts the entire drive. You'll encrypt the entire hard drive. It encrypts an entire hard drive to protect all data on the drives. Transparent to users and applications. People don't even know it's encrypted. You should also be doing mobile device encryption. Almost all your phones have this turned on by default, by the way, on the newer devices. It protects phones and tablets built into modern. This is essential. There's somebody ever steal your phone and try to take out the memories out of it and try to take the data out of the memory, the chips on these devices, they wouldn't have access to it. The benefits: protects your personal data and your business data, prevents access if the device is lost. It's required by generally corporate policies to do this, by the way. Now, data in transit. This is data I mentioned moving between systems, moving from your computer to the Amazon web server. Network communications and files. It's a network and the data is traversing it. Anybody that intercepts it can read this data. Transit protection. So you want to encrypt this data as it's traversing the network. Encryption secures the data while moving the data. It prevents eavesdropping and tampering of this information. It creates a secure channel between you and Amazon. So it secures data while it's moving, going across, leaving your computer to Amazon. It prevents eavesdropping as people listening and seeing the data. Eavesdropping means listening, so they can grab and steal the data, and they can't tamper with it. Good encryption can detect if the data was tampered with. Email protection. This protects email messages. End-to-end encryption. Email by default is not encrypted. Never, ever, ever send secure things through an email. Social security numbers, credit card information, never do it. Make sure if you are, there are things you can use to encrypt your email. And if you did, you will know. Just standardly sending an email is not encrypted. You have to ensure it has end-to-end encryption to prevent unauthorized reading of your email. Some things that does this is use the SMIME or the PGP, pretty good privacy. That's actually what it means. Protocol to do this. You don't have to know that for your exam. I just put it in there. Transport encryption. Server to server, end-to-end, server to recipient. So when you do an email encryption, you could have it set up where it's just the email server to email server is encrypted. The problem with transport encryption is from the client machine to the email server, it's not encrypted. If the email server is within the organizations, maybe it's fine. You want end-to-end encryption. From the sender's computer to the receiver's computer, it's fully encrypted. That way, anybody sniffing the data, anybody traversing the network will not see it. Never ever visit a website that does not support HTTPS. This is a secure web browser that ensures data is encrypted between your browser on your computer and that email server. Generally, you'll find a lock icon on it. This ensures that, you know what, it's protecting your login credentials, your online transactions like your credit card and your addresses, prevents website from being spoofed. Now, let's talk VPN. Virtual Private Network. What is it? Virtual Private Network is when you are at home and you're given a specific piece of software, you install it on your computer, and you can connect to your workplace in a virtual network. It sets up a virtual network over the internet between your computer at home and your workplace machine. Obviously, if you're at home and you're accessing all your workplace information coming from the workplace to your machine, it better be encrypted, because I'm pretty sure all that data you're accessing from your workplace is confidential data. So VPN encryption creates an encrypted tunnel through the internet, hides all the network monitor, hides activity from network monitor. So anybody monitoring the internet or monitoring the network can see the confidential data that you're taking and sending to your company utilizing a virtual private network. People do this for remote work. If you are on a public Wi-Fi, make sure that you're using a VPN to connect to anywhere else. Everybody is connected to a public Wi-Fi. When you join a public Wi-Fi, you can sniff everybody's data. You could eavesdrop on everybody's data. Unless they're using some kind of encryption, you'll be able to see what they're doing. Geographic content access, which means you can access things from around the world. Now, mobile application encryption. This protects application data. A lot of the applications we have in here already comes with full encryption. They're built into the application development framework. Banking app, healthcare apps has a lot of confidential data. You want to make sure that this kind of information is secure. User data and preferences, payment information, healthcare and fitness. Think about, I have an app on my phone that I can read, like my blood results. Those types of apps should have good encryption on it. Even apps that we use to communicate with should have good encryption on it. All right, encryption is a fun topic. It is a very complicated topic. But for your exam, just understand that encryption is, to me, is IT Security 101. You don't have encryption, you don't have security. When people think IT security, they're probably thinking encryption anyhow. This is a good introduction to it. Let's keep going in the course. If you enjoy it, study IT security. It's the best part of IT. Andrew from the future. If you're enjoying this course so far, once again, if you would like to get the course notes, the presentation I'm using, you would like to get practice questions, and just watch it without, I'm pretty sure YouTube is going to put a lot of ads. If you would like that, don't forget to check out the links below. My website, TIAexams.com. You can get this course for just $9.99, the price of basically 2 cups of Starbucks. And you can also, I think this is also going to be on the Udemy platform if you have that also. You can get the course notes, you can get practice exams with it. Let's keep going in the course. In this video, we're going to take a look at how to secure your wireless network. Now, this is not an in-depth lecture on this, but it's some things that you should know when it comes to securing a wireless network. You can't talk security without talking about wireless security, because all of us are basically connected to our networks wirelessly. Before I start this though, I'm going to show you a quick demo that you can practice yourself if you want to see how to configure devices like this. So when you have a device like this, you purchase a wireless router or access point, I'm going to show you just a quick demo of how you can configure this thing. Let's do that before we get in here. So let's go here. We're going to type ASUS router demo. Now, I showed you guys this earlier. Let's type it again, ASUS router demo. Let's go configure this router that they have here. So I'm going to go here. I actually use ASUS router, by the way. I'm going to go down here to wireless. And you can see that right now, the security on it. You notice the authentication method and the name. So the first thing I want to point out is the network name. This is the SSID. This is what it is named. You notice how by default it's named ASUS? I would just put the company name there. Don't leave the technology as the company name. That's not good security. Some companies do hide the SID. Now, you notice right here, so that's important. The other thing I want to mention here is going to be the security setting. You notice how this one supports WPA2. We'll talk about these things coming up. WPA3, all right? So you can choose. You also have open. Don't ever do that. That means that and we'll talk about it in the exam objectives. That means anybody can connect to your Wi-Fi. There's no password. You just click on it and boom, they're connected. I don't know why you would ever enable that. Maybe some kind of public access thing you're running. I don't know. You have WPA2. You have WPA3. All right. When you select the WPA, you would then put in the key. Make sure the key is long and secure. We'll talk about that. So when somebody connects to the network, they're going to have to notice kind of what's called a pre-shared key. If they have it, they'll be able to connect to the network. So that's going to be what we need to know when you're setting up your wireless network. Oh, you know what I forgot to show you? When I said ASUS, if you're joining me now, when I'm talking about ASUS routers, wireless routers, I'm talking like one of these devices, more like this type of device. They all basically run the same operating system. That demo was a publicly accessible demo of what the operating system looks like for your information. Let's go here right now and talk about some wireless thing. Let's talk about changing that SSID, that service set identifier, SSID, changing that default password and talking about what encryption we should use right off the bat. Use WPA2 at a minimum. If you have 3 and you have devices that supports it, use that also. So let's get into this. The first thing up is wireless network security. This protects your Wi-Fi from unauthorized access. If your wireless network has a password, then anybody can just connect it, use your wireless to get internet. But more importantly, if somebody is connected into your wireless network, they can sniff and see all of your traffic that you have out of your machine that's not encrypted. So you want to make sure that you don't have unauthorized access. It's a security layer in the setting. It's essential for home and small offices to do this correctly. The first thing we want to talk about is changing the SID. Change the SID. Don't leave the default names. You remember the default name on that router was ASUS? That tells you who the manufacturer is. You don't want that because then hackers know who manufactured your router and then they can use that to find vulnerabilities and hack your wireless network. Use a custom name. For example, if you're in a company, you may want to use the company name. Best practices, don't put personal information in the name. Don't include the router model like that one had. Choose non-obvious network names. Don't call it Citibank secret Wi-Fi, right? Choose things that is non-obvious. Remember, if a hacker is looking to break into your network, and your name is Andy, if you name it Andy's Wi-Fi, the hacker will know, okay, that's Andy right there. Best benefits, guys, hides router type from attackers, all right? Don't put the router name. Reduces targeted attacks. Don't just use your name on there. Makes the network less obvious. Change the default password. You notice the default password on this one was 123456778. Replace that default admin password. Make it something complex. It prevents unauthorized router access. This is the first step in router security. It doesn't matter what authentication protocol, encryption protocol you're using, WPA 1, 2, or 3. If your password is 123456778, it kind of defeats the purpose of your encryption. So what you want to do is you want to make sure that that default password is secure. All right? Default passwords are published in manuals. They're common targets. They leave your network completely vulnerable because if people can just guess it, they can just log in. Use strong, complex password. Make it different from network access passwords. Change regularly. So the network access, that's the password you're going to use to access your resources or your user accounts. Don't make it the same for your wireless router also. Now, when you get onto your wireless network, you want to make sure it's all encrypted. You want to make sure the wireless traffic is all encrypted. Surrounding me right now is tons of wireless traffic all over the place. If I put on a wireless sniffer, I can capture all of the traffic. Now, is it all encrypted? I'm pretty sure it is. This is a business builder. So, encrypted is password protected networks. Unencrypted is the open access. Remember on the ASUS, I could have selected that. Encryption prevents people from eavesdropping or listening on your traffic. It's important because it protects the data transmission. As the data is traversed and people can't listen to your data, it prevents unauthorized access to your network. People can't get in there. It's required for, especially if you have sensitive data. Never do this. I don't know, unless you're running some kind of free public Wi-Fi for the world to use, never have open network. There's no password. People just click it and boom, they connect. All traffic is visible. Maybe for a guest, even on a guest network, I wouldn't do this. On a guest network, what I would do on a guest network is I am going to put a password and put signs up. Here at TIA, in our online in-person training, we own a medical school. We have a guest network. We have signs, hey, use this password to access it. So it's just our people. Again, I don't know really where you would put this. The other one here we have is open network risks. Anyone can connect. This is not having a password again. Not having a password again. People can easily connect, easily intercept. A lot of malicious people can connect to your network and use it to do malicious thing, and then you're going to get blamed for it. If you have an open wireless, I can go and I can hack companies and steal stuff, and then the cops are going to show up at your door because it was coming from your IP address. The other thing you have is what's called a pre-shared key. This is a password that share amongst users. It's the same password for all devices. Simple but not secure. At home is what you're going to use this for. In big organizations, you're not going to have this. In big organizations, they're going to use something called, beyond the scope of this course, but I'll just mention it, called a radius server, where they're going to use, you're using them in passwords and your user credentials to log into the Wi-Fi. But at home, pre-shared key, it's the same password for all devices. As long as they have the key, they can log in. What you want to do is you want to make sure that it is distributed to only folks that needs it. Changing the password affects all the devices. It's suitable for your home networks. For your business networks, it's probably not the best thing. Now, WPA stands for Wi-Fi Protected Access. Okay? WPA, when wireless first came out, there was a wireless encryption called WEP, Wired Equivalency Protection. That thing was hacked in like a few weeks it was out. After that, they created something called WPA. WPA is a really old standard. It's the first generation of real Wi-Fi security standards. It's not very good. It's been cracked also. They are cracking softwares that does it. So it's better than an open Wi-Fi. Our ASUS router didn't even support this thing. It's so old. The next gen, by the way, limitations, vulnerable to certain attacks, user older encryption, is replaced by newer standards. The next one is WPA2. This is the most widely supported standard, and it is still considered strong. It's the second generation of Wi-Fi security. Almost every router and device out there supports this. Most of us, me at home, I'm running this. I got some older devices out there. Now, good here, it's AES. AES is the Advanced Encryption Standard. It is the standards of encryption that we have today. Almost every piece of data that is ever traversing the internet today is encrypted with AES. It's widely compatible with devices. It's a good balance of security and compatibility because almost every device made in the last 15 years is compatible with WPA2. The new standard is WPA3, the latest one. It's the strongest available, but it's not very, you don't have a lot of devices with it yet. So it improves resistance to attacks. It's more resistant. It's stronger than WPA2. Enhanced protection. It's protection against password attacks. It has a very good protection against that. It's better security for all the different devices that are connected, like your fridge and your toaster and your watch and your car and all that. So it does have some pretty good advantages, but there's some consideration. Number one, you need newer devices. WPA3, yes, is better than WPA2 but do you have the devices for it? Not every device supports it. It may not work with older equipment. The adaptation to WPA3 is coming out, and as more newer devices come out, they support WPA3. Recommendations. Well, the best thing right now is WPA3 with a nice strong password. If that's not feasible and all your devices doesn't support it, the thing is when you go into the routing, you put WPA3. Every device that connects has to support that. If it doesn't, they're not going to be able to connect. Then go with WPA2. Every device can in today's world. WPA3 is just one step above open networks. I wouldn't have that in there. Okay, that concluded this section on the entire IT security. Guys, if you enjoyed this entire section, consider moving up into the IT security. We need folks like you to join us in IT security, especially folks that are really knowledgeable and have a passion for IT. Check it out. It's where I work. I think it's the best part of security. So hopefully you guys enjoyed this section of the course.